Hi guys, how are you? How are you all? As promised, I am back with my IOQM English lectures. I promised you that we will be starting, and the geometry section is being taken care by SPS sir, and I will be taking your number theory classes. So, like I said, this course is applicable for all the aspirants who are not so comfortable in Hindi. So, today we are going to start number theory. Number theory is perhaps the most important and most non-routine thing which is being asked by IOQM authorities. Why it is non-routine? Because if you see geometry is largely covered in NCERT. The higher level of NCERT problems are being asked. This is one. Second, if I talk about algebra is basically JEE, right? JEE algebra is being asked in IOQM. Combinatorics is completely JEE permutation and combination. I am talking about only IOQM level. When we talk about RMO level, there are many non-routine things like pigeonhole principle, right? There are many advanced theorems also in inequalities. There are many advanced theorems. But when I talk about only IOQM, number theory stands out. Number theory stands out as the most non-routine thing, right? And in number theory, largely our concern will be integers, right? And there are many basic principles about integers, right? There are many basic principles, basic properties, basic operations. So we can add integers. If you add two integers, you get integer. If you multiply two integers, you get integers. If you subtract two integers, you get integers. But when you divide integer, there are many possibilities. Either it is perfectly divisible, then you get integer. Otherwise, you can get rational numbers. Okay. And then the concept of quotient and remainder. So divisibility is something which is very important in integers, and that is what we are going to study in this particular lecture. We are going to start with congruence of integers. The prerequisite for this lecture is basically 9th-10th level of mathematics, in which classification of integers, classification of numbers is included. You must be knowing about what are prime numbers, what are integers, what are real numbers, what are irrational numbers, what are rational numbers. You should be aware about these things. This is one. Second, you should be aware about Euclid division lemma. Obviously, I will start with Euclid division lemma first. So this is what the priority is. Okay. So can we start, guys? Sir, Nimbus batch students will note it in their usual classroom copy. No, you have to maintain your separate IOQM copy. There you have to basically study. Yeah, like take notes. And guys, this is my humble request to each one of you. My humble request to each one of you. Please, if you are preparing for IOQM, prepare with full rigor. Whatever you do it with full rigor. What is full rigor? You do this lecture, you do the homework. I will assign you some homework after this. So the homework will be from my book, right? So basically, I'll tell you, the homework will be Know Your Progress 3 and Know Your Progress 4. This is the homework after today's lecture. Okay, this is the homework after today's lecture. Okay, I am already giving you the homework. So you should make your own notes, you should do your own homework, and then possibly you should also revise and give the test. IUQM test series, NSEHSS test series has already been announced to all of you. Please try to give the test. Okay, can we start, guys? Can we start? Like I said, in months of December and January, I have already covered the prerequisites. I have already covered the basics. So today I am going to start from the IOQM level, and the theory of IOQM number theory and RMO number theory is the same. So whatever I teach you, it will be sufficient till RMO level. Okay, okay, right? At the like you can subscribe to this Telegram channel so that you get each and every information. Perfect. So now I am going to start with congruence of integer. What is congruence of integer? What is divisibility basically? Right? When I talk about divisibility, there is a simple concept, there is a simple theorem which comes into our mind. Euclid division lemma. It is a lemma rather, right? So what is the statement of it, right? The statement is, when you divide, A is divisor, B is dividend, and when you satisfy this situation, that your remainder is 0, 1, 2 to A minus 1. When you satisfy this situation, you get a unique value of quotient. For example, if I am taking A to be 4 and B to be 10, so what am I doing? I am essentially dividing 10 by 4. So if I write 10 here, 4, and I have to make sure that my remainder is less than my divisor. So just imagine if I write it like this. This is wrong because my remainder is coming out to be more than the divisor. But when I write it like this and the remainder situation is satisfied, then I'm good to go. This is where I have to expand my mind, right? I have to expand my mind. Why I have to stop at positive numbers? I can see everything is positive here. Every single thing is positive. Why? Who said this thing? So this is where the IOQM things start. What if I write it as 4 times 3 minus 2? The equation is correct. Is minus 2 the remainder? No. Remainders are always non-negative. You have to remember this thing. Whenever you are asked remainder, remainders are always non-negative. Okay. What do I mean by non-negative? Basically, whole numbers. It's a fancy word for whole numbers, right? It is a fancy word for whole numbers. I hope the sound is clear. Perfect. So 0 to A minus 1. Just a second. Where should I keep it? I think I should keep it here. Let me increase the sound. Yes, I have increased the sound. I think the sound was very clear because I am very loud. Okay, perfect. So the remainder is 0 to A minus 1, but all these statements are correct. Now this 10, there is something about this 10, of this 6, this 2, this minus 2. So in congruency, basically what happens, we convert this. You see, like the quotients are changing. The quotient is 1, 2, 3 based on the value which you are taking here. So we write this equation as 10 is congruent to 6 mod 4. So how do you read it? Right? It is another way of saying that 10 and 6 leaves same remainder when you divide them by 4. What is the remainder when 10 is divided by 4? 2. What is the remainder when 6 is divided by 4? 2. So 2 is something which is common to 10 and 6. But obviously the choice of divisor is very important. The choice of divisor is very important. Please take a note of this thing. The choice of divisor is very important. The divisor is 4. That is why 10 and 6 are congruent. But if you write 10 is congruent to 6 mod 5, then it is incorrect. This is correct, this is incorrect. Why this is incorrect? Because when you divide 6 by 5, the remainder is 1. When you divide 10 by 5, the remainder is 0. So they are not leaving the same remainder. Modular means if I am writing A congruent to B mod D, this means A and B leaves the same remainder upon division by D. Am I making sense? Sir, what about Nimbus batch students? They can attend this live. All my Nimbus batch students are from the boards which treasure English teaching. Okay. Now, what about this? My 10 is congruent to 2 as well. And since these two are congruent, I would say 10 congruent to 6 congruent to 2. And it is congruent to negative integer also. You can extend this logic as much as you can. You can extend this logic as much as you can. Ruchi is saying, sir, I brought pre-college mathematics. It is good. See, like the major problem about like the book selection which you do, it is a great book. I agree. This is a great book. But just imagine that you have an allergy, right? Just imagine this situation. You have an allergy and you want a citrazine tablet, right? Now, citrazine tablet is slightly costlier than a paracetamol tablet, right? Now, since paracetamol is cheaper, many people take paracetamol in every health condition that they have. If they have fatigue, they take paracetamol. If they have headache, they take paracetamol. If they have running nose, they take paracetamol, right? But in running nose, in allergy situation, if you take citrazine, it gives you instant action. So this is an example. So what I'm trying to say here is pre-college mathematics book is cheaper than my book, IOQM book, but it is for RMO. It will not necessarily help you in basically IOQM. My book is designed for IOQM. So if you want to properly study for IOQM, then my book is a must have for you. Okay. See, it is already in the my new book is already in the market. The new book which we have released, it has IUQM 2024 paper solved in it already. See, I don't trust you now. So much syllabus is there, but in playlist, so less videos. Format and combinatorics and all. I have taught everything. Everything is available on YouTube. You can see. Just search format theorem Prashant Jain. You will get the video. See, it is your laziness. See, you are blaming somebody else for your own laziness. You are lazy that you are not studying these particular things from YouTube. If you want to see, if you are dedicated, everything is available on YouTube. My everything of related to IUQM is available. If a JEE learner says this, I would agree, because I have not taught class 12th on YouTube for JEE. But for IUQM, I have taught everything. Right? Where is mod in last line? Mod is, so see, like this is mod 4, right? This is assumed. So usually the mod is given in the situation. Everywhere I won't be writing mod. You have to assume basis the context. Okay. It is in the playlist also. It will be updated. It will be updated. So like if you are talking about the IOQM 2025 playlist, you will see videos coming from this week in which like there will be 4 or 5 hours of video and everything will be covered in that. Okay. So I hope you noted that down. So let's do few examples. Right? You have to say true or false. You have to say true or false. Okay. So 29 congruent to 2 mod 9. True or false? True or false? True or false? Ayansh is saying false. Pranchu is saying true. Sayak is saying true. I think it is true, Ro. It is true. And then we will write another important thing. The very simple hack to see if these two are leaving the same remainder. First of all, this is a very simple equation, right? You could have divided 29 with 9. 2 is the remainder. So this is precisely the definition of congruence. But the hack is, if it is given, it implies D divides A minus B. This is a very important thing. If A is congruent to B, mod D, then D divides A minus B. Right? And it has a very simple proof. Just imagine A to be dq1 plus R and B is dq2 plus R. Subtract them. A minus B is equal to D times q1 minus q2. Now this is the definition of divisibility. This means D is divisor of A minus B. D divides A minus B. It is evident from this example. Am I making sense? Am I making sense? The beauty about mathematics as a subject is you can prove each and everything, unless they are axioms, obviously. So you cannot prove SEHSS, right? Because it is an axiom. But using SEHSS, congruency, you can prove triple S, you can prove ASA, right? Right? I hope I am making sense. So this is first question. And you have to write all these things. Whatever I am writing on the board, you have to write. Second, 29 is congruent to 2 mod 9, right? This was the first example. 19 is congruent to 5 mod 11. Right? Now this is a lengthier example. This is a slightly lengthier example. Sayak is saying false. Vishaka is saying true. Pranchu again is saying true. Ayansh is saying true. Fang is saying true. Right? Now, see, with this short trick, you should have done it. Right? One very simple way to do it is like this. Okay. Then this. Right? But this is a lengthier version. Let me tell you the smaller version. As per this, my 11 should divide this, which is 1914. Now, you must have remembered the divisibility rule of 11. Sum of digits at odd places, sum of digits at even places. Their subtraction should be divisible by 11, which is the case here. And hence, 11 divides 1919 minus 5, which means 1919 is congruent to 5 mod 11. Right? Right? 1919 is congruent to 5 mod 11. I hope I am making sense. I hope I am making sense, guys. Yes, I have forgiven you. Don't worry. I just wanted to. I've just see, like, it is my simple request. Like, see, like, concepts like these, which are very very advanced. There are very limited people who teach this, right? Like, I am there, VOS is there, like OW is there, right? We are very few people who are teaching these things, right? And when we listen to these things, that sir, like, I will not trust you, then I somehow lose motivation to teach all these things, right? Your love is the only motivation. I'm teaching all these things, right? You can imagine. And that to IOQM English, I think I'm the only one who is teaching IOQM in English language, right? So please keep on supporting us. That is what my request is. Third, now the third problem. We will do the third problem. Right? 5, 4, 3, 6, 2 congruent to R mod 9. Right? It is given. Find least positive R. Find least positive R. Right? Let's do it, guys. Guys, can you please like the video as well? I can see 33 people watching it live, but the likes are only 19. Yes. 3. Vishaka is saying 2. Now, again, I will actually do it using the divisibility rule of 9. So what is it? 5, 4, 3, 6, 2. 5 plus 4 is 9. 9 plus 9 is 9 plus 2. right? So it's giving me 20. Okay. Now, what should I add here so that it becomes, or rather, what should I subtract to make it divisible by 9? Minus 2, right? So, I have seen that this should be divisible by 9. So, my R has to be 2, comparing these two things. Comparing these two things. In fact, you can write for any number, Sn denotes number of digits, sum of digits of n, sum of digits of n, then Sn is congruent to n mod 9. See, you can tell me honestly if you have been able to understand this or not. If you have understood it, then you must have a proof of this in your mind. If you are not being able to understand it, then you can clearly tell me so that I can prove it in the next page. But before next page, please write it down. Write each and everything. Yes, but there are many teachers who teach us about IOQM. Yeah, I have mentioned them. I have mentioned VOS, I have mentioned OW. I have mentioned these things. These are very good friends of mine, right? They are very good friends of mine. Okay, Sanvi. Okay, you want proof. So this is very important. This is the beauty of mathematics, right? Everything you can prove. Like I said, except for the axioms. Okay, perfect. Now let n be a 5-digit number. I am taking it as a 5-digit number. And when I am writing like this, the base is assumed to be 10. Right? What do I mean by base? Your n will be 10 to the power 4a plus 10 to the power 3b plus 10 to the power 2c plus 10 to the power 1d plus 10 in fact e. Right? Right? Now just imagine, just remember in fact that you have to prove this. So you have to generate sum of digits somewhere, right? So if I write it like this, I think everybody is aligned with this. Nobody has any problem with this. Nobody should have any problem with this either. Nobody should have any problem with this too. And yeah, nothing here. So what do I have here? I have sum of digits. And if you see this number, this is divisible by 9. And this is precisely the definition of congruency. N is congruent to Sn mod 9. I hope I am making sense. I hope I am making sense. OW is PW only. OW is PW only. Right? Sir, if we start preparing for IOQM from very basics now, can we crack an Olympiad? Can we crack and qualify for RMO? Also, any plan? I have already given you the plan. I have already given you the roadmap. I will again come up with a plan. If you want to start from the basic, what all topics you can study, what all topics you can prepare. But it is my humble request that if you do not have 2 to 3 hours daily for IOQM, do not go for it. IOQM examination is perhaps one of the most enjoyable journey. I consider it to be very enjoyable, very rewarding. Like I have seen learners enjoying the art of problem solving in IUQM. But for many people who are after certificates, who are after achievements rather than true joy of mathematics, they find it very difficult to crack IUQM, because IUQM can be very punishing as well. How come it is punishing? because the level of problems will be too tough. Yes, we can crack JEE. JEE, if you see, majority of the toppers have like they have always qualified for IOQM. Right? Perfect. Let me move on. So SN. Now let's do one problem on this. Let's do one problem on this. Right? Let's do one problem on this. But will we be able to do it? Let A SA is equal to 7, where A is a 3-digit number. Right? Find all possible values of S A plus 3. SA is sum of digits of A. You have to find out all possible values of S of A plus 3. If you are watching this problem very carefully, this is a problem adapted from a problem which was asked in IOQM 2024. Sir, when are you going to start IOQM Hindi? IOQM Hindi will be in recorded format. It will come very, very soon. I already declared in one of the videos. Yeah, the videos will come very, very soon. This week or maybe next week. Sir, when you and Abhay sir will collaborate, we have already collaborated. If you see, we are together in our mission to teach non-routine mathematics. We are always together, right? We are very good friends. We share our knowledge with each other. Yes, but my book is written in such a manner that it is self-explanatory. You can see sufficient amount of examples, you can see sufficient amount of problems, and every solution is given also. Sayak is saying 1. There is only one possible value. So let me give you the example of what this problem is saying, right? Please listen to this very, very carefully. Since my sum of digit is 7 only, I cannot have more than 6 here. My digit here will be less than equal to 6. You have to understand it properly. Right? You have to understand it properly that the maximum digit which I can have here is 6, since it is my 3-digit number. Now, since your maximum digit is 6, if you add 3, there is no carry here. If you see, there is no carry. So, if it is PQ6, so P plus Q plus 6, P plus Q, and I can say this to be R. P plus Q plus R is 7. So, this will be PQ, and here you can see R plus 3, since there is no carry. So, the sum of digit here is P plus Q plus R plus 3. Since this is 7, the only possible value is 10. Right? The only possible value is 10. There is no point studying for divisibility rule of 17. There is no point in studying divisibility rule of 17. Can you please see this? Am I making sense? The value of sum of digits of A plus 3 is only 10. Now, how can it be different? Let me give you an example. Just imagine my S of A is 19. right? My S of A is 19. So just see this number, 991 plus 3 is 994. In this case, my S of A would have been 22. But if my number is this and then I add 3, the sum becomes 922 and my sum of digits becomes 13. Are you getting my point? Are you getting my point? Are you getting my point or not? Right? So you can see there are two possibilities of S of A plus 3. S of A plus 3. But having said that, these two will be congruent to 9. These two will be congruent to 9. Okay? 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 Clear? So this is the basic understanding. Like I said, number theory is mostly about how you analyze addition, subtraction, multiplication and division with respect to natural numbers. So see, this is a very simple concept, right? That since sum of digits is 7, you cannot have more than 6 here. And since you cannot have more than 6 here, if you add 3, there will be no carry. So these two digits will remain the same. So if my original sum was P plus Q plus R is equal to 7, my this digit will be R plus 3 and my new sum will be P plus Q plus R plus 3. Now P plus Q plus R was 7, so 7 plus 3 is 10. Very simple, right? 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 I hope you are getting it. I hope you are getting it. And similarly, in the example, when there are multiple possibilities for sum of digit, like I illustrated here, 991 plus 3 is 994, here the sum of digit is coming out to be 22. In the next illustration, the sum of digit is coming out to be 30. But what is the common here? 22 and 13 are congruent to like 22 and 13 are congruent mod 9. I hope you are understanding the importance of modular arithmetic. I hope you are understanding the concept. So if SA is 8, then it would have different values. Yes. This is precisely my point. This is precisely my point. This is precisely my point. Okay. Okay. Now, there is one more thing here. I think you all know about this. You should actually. Do you know about this identity? A to the power n minus b to the power n is a minus b. A to the power n minus 1 plus a to the power n minus 2b plus a to the power n minus 3b square. Right? 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 Everybody knows about it. Now, if so, basically, see, like the whole point of like making it right here is to simply write that a minus b divides a to the power n minus b to the power n. Right? A to the power n a minus b divides a to the power n minus b to the power n. MB Devada, there is no batch of IOQM on the plus subscription. It is available in Olympiad Gold. It is a paid thing, right? So you do not get access to the IOQM batch, the paid IOQM batch, right? Perfect. So A minus B divides A to the power n minus B to the power. Everybody knows about it. Everybody knows about it. Okay. Done. Please write DN. Please write DN in the chat so that we both are in the same page. All of us are on the same page. Please write it down. Please write it down. Okay, perfect. Now a minus b divides a to the power n minus b to the power n. There is one more way to see it. If you see, let's assume there is a polynomial px, which is x to the power n minus b to the power n, right? Now if I write pb, I get b to the power n minus b to the power n equals 0, which essentially means that according to factor theorem, x minus b divides x to the power n minus b to the power n, which is precisely my point here, which is precisely my point. This is one more way to see it. This is one more way to see it. What I'm trying to imply here is, and what I'm trying to connect here is, this is a polynomial thing, this is a number thing. So you can relate polynomial with numbers. I hope I am making my point clear. Now, sir, why this is important? Why this is important? This is important in deriving a very important theorem in congruence, which says if A is congruent to B, mod D, it implies A to the power n is congruent to B to the power n mod D. N belongs to natural number, right? Now let me prove it for you, and then you can possibly write it. Since A minus B, A is congruent to D, it means D divides A minus B. Now A minus B already divides A to the power n minus B to the power n as per this identity. This means, see, there is a you know about transitivity in divisibility, right? That if A divides B, B divides C, it implies A divides C, right? You know this, I hope. So all these things were covered in basics of algebra. So with these two, I can say D divides A to the power n minus B to the power n, which essentially means A to the power n minus B to the power n is congruent to 0 mod D, which again essentially means A to the power n is congruent to B to the power n mod D. This is a very important theorem, and the problems related to remainders come from this theorem. I hope I am able to tell you this thing very, very clearly. Should I watch? See, like, if every Nimbus learner, if you are preparing for IOQM, then this is for you. Manu, there is no 5th edition. The latest is 4th edition. Refurbished copy of 4th edition is already in the market. It has 2024 problems. IOQM 2024 problems are there. Yes, Satsang, it can be done. Done. The level of problems in my book is very hard, and then you are thinking, so basically this is precisely the point. If you are preparing for 100-meter race, you prepare to sprint for 150 meters. That is how you maintain your peak pace at the 100-meter point. This is the whole algorithm, right? Am I making sense? Perfect. Perfect. So let's do this. Let's do this. Just a second. Yes, yes. So let's do some problem in this. Let's do some problem, right? What is? Let me show you how to solve this. Find remainder when 8 to the power n is divided by 7. 8 to the power n, and you can write n to be 2025. Since we are studying in 2025, you can assume n to be 2025. Sir, if we are not being able to do the problems, then we feel so much demotivation. Like I said, IOQM can be a very punishing journey, right? But the fruits are immense. If you are in 9th, 10th and you are preparing for IOQM, once I told the learners that if you are getting 0 marks after appearing in IOQM, then you are already a winner, because at least you had the guts to be among those 1.5 lakh learners who actually attempted IOQM, right? There are many people who simply do not attempt IOQM because it is too tough. And just imagine, if you get 10 marks, you have the chances of getting selected in majority of the states, right? Any tip for first timers? Start with the basic lectures. Start with 9th and 10th. Complete your 9th and 10th first properly, and then jump on to IOQ. Okay. Now, how do I do it? How do I do it? Right? It's a very seemingly very simple thing, but how do we do it? 8 to the power 2025 is divided by 7. How do we study? How do we do this? This is very interesting. Solution. Let's write the solution. Find remainder when 8 to the power 2025 is divided by 7. What is the remainder? Everybody is saying, sir, 1 is the remainder. 1 is the remainder. Okay. Now, how do I solve it? If I write it as 7 plus 1 to the power 2025, right? In fact, I won't do this. Let me solve it very, very simply. Can I write it as 2 to the power 6075? 2 to the power 6075, right? Now, my 2 to the power 1 is congruent to 2 mod 7. Just remember, what is 2 to the power 1? 2 to the power 1 is 2. And what is remainder when 2 is divided by 7? It is simply 2. Simply 2 to the power 2 is 4. What is 2 to the power 3? It is 8, which is actually congruent to 1. This means you have 2 to the power 3 congruent to 1. This means you have 8 congruent to 1, right? Mod 7. See, like I could have written this as first step. I know I could have written this as first step. But just for the sake of explaining, I am writing it, because usually you won't get this easy problem. This is just for the illustration purpose. Now, by our theorem, 8 to the power n is congruent to 1 to the power n mod 7. And what is 1 to the power n? It is 1 only, which gives me 1 as remainder. Okay. 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 Please tell me this. Please tell me this. Right? Our aim is to get plus minus 1 in remainder in congruency, so that we can increase the powers. We can increase the exponent. We can increase the exponent. What I'm trying to do here is, first of all, you write this and then I'll be able to explain you. Then I'll explain you this. Sir, we can also use EDL. Yes, Pranshuja, but that is the thing. In the majority of the problems that we do, After this, we'll not be able to use EDL, right? Right? EDL is Euclid division lemma, right? Now, what do I mean by this? I will explain this using an example in the next page. My example is very simple. My example is very simple. Find remainder when 2 to the power 42 is divided by 11. 11. 2 to the power 42 is divided by 11. Right? 2 to the power 42 is divided by 11. Hamad is saying 9. Now, how do I proceed? How do I proceed? See, my every first step will be this. 2 to the power 1 is congruent to 2. 2 to the power 2 is congruent to 4. 2 to the power 3 is congruent to 8. 2 to the power 4 is congruent to 16. 16. But 16 is congruent to 5. Because see, like I always have to write it in terms of remainders. Okay. Now, 2 to the power 5 is 32 basically, right? 32, if you see, is congruent to 10. Now, this is where the fun begins. Can I write 10 congruent to minus 1? This is precisely my point. Either I have to generate 1 here or minus 1. This is basically our pursuit. We are pursuing plus 1 or minus 1. Okay. Now, let's do this. 2 to the power 5 is congruent to minus 1. This means 2 to the power 40 is to the power 8, right? Minus 1 to the power 8, which essentially means 1. So 2 to the power 40 is congruent to 1. 2 to the power 2 is congruent to 4. So if you multiply these two, this also gets multiplied. So 2 to the power 42 is congruent to 4 mod 11. Mod 11. Okay. Got it? 2 to the power 42 is congruent to 4 mod 11. Yeah, we have a paid IOQM course. Ramanujan is the link. You can go for the first link and pay for 1 year subscription, and then you'll be able to attend the classes. Now let's see. There is another theorem coming here now. If A is congruent to B, it implies, and C is congruent to D, this implies AC is congruent to BD. This is applicable in addition also. You can simply prove them using Euclid division lemma. These are very trivial solutions. These are very trivial theorems. Okay. This is important. And then if A is congruent to B, it implies KA is congruent to KB mod D. If you multiply by same number, the remainder does not change. Okay. Okay. Sir, can you give level wise like you do in class? Can you give level wise like you do in class? I don't get you, Pranshu. Sir will give better for other topics as well. Yes. What is the hardest chapter in IOQM syllabus? I consider number theory to be the hardest. And that is why I am teaching it. That is why I am teaching it. Okay, that is why I am teaching it. We will do all the PYQs. We will do all the PYQs. After completing this, I am going to take PYQ session. And like your 2 chapters are going on simultaneously, right? If you see, we are conducting 2 classes of IOQM English. One is recorded by SPS sir on Saturdays. Every Saturday you are getting a lecture. My lecture you will get every Wednesday 4 to 6 p.m. How does number theory beat PNC? PNC is very easy topic once you understand it. But with number theory, even if you understand it, you will not be able to get it. This is the problem. How to see -1 is congruent. So this is experience. All these observations come from attending the classes like these. That is why you need classes. You cannot study for examinations like IOQM through any book. Books are always complementary to a particular lecture. This is that lecture. What is going to be the next topic after this arithmetic of remainder? See, like number theory is going to be very big thing. So congruence of integers is first. Then we are going to talk about HCF and LCM. Then we are going to talk about what do I call it? Diophantine equations. Diophantine, and like this. So like it is planned like this, right? See, like if you are targeting JEE 2027 batch, you can go for the Nimbus batch. Nimbus batch is a very good batch. Okay, let's do it now. Let's do another problem. Find remainder when 1919 upon 1919 is divided by 11. You would not believe, but this question is JEE Main 2025. It was asked in the April attempt. I solved it live merely 7 days back. So it is as per my book. Logarithms is something which I covered, right? Right? Sir, can you please give harder questions in other concepts also? Please, like new one, I have already watched your previous videos. Yes. Like obviously so these are tough IOQM lectures only. Hamad is saying 9. Now, first of all, see, what I was doing here is power jumping. We call it power jumping. So from power 1 to, I jump to 2, I jump to 3, I jump to 4, I jump to 5, and then from 5 to 40. Now, power jumping is only possible when you can calculate the powers, right? And you cannot calculate the powers for numbers as big as 1919. So first of all, I would say 1919 is congruent to 5 mod 11, right? This is what we have studied already. Right? We just did this. Now 1919 to the power 1919 is congruent to 5 to the power 1919, which means I have to deal with this. Okay. Which means I have to deal with this, right? 5 to the power 1919. 5 to the power 1919. Okay. 5 to the power 1919. Okay. Now, again, if you do properly, 5 to the power 1 is congruent to 5. 5 to the power 2 is congruent to 3. because it is congruent to 25. 5 to the power 4 is congruent to 9, right? 5 to the power congruent is 2. Okay, 5 to the power 5 is congruent to 45, which is congruent to 1. So you got it. You got it. 5 to the power 5 is congruent to 1. Mod 11. Okay. This gives me 5 to the power, since it is multiple of 5, 1915 is congruent to 1. 5 to the power 4 is congruent to 9. If I simply multiply these two, I get 5 to the power 1919 is congruent to 9, which was also congruent to 1919, congruent to 1919. So my answer is 9. My answer essentially is 9. Right? Sir, Pathfinder. I have already given you the homework from my book. It is Know Your Progress 3, Know Your Progress 4. Right? If you are referring to Pathfinder Senior, then you can simply go to congruence of integers. This is the first topic which they have taught. Yes, by 15th of August, we will complete the syllabus with recordings and with basically with recordings and with new lectures. We will complete it. I am slow, but get the answers. See, like time will not be the challenge in IOQM. Believe me, if you are able to complete 12 problems correctly, then you are through. Right? Time is not the problem. See, every year I change my questions. Every year I change my problems. Obviously, I would not have given this problem last year because this problem is asked in JEE Main 2025. So every year I update my content. Okay. So this is basically, like, these are basics of congruence. Now there is something called cancellation law. Cancellation law. Right? If you see HCF of A, B is D. Right? A, B is D and A is congruent to B mod KD, then actually, right, so A is DP, B is DQ, right? So you can write DP is congruent to DQ mod KD. KD is some number, and then you can cut it like this. This is the left cancellation law, mod K. So what I'm trying to say here is, if you are given like this, you cannot simply write, you can not simply delete K like this. This is wrong. This is wrong. And what is the proof of this? Very simple. A is basically DP is equal to KDQ plus R. DQ is congruent to KDQ1 Q2 plus R. Right? So then if you subtract it, DP minus DQ, you get KD Q1 minus Q2. You can cut D here. So you can see P minus Q is equal to K times Q1 minus Q2. So these are congruent mod K, not KD. So your divisor is also changing with respect to the cancellation. Okay? 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 Am I making absolute sense, guys? Am I making absolute sense here? right? Perfect. Let's go for one more problem now. Now that you have understood this, find remainder when 2 to the power 202 is divided by 18. Now I am giving you random divisors. Let's see if you are able to do it. Sir, I guess it is 16, right? Now, first of all, you have to make it co-prime. This is the first step. So what I'm trying to do here is solution. Just see, 2 to the power 202 is equals to 18q. Now, since this is even, your remainder will be even. But remember, your remainder is 2r. Now you can cut one number. Can I write it like this? Now I can solve this problem. Can I say my 2 to the power 3 is congruent to minus 1 mod 9? Because now I have to solve it mod 9. 2 to the power 3 is 8. 8 is congruent to minus 1. 2 to the power 201, since this is a multiple of 3, minus 1 to the power 67, which is congruent to minus 1 mod 9. Now you can imagine this thing. The remainder cannot be negative, which means 2 to the power 201 is congruent to 8 mod 9. Okay. Okay. Which essentially gives me r to be 8. Now my original remainder was 2r. This gives me 2r as 60, which is my final answer. So very good, Hamad. Very good, Hamad. RST, I got AIR 467 in JEE Advanced by your guidance. Thank you, thank you. Ankit Raj, there are many options. He is saying, sir, you do not teach well. There are many options. Go for it. Adarsh, sir, can we complete syllabus with just one class in week? See, that is the point. You are not understanding it. We have already taken the basic lectures. Your geometry sessions, your geometry lectures are going on Saturday. I am taking number theory, and I have asked Dhairya ma'am, Dhairya Sandhyana ma'am, who was AIR 29. She will be taking the algebra part. So together we'll complete it by 15th of November. Right? Perfect. Yes, AIR 29. Now, another lecture. Let me do another lecture. Let me do another problem. Remainder, last remainder problem. Then we will move forward. Right? Then we will move forward. Just a second. Find all values of n so that 16 to the power n minus 1 is divisible by just a sec, divisible by 45, where n is a two-digit number. N is a two-digit number. Please tell me. Sir, what about IOQM recorded course? When it will resume? It will be resumed this week. It will resume this week. Sir, but when school start, how to manage? Because I am in a batch of my school where they teach 11th and 12th syllabus in 8, 9, 10 only, and in 7th we did 8, 9, 10 NCRT and we revise on first month. See, like that is what you have to manage, right? I cannot comment on this. So whenever you get time, you can see these recordings. I don't understand, but what is so fuzz about doing JEE mathematics syllabus by 10th end? It is not required at all. Majority of the toppers complete their JEE syllabus by September, October of their 12th class. There is no need to rush, because you should maintain curiosity. Curiosity is the most important thing in JEE preparation, right? If you are not curious enough in class 12th, if you do not have anything new to study in class 12th, you will get bored. And when the boredom kicks in, believe me, you will not be able to get out of it. My suggestion is never complete your JEE syllabus before 12th. If you are doing it by the start of 12th, it is good. Okay. Now see, like, what is the problem here? First of all, my first observation number 1, 16 minus 1 divides 16 to the power n minus 1, right? Which means 15 is already a factor of 16 to the power n minus 1. So, if I ensure that 9 divides 16 to the power n minus 1, then I am done. Okay. Am I making sense here, guys? Then I am done. If 9 divides 16 to the power n minus 1, then I am done. Okay. Because it is already divisible by 5. This is how the divisibility rule works. Am I making sense, guys? Am I making sense? Hindi recorded lectures will resume very soon. It will be time stamped. It will resume very soon. Right? Right? So this means I have to take n such that 2 to the power 4n is congruent to 1. Now let's solve this. 2 to the power 8, 2 to the power 3 is congruent to minus 1. You see, like, you have to make sure that this is multiple of 4. Mod 9, we have already studied this. So 2 to the power 12 power 4 is congruent to 1. Mod 9. So this is the least multiple of 4. This is the least multiple of 4 which is divisible by 1, which gives essentially 1 as remainder upon division by 9. Right? So it is the smallest power which is multiple of 4, and gives me 1 as the remainder. Now, if I take any power of it, it will give me 1 as remainder. This means my n has to be multiple of 12. This means my n has to be a multiple of 12, which essentially gives me 12, 24, 96. 8 values. 8 values. Am I making sense here, guys? Am I making sense here? Now you were saying, sir, 15 is also the answer. Let's check it. First of all, 16 to the power 15 is nothing but, oh, I am asked, okay, got it. Oh, got it. We are asked, it is actually, you have to write it as 2 to the power 12k, but then it is, since my n is on the power of 16, so it is 16 to the power 3k, which hence you are correct. You are saying 12, 15, 18, this is correct, because it is power 3k only. So you are correct. 12, 15, 18. So how many of these numbers are there? Till 99. So then, to calculate number of these numbers, you just have to divide it by 3. You get 4, 5, 6 till 33, and then the ninja technique kicks in. 33 minus 4 plus 1. 30. 30 is the total possible values. Right? Indrajit, sir, I am IOQM aspirant. I don't have any knowledge of number theory. So then you have to see, like, if you have completed 9th, 10th, which means you thoroughly know Euclid division lemma. It is sufficient to start this. If you see the initial of this lecture, I have started with Euclid division lemma only. Yes, it is of the form 3q. It is of the form 3q. Right? Am I making sense, guys? Am I making sense? And actually, you could have done it like this also. Just imagine 16 to the power 3q, just to verify. Right? This gives me 4096 to the power q minus 1. 4095 divides 4096 minus 1. Right? Right? And what is 4095? 4095 is nothing but 45 times 91. Can you check it? Can you check it? This is 45 times 91. So it is divisible by 45. So 45 divides 4095, which means 45 divides this also. I don't have any opinion about our competitors. By the same reason, they don't have any opinion about us. Right? If you ask them, they'll not say anything. So I will also not say anything. Hi Utsab. Right? Sir, one more query. I am currently learning geometry from your course, but I am unable to solve several questions. So, like, Shaurya, you have to go for the solved examples. Very good, Sayak. This is reality of West Bengal. West Bengal is a very tough market to be in. Now, let's do another problem of divisibility. Find numbers of the type A, B, 4, sorry, 4a, 2b, 5, which are divisible by 5, which are divisible by 7. These are 5-digit numbers. So basically you have to find a and b so that these numbers are divisible by 7. How do you approach these problems? Right? How do you approach this problem? (11 minus a minus b or a plus b minus 11 is divisible by 7 or either 0. Do this then. Do this. Do this. By breaking number. Very good. I don't think it is easy problem. I don't think it is easy problem. I don't believe that it is an easy problem. Easy problem. So like this was 2 marker in IOQM 2018, but this will now, as per the new level, it will be 3 marker of IOQM. IOQM solution. Right? First of all, I will write it as like this. I will write it like this. You have to understand this. Plus 10b. Right? Now, if I see this number is congruent to. What is it congruent to? Mod 7. 5, 52, 49, 30, 28, 25. It is congruent to 4. 1000A is congruent to minus A. You can check it because 1001. 7 divides 1001. Right? So it will be congruent to minus A, and similarly 10b is congruent to 3b. Right? So can I say that 40, so this particular number, this number 4a 2b5 is congruent to 3b minus a plus 4 mod 7. Can I say it like this? Can you please confirm? Can you please confirm? See, like, what is the use of this? See, if you do not get the correct answer, if you do not see, like, if after claiming that this is an easy problem, and if your answer is incorrect, then your judgment is very bad. You will accept this, right? 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 Perfect. Perfect. Now, this means can I say that this can be equal to 7? If I solve it, I get 3b minus a equals 3, right? So this gives me 1 0 1 0. A and B are digits. You have to accept this thing, right? 2 3 3 6 49. Only 4 cases here. 4 cases, right? In this particular example. Then 3b minus a plus 4 is equal to 14. This gives me 3b minus a equals 10. Now obviously b cannot be 2 or 3 here. When I take b equal to 4, this becomes 2. 5, 5, 6, 8, 7, no 7, 6, 8. 3 cases here. Then 3b minus a plus 4 equals 21. This gives me 3b minus a equals 17. Now my b is 6, 1, 7, 4, 8, 7, 9, not 9, right? 24. So 3 cases here. Then 3b minus a plus 4 equals 28. 3b minus a equals 24. A equals 8. This is 0, 9, 3. Right? 2 cases here. And let me take the last case. 3b minus a equals to 31. No cases here. So 2 plus 3 plus 3. This is 8. 8 plus 4. 12 cases. 12 cases. 12 cases is the answer. 12 cases is the answer. Right? Sir, how did you get 3b minus a plus 4 equals 7? See, like, basically, if this is divisible by 7, so you want to have this remainder to be 0. Oh, I actually, no. Actually, I did not solve for this. The remainder can be 0 as well, right? So if I take b 0 here, this gives me a equal to 4. If I take b 1 here, then my a becomes 7. If my bus, these two. So in total 14 cases. 14 cases is the correct answer. 14 cases is the correct answer. I forgot to take this one case. Yes. Yes. Right? So Arnav Raheja, what I was saying here is that this has to be congruent to 0, which means this has to be a multiple of 7. So I have taken all the possible values of multiple of 7, that is 0, that is 7, that is 14, that is 21, that is 28, that is 35. In 35 case, I am not getting anything. Right? Sir, should Ramanujan batch students study this? No. Everything will be covered in Ramanujan batch. It's a paid batch. Obviously, paid batches are always superior to the YouTube batch. In everywhere. This is the case everywhere. Na? It is not the case only with an academy. Got it. Sir, 2a plus 3b is congruent to 1 mod 7. What is Ramanujan batch price? 999. Sorry, 9999. This is the batch price of IOQM Ramanujan. Perfect. Good. Now, I think you have understood about the divisor. Now, let's talk about HCF. Let's talk about HCF. Find maximum HCF of numbers 3n minus 25 and 129 minus n. N belongs to natural number. Find possible value of n. Yeah, Abhimanyu is Ramanujan student. After discount, I am telling you the price. Sir, should I study this or Hindi recorded? 31. 31. You are saying 31. 1 2 181 362. I'm asking about the maximum. I am asking about the maximum. Done. 2. Hopefully 2. The maximum HCF. Maximum HCF is 2. So, see, like, the amazing thing here is when you take n, see, 3n minus 25 plus 3 times 129 minus n. Your HCF will divide this, right? So HCF will divide, if you see here, this becomes 387. 387 minus 25, and 3 gets cancelled. So H divides 362. Now you have to understand here that n is less than 129. So your HCF will also be less than 129, right? Right? So what are the possible values of HCF? Let's divide. HCF will divide 362. So basically 362, 181, and then I think 181 is prime. I think 181 is prime. I've never seen 181 in anyone's table, in any table, right? 181 is prime. Okay. So the maximum value is 2. Maximum value is 2. Okay. The maximum value is 2. Can I say this? Can I say this? Can I say this? Please tell me. Can I say this? Can I say this? 181 cannot be the value. See, and it has to be less than 127. So this number is less than 129, right? So 181 is anyway not possible. Am I making sense, guys? Sayak, are you understanding it? Why H divide? This is a very important point. See, the theorem is if HCF of A and B is H, then H divides PA plus QB for PQ belongs to integer. How do I prove it? Since AB, HCF of A and B is H, A can be written as Hindustan Petroleum, B can be written as headquarters, HQ, where HCF of P and Q is 1. Otherwise, H will not be the HCF, right? I should not use P and Q because P and Q are already mentioned here. So HU B is HV, where HCF of U and V is 1. Right? Now, if I talk about PA and QB is equal to PAU plus PHU, A is HU, plus QHV. Now, can you see that H is coming out to be common? This means H divides PA plus QB. Am I making sense here? Please write this down. This is a very important theorem. Remember, this is the nomenclature for HCF and this is the nomenclature for LCM. Right? Right? And what we know is H into L is equals to A into B. A and B are natural numbers here. We can also call them positive integers, but this is how it is, right? And there are two important properties which you should remember. First, HCF obviously divides LCM. HCF obviously divides LCM. Second, HCF divides PA plus QB, where P and Q are integers, right? P and Q are integers. This is a very important property. But now we are going to use these two, HCF and LCM, to determine basically the solution of simultaneous congruence. The end result of today's lecture is what we call Chinese remainder theorem as well. We will be solving simultaneous congruences, right? So I am going to start with a very basic thing, right? Let us do some problems in HCF LCM first. Okay, HCF LCM first. Question number 1, right? Find minimum number which leaves 3 as remainder upon division by 7 and 8 as remainder upon division by 12. So this is the question. Find minimum number which leaves 3 as remainder upon division by 7 and 8 as remainder upon division by 12. Right? Please guide how to study from CT-PCM. First of all, see, like CT-PCM is a RMO book. So first of all, you have to acquire the skills required to study any such books. All the RMO and INMO books have prerequisites, right? Even if you are following Pathfinder Senior, which is of Vikas Tiwari sir, so you have to do it. You have to follow these lectures first, get to the IOQM level and then attempt those problems. Yes, Ansh, you are not eligible for IOQM. Dropper learners are not eligible for IOQM. They are, however, eligible for ISI. Yes, there can be some printing errors. Okay, Chaitanya Singh is saying the answer is 31, sir. Let me check. Let me check the answer. So now, first of all, I will write it in terms of congruence, right? This n is leaving what remainder? 3 as remainder mod 7, right? Mod 7, it is leaving 3 as remainder. Similarly, it is leaving 8 as remainder mod 12. Now, do you see that 7 minus 3 is equal to 12 minus 8? This is something which you have to observe. All these properties are written in my book also, but you have to observe these. This 7 and these 3. So like, see, like you had this as a given number, this as a given number, this as a given number, this as a given number. You have to make sense of these numbers. This is called number sense. So 7 and 3, 12 and 8, the difference are same, which means if I add 4, n plus 4 is actually congruent to 7, which is actually equal to 2 mod 7. right? Similarly, n plus 4 is congruent to 0 mod 12. Okay. So this says that n 7 and 12 divides n plus 4. Now, what is the minimum number? What is the minimum number which is divisible by two numbers? Their LCM. LCM means least common multiple, right? So these are certain applications of LCM and HCF. This is how we use them, right? 7 and 12. So what is this means? N plus 4 is 84, which is the LCM, and your n becomes 80. N becomes 80. Okay. Okay. I hope I am making sense. Please write done. If you have understood it, please write done. And also, if you are seeing the recordings, you can leave the comments. I am very much motivated by the comments which you leave. And literally, I read all the comments on Olympiad Corner. I do not read comments in my JEE videos, but I definitely read comments, because I believe that this is a very small and very amazing community that we have built over the years. In last 5 years, we have grown from 0 subscribers to 71K subscribers approximately. Right? And this is your hard work and obviously team effort of my team as well. I have been teaching on this channel consistently for last 5 years. This is I think this is a record in itself. Right? Okay, perfect. 71K, and we are going to celebrate it. We are going to celebrate it. Can I prepare for ISI from your lectures in 1 year? Yes, you can do it. Okay. Now let's focus on one more problem. Let me give you one more problem of LCM and HCF. Right? This is a problem which is a repeat of which is repeat of another problem. But before that, actually, we should solve simultaneous congruence also. Let us solve simultaneous congruence. Right? Solve for x congruent to 2 mod 3, x congruent to 1 mod 5. Right? Right? Let's solve. Now, since many of you have not studied AP, it is actually equivalent to finding common terms in AP. How? Finding common terms in AP. Right? This is equivalent to finding common terms in AP. Right? X is congruent to 2 mod 3. Right? Let me give you a solution. You can pause the video and then you can solve it. If I write the solution of it, x is congruent to 2 mod 3. This means x satisfy this. It is 2, it is 5, it is 8, it is 11, it is 14, it is 17, and so on. Now, if you see x here, 1 mod 5 means 1, 6, 11, 16, 21, 26. If I write it, now let's see the beauty of it. Let's see the beauty of it. Can you see that 11 is the first common term? After that, you have to hop 5. 1, 2, 3, 4, 5. 5 in this, because the common difference was 3. But you are actually finding the common term between this and this. Here the common difference is 5. What is common difference? Difference between the consecutive terms. Here common difference is 3. You are hopping 5 times here and you are hopping only 3 times here. Are you understanding the correlation? The common difference here was 3, but you are hopping 3 times here. The common difference here is 5. You are hopping 5 times here. Right? And your next term becomes 26. The difference is 15, which is not a coincidence. 15 is actually LCM of these two. The LCM of 3 and 5 is actually 15. Right? So your common terms, this is the common solution. Now can I say that all these numbers are of the type 15q plus 11? And the way to write it is, the way to combine these congruences is this. You write x is congruent to 11 mod 50. Am I making sense to you guys? Am I making absolute sense? Anuj, I believe, gave the answer before I wrote. This is how you solve simultaneous congruence. You can write the heading simultaneous congruence. Simultaneous congruence. You can write this heading. You can write this heading. Sir, I finished class 9 maths and starting 10. I also finished all the available English lectures. So should I start Hindi lecture? Also bought your book today. Okay. This can be done by CRT. This is CRT. You are using CRT without actually naming it. And this is what I do every year. I do not like using Chinese, right? I'm teaching basically the theory, Ansh. What is CRT? You don't have to remember. Believe me, you don't have to remember. For you, CRT should be cathode ray tube, right? Cathode ray tube. It is a chemistry concept. We do not use CRT in mathematics. Okay? Okay? Perfect. So should we solve next problem? If you can write done, then I can move on to the next topic. Next question rather. I want you to solve one of the problem for me. Right? Okay? Perfect. Question. Solve simultaneous congruence. X is congruent to 0 mod 3. X is congruent to 2 mod 5. X is congruent to 9 mod 11. Right? Let's solve this. Solve the simultaneous congruence. Right? See, if you are asked find the minimum natural number, then you get a IOQM question. If you are asked to find all the numbers, then you have to reply in congruence terms. Right? So see, like the answer is always x is congruent to something mod LCM of these three. So the LCM is 165. If you can see, LCM is 165. Okay. So you have to find this bracket. Sir, in your book it is done in some table form. How to reach IOQM level? See, like IOQM level is a very high level. First of all, it is above JEE Advanced, above JEE Main, which means you require a complete year of preparation. So Sarthak, ask yourself this question: have you diligently prepared for 1 year? Have you seen, even if you are a free learner, have you seen my 109 lectures of IOQM? Have you completely solved my book? If these two things are done, then you can say that, sir, I have achieved IOQM level. IOQM level is not an easy level to achieve. It is the path of champions. Every year I say this thing. It is the path of champions. Not everybody can walk on it. Siddesh, like by practice. So there are 100 odd problems of sequence and series in last 4 years. Sir, in your book it is done in some table form. So we'll do that. 165 Q plus 42. In which NCRT there is this topic? Get over NCRT. This is beyond NCRT. This is beyond JEE Main. This is beyond JEE Advanced. This is something which is very huge. Even if you want to know in which NCRT this is, it is not in NCRT. It is in a CBSE book called Applied Mathematics. I have written a book on applied mathematics also. It is for CUET. So in applied mathematics, you get the topic number theory. Right? Logarithm you have to study from my recorded lectures. You can find logarithm Prashant Jain. You will find the lectures. So x is congruent to dash mod 165. Let's see. X is congruent to dash mod 165. Okay. So if I write this, this is 3, 6, 9, 12, 15, so on. If I write this, I have got 2, 5, 2, 7, 12, so on. Now, the thing here is, if I want to combine these two, it is very simple. I just have to find the first one. I just have to find the first common term. And now the LCM will be the common difference. So, this is the term. I just have to add 15 in it. Right? Now, if I generate this sequence, it is 9, 20, 31, 42. Can you see 42 is the common term? 42 is the first common term. So 42 and then the LCM is 165. So simply you can write it as 42. Now the answer is 42. It is a complete coincidence. Right? It was not intended to be 42. Okay. It has nothing to do with my AIR. It has nothing to do with my AIR. It is a general thing. You got it? You got it, guys? You got it? Sir, I am new to Maths Olympiad and I have been an average student but with passion. Where I can get started with Maths Olympiad? First of all, complete 9th and 10th NCERT. And after that, you can actually follow these Olympiad lectures. If you have done it, then we can move on to the next lecture. We can move on to the next question. Right? In the next question, you will know it. Theta Hackett. What is this here? What is this name? In the next question, you will understand it. Now, we'll take a very brief detour and study Bezout lemma. What does Bezout lemma says? That if H is your HCF of A and B, then you can actually have P and Q, then PA plus QB equals H. There exist P and Q belongs to integer. Right? To understand it, let me give you an example. Can I say that HCF of 12 and let's just say 78 is 6, right? I hope it is the HCF, yes, right? So what this statement is saying, that I can choose certain integers. This is P and this is Q, so that this equation is satisfied. Am I making sense? This is basically the statement of Bezout lemma. Right? This helps in finding solution of indeterminate equations, indeterminate linear equation in two variables. right? It helps in finding solution of indeterminate linear equation in two variables, right? How to do your book. It is like there's a video how to use IOQM book. You can see that video, neural network. Neural network, you can see that video. Okay. Okay. Perfect. So I think we should really see the application of it. We should really see the application of it. What do you think? What do you think, guys? Should we really see an application of this? Should we really see an application of this? Diophantine can be multi-degree, right? Indeterminate is something which is used for linear equations. Indeterminate is something which is used for linear equation. Yes. Let's try and understand this thing. So, see, I am asked this question. Solve for integral PQ such that 37P plus 43Q equals 2. What an amazing problem. What an amazing problem. What an amazing problem. Can you solve it? Just give me one solution of it. Just find me any one pair. Any one pair would do. Any one pair would any one pair you can tell me. Any single pair. I'm okay. Right? Any one solution. I dare you. I double dare you. So let me do it in commonsensical terms, right? If I have to use my brain, what I would do, I would simply write it as this. Right? So that this is smaller. So that this becomes smaller. Right? And then I would assume P plus Q to be another variable x. And then this equation becomes 37x plus 6q equals 2. Now, if you see closely, see this, actually, this number is this number, any one solution you can find. Now, since this is even, I can say that x will be even. X has to be even. So this is even, this is even. So this further reduces my equation. This gives me 37y plus 3q equals 1. This is manipulation. This is manipulation. And now you can clearly see, if I write y equals 1 and q equals minus 12, I am done. Am I making sense? And since my y is 2, my y is 1, this gives me x to be 2. Now, what was my x? P plus q was my x. Now, my x is 2 and q is minus 12. So, this gives me P equals 40. Hush! Am I making sense? Am I making sense? Am I making sense? This is how you do it. This is how you do it. This is how you do it. But it included a lot of number sense, right? We have used here that this is divisible by 2, this is divisible by 2, so this has to be divisible by 2. Then we combine these things. So it is more intuitive rather than methodical, right? If I want to study a method of it, then I'll have to do certain things. How x equals 2y? See, I told you that this is even, which means this has to be even. If this has to be even, 37 is odd, x has to be even. So I did put x equals 2y. Am I making sense? Am I making sense? Am I making sense, guys? Right? Let's get on with it. Let's get on with it now. Let's move on to the next problem. Let's move on to the next problem. Okay? Let's move on to the next problem. Uh, in fact, method 2. Now, my method 2 is actually application. So, what is the HCF of 43 and 37? It is 1. And how do I find it? 43 is 37 times 1 plus 6. Then I write 37 is 6 times 6 plus 1. This is how I do it. Okay. Now, according to Bezout lemma, there exists some P and some Q so that this becomes 1. Right? This is the statement of Bezout lemma. And the algorithm to find P1 and Q1 is actually Euclid division algorithm. It is called Euclid division algorithm. Now, if you see, I want 1 in my equation, I want 37 in my equation, I want 43 in my equation. I will use these two equations to eliminate these 6, this 6, right? What is the value of 6 here? If you can see, 37 minus 1 upon 6. From this equation, I have written it, right? If I use this 6 and I put here, what do I get? 43 equals 37 plus 37 minus 1 upon 6. Right? If I multiply it with 6, I get this. Okay. So 1 equals 37 times 7 minus 43 times 6. If I multiply to both sides, I get 2. 37 into 14 plus 43 into minus 12. Did I get the same answer? Did I get the exact same answer? 14 and minus 12 was my answer, if you remember. This is the method. While last method used a lot of intelligence, this method used lot of hard work actually. It is a see, like if you do 3-5 problems of this type, you will be able to understand this. And the best part about this thing is, if you have one solution, this is the best part, right? This is the best part. Let me give you the best part. Let me give you the best part. This was the equation, right? And you have found one solution as 14 minus 12. If you add 43 here and you subtract 37 here, this will also be the solution as per our intermediate equation theorem, intermediate equation, right? This is how to do it, 57 minus 49, right? So, in fact, the general solution, if you see the general pattern here, general pattern, can I say that P is congruent to 14 mod 37, right? Right? In fact, if I do not use congruence, I will simply write P comma Q as this ordered pair, 43 Q plus 14 minus 12 minus 37 Q, right? You can simply put this equation here and like this, not, I should not write, just write T here, where T belongs to real number. So this is the general solution. This is called general solution. What is it? 43T plus 14 minus 12 minus 37T. Okay. Okay. Sir, I have a question. I have been struggling with this. Please lend me your hand. Chaitanya, sir, can we also use this pattern while calculating zeros for pair? Yes. But pair of linear equation, you have two simultaneous equation, no? That is not indeterminate. Pre-college mathematics book enough. Yes, pre-college mathematics book is enough for RMO even, right? You can do my book for IOQM. Okay. Okay. Sir, I'm currently done, but thank you, Kartika. Kartika, where are you from? Kartika, where are you from? Yes, see, like why I have written that this is the general solution. Even if t is real number, this solution will hold. This will hold. AP, sir, nice. So this is why I started these lectures in English, because when, see, like this is a very amazing story. I went to Vijayawada last year. And I found a boy who was solving my book. Right? He came to me. I introduced myself as National Outcomes Head of an academy. He did not know me. That is the beauty of it. He did not know me, but he was solving my book, right? And he asked me one question from that. I solved it obviously, and I told him that this solution is not efficient in the book. This is the more efficient solution. So he asked me, sir, how do you know that the solution is not efficient? Right? So I told him, because I have written this book. So that was the moment of awareness for me, that there are learners in South India who wants to study from me, who are following my books, because the books are in English. But since I do not have any lectures in English, they are not being able to follow me. Right? Anyway, perfect. So this Wilson theorem problem, like the next lecture is Wilson theorem only. So we'll do this in next lecture. You can save this question for next lecture. Okay. Perfect. Now what do I have here? Method 2. Yeah, method 2 I have done. Okay. Perfect. Now if you see properly, this was my question. X congruent to 0, X congruent to 2, X congruent to 9. Right? This was my original problem. Now how do I solve it using Bezout lemma? Please try and understand. First of all, I combined it to get 15Q. Right? What did I get? 15Q plus I think 7, right? 15Q plus 7. Yes. 15Q plus 7 was the solution of this. Not 7, yaar. What am I doing? Plus 2, right? So 2 is 12. 15Q plus 12. 15Q plus 12 was the solution of this, right? If you remember, 15Q plus 12 was the, right? 15Q plus 12 was the solution. And can I write it as 11P plus 9? Now just imagine that I do not know how to solve the sequence and series thing. So now this X can be written as 11P plus 9 and 15Q plus 12. So if I combine them, since these two X are equal, can I say my X is of the type 11P plus 9 equals 15Q plus 12? So can I say that 11P minus 15Q is 3? Okay. 11P minus 15Q is 3. Now I will again use Bezout lemma. What is the LCM of 15? What is the HCF of 15 and 11? It is 1. Right? Actually, I can write this 4, I can write it as 4 times 3 minus 1, right? So that I have 11, 1 and 15 here, right? I wanted 3 here, okay, not a problem. So this is 4, I'll substitute this value here, 15 times 11 times 1 plus 11 plus 1 upon 3. So 15 times 3 is equal to 11 times 4 plus 1. Okay. Okay. You can check it. Now, how do I solve it? If I get 11 times 4 minus 15 times 3 minus 1, multiply it with minus 3. So, you have 3 equals 11 times minus 12 plus minus 15 times, I have multiplied with minus 3, right? Minus 9. Okay. So, simply I can write P to be minus 12 and Q to be minus 9. Right? If I put these values here, x equals minus 132 plus 9 is, what is minus 132 plus 9? Minus 132 plus 9 is 123, minus 123, right? Here also I got minus 123. Now, since negative remainder is not allowed, I have to add LCM in it. 165 is the LCM, you get 42 as answer. So while Bezout lemma is very great, you need to understand why we need to read it. Let's assume that we have this problem. This is a more elegant way to put this solution in a written format. Let's assume that this question comes in RMO. So I consider that this commonsensical way using AP, this commonsensical way using AP is a better method while attempting IOQM level problems. But this is not elegant to write. You have to write formal solutions in RMO, right? You have to write RMO and INMO, you have to write formal solutions. This is not formal. Right? The formal solution is using Bezout lemma. This is how you do it. Can you write done here, please? Can you write done? Can you write done here, please? Right? Should I study binomial for number theory? Yes, binomial we have already taught, something of that sort, right? I think it is time to do one more problem. It is time to do one more problem. Okay? Okay. Find last two digits of 3 to the power 2024. Find last two digits of 3 to the power 2024. I'll just come. Hello, 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 hello. Am I audible? Am I audible? Am I audible? Yes, this is the mic. Okay. 81. Okay. 81 is something which learners are saying. Okay. Find last two digits of 3 to the power 2024. I'll do multiple methods, right, for it. Method number one. Method number one, right? Can I write it as 9 to the power 2024? Sorry. Can I write it as 9 to the power 1012? And I can write it as 1 minus 10 to the power 1012. Now let me give you the formula for it. In fact, actually we have not studied this. Binomial theorem, we should have studied binomial theorem first. So this includes binomial theorem, which will be dealt in next lecture, right? In the next lecture, we will deal with binomial theorem, right? Binomial theorem we will deal in the next lecture, right? So we'll simply leave it. So method 1 we cannot do. Now we'll do method 2. 9 to the power 1 is congruent to 1. Mod 100, 9 sorry. 9 square is congruent to 81. Mod 100. 9 to the power 3 is congruent to 29. Right? 729. So what I am doing, I am simply multiplying 9. This becomes 61. This becomes 49. And then I see the pattern. See, 09, 29, 49, 81, 61, and then 41. Right? Can you see the pattern here? If I go through this pattern, my 9 to the power 8 is 21 and 9 to the power 10 finally is 01. This gives me 9 to the power 1010 congruent to 1 and 9 to the power 1012 congruent to 81. Am I making sense? Am I making sense here, please? Am I making sense here, guys? Am I making sense here? So this is one way to do it. Right? Now, are you excited about the third method through Bezout lemma? Are you excited about third method? Are you excited? Euler-Tauschent. You have done through Euler-Tauschent, is it? Euler-Tauschent. Seriously. Perfect. Now, I am going to do it using method number 3. Let's do it using method number 3. See, if I write 3 to the power 2024, 3 to the power 2024 mod 25, then this simultaneous congruence will have answer mod 100 and this is going to be my answer. Am I making sense? Am I making sense, guys? This is going to be my answer. This is all this while I have been doing this. All this while I have been doing this. Right? All this while I have been doing this. Right? Correct? 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 Now, let's solve these two. Let's solve these two. Okay? I can see 3 to the power 3 is congruent to 1 mod 4? Oh no. In fact, 3 to the power 2 is congruent to 1 mod 4. So hence this is 1. Very simple. Now 3 to the power 3 is congruent to 2 mod 25. Okay. 3 to the power 4, 16. So we just have to increase the powers. 3 to the power 4 is 3 to the power 6 is 81, which is 6, right? 3 to the power 6 is not 81. Just a second. 3 to the power 6 is 4 mod 25, right? We want to find 3 to the power 2024. Okay. So obviously we need to find 1 here somewhere. 729, 6561. Okay. So 3 to the power 9 is congruent to 8. 3 to the power 18 is congruent to 64, which is nothing but 11. 64 is 14. And 3 to the power 20 is congruent to 9, 126, which is congruent to 1, right? So I got 3 to the power 20 congruent to 1 mod 125, right? We studied power jumping in the last lecture. This gives me 3 to the power 20 congruent to 1 mod 125. Oh, sorry, not 125, mod 25, right? We are finding mod 25. This gives me 3 to the power 2024 is congruent to power 4, 81. 3 to the power 4 is congruent to 6 mod 81. Mod 25, my mistake, right? Okay. So this is the question now. Now can I solve this? Of course I can. Right? So just write this AP. Right? Just write this AP. Right? And among these four, which is following this? 1 mod 4. This is 2 mod 4. This is 3 mod 4. This is 0 mod 4. This is 1 mod 4. So this is the minimum number, which is the answer. 81 is the answer. Am I making sense, guys? 81 is the answer. Right? Okay. Got it. This is perfecto. This is perfect. Right? 81. So this is how you find the last 2 digits. Right? When will you start teaching on the IOQM nights batch? I will not teach on IOQM nights batch. I don't know who told you that I will be teaching on IOQM nights batch. Have you ever seen, like you must have seen my photo. Have you ever seen me saying this thing that I will be teaching on IOQM nights? I never said this thing that I am going to teach in IOQM nights batch. I am going to teach in Ramanujan batch. Every Tuesday and Thursday I am teaching in Ramanujan batch. Right? I know, Chaitanya, I am saying this thing, but I did not commit, right? And anyway, you are getting here, everything you are getting here. You are studying live only, no? Okay. Now the next question. This is interesting. Find last 2 digits of 6 to the power 2025. And now we are going to study the shortcut of it. I am going to study shortcut for it. Now we are going to study shortcut of it, right? Now we are going to study shortcut of it. Right? Let me give you the shortcut of it. First of all, for the shortcut, you need the last digit. You should know unit digit cyclicity. What do I mean by unit digit cyclicity? If you see, if I write 2 to the power n, right? If this is r, n is r mod 4. If r is 1, the unit digit is 2. If r is 2, unit digit is 4. If r is 3, unit digit is 8, 4, 6, right? This is unit digit cyclicity. If this is 3, 3, 9, 7, 1. If it is 4, 4, 6, 4, 6. If it is 5, 5 everywhere. If it is 6, 6 everywhere. If it is 7, 7, 9, 3, 1. If it is 8, 8, 4, 2, just a second, 6. If it is 9, 9, 1, 9, 1. Okay, this is the unit digit cyclicity. Now, this means if I talk about 6 to the power 1, can I say it is 6 mod 100? 6 to the power 2 is 36 mod 100. 6 to the power 3 is 16. 6 to the power 4 is 96. 6 to the power 5 is 76. 6 to the power 6 is 56. 6 to the power 7 is 36. Can you see the pattern? Unit digit remains the same. 3 minus 2, 9 minus 1 minus 2. Now 1 minus 2, you can say that's just take the carry, right? If you subtract 11 minus 9, it becomes 2, right? 11 minus 2, it becomes 9, right? So 11 minus 2 is 9, 9 minus 2 7, 7 minus 2 5, right? So if you see the pattern here, now this is repeating. If you see the pattern here, can I say that 6 to the power 5q plus 2 is 36? 6 to the power 5q plus 3 is 16. 6 to the power 5q plus 4 is 96. 6 to the power 5q plus 5 or 5q is 76. This power is multiple of 5. This power is multiple of 5, if you see, right? So your answer will be 76. 76 is your answer. Okay, 76 is your answer. This is the repetition. This is the pattern. This is the pattern, right? So if you see properly, unit digit cyclicity is 4, right? Every digit is repeated after 4 times. It can be 2 also. For example, in this case it is 4, it is 2. In this example it is 2. In this example it is 4, 4, right? Here it is 1. Means in every power the unit digit is same. Similarly, if I talk about unit digit, last two digits have the cyclicity 20, right? Very important thing. Last two digits have cyclicity 20. You can note it down. You can note it down, guys. Last two digits have cyclicity 20. Okay. Okay. Okay, last 2 digit cyclicity is 20. So, sir, can you apply this shortcut or whatever you want to say to 3 to the power 2024? Let me apply. Now, if I talk about 3 to the power 2024, you'll see the pattern very initially. 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 27, 3 to the power 4 is 81. Now see properly. 3 to the power 5 is 243. So 43. Right? See properly. 3 to the power 6, 29. Right? You have to see pattern among these. 3 to the power 7 is 29 3s are 87. Right? Plus 6. 3 to the power 8 is congruent to 87 times 3 is 261. Right? See properly. Right? Right? In fact, since I have told you that the cyclicity is 20, this means that 3 to the power 20q plus 4 is congruent to 81. And can you see that this number is 20q plus 4? So you have got the answer. You have got the answer. Everywhere cyclicity is 20. Everywhere cyclicity is 20. Okay, and obviously it has to do with Euler-Torsion function. Obviously it has to do with Euler-Torsion function. Right? Right? This is the question which is going to come this year. I'm pretty sure of it. I'm pretty sure of it. Okay. Find last 2 digits of this was RMO problem. 2 to the power of 1990. Can you do it, please? Can you do it? It should be a one step answer. It should be a one step answer. It should be a one step answer. (24). Sir, it is very simple. 2 to the power 10 is congruent to 24 and 1990 is 20q plus 10. This means this is going to be the answer. Have you done it like this? Have you done it like this? Have you done it like this? Isn't it fast? Isn't it fast? Tell me. This is fast, right? This is fast, right? So nobody talks about cyclicity of last 2 digits. Nobody talks about cyclicity of last 2 digits actually. Okay, perfect. Now, please write factorials. So, factorials are nothing but n factorial can be written as n into n minus. It is defined recursively, n greater than equal to 1, right? For this, this is the one. So, the basic definition is n factorial is n minus 1 and it stops at 1. So, 1 factorial is obviously 1. If I put n equals 1 here, 1 factorial is equal to 1 times 0 factorial, which gives me 0 factorial as 1. Which gives me 0 factorial as 1. See, like this is a vacuous truth. This is called a vacuous truth. There are certain truths about identities. So, 0 is additive identity, right? 0 is additive identity. There are very special things about 0, right? For example, 0 factorial is 1. It is so unintuitive. 0 is the only number which does not have any sign. It is neither negative nor positive. 0 is a number which is both purely real as well as purely imaginary. It has so amazing properties, and that is why it was found in India, right? Many special things are found in India. Okay. Okay. So, 2 factorial is 2 into 1. Now, the next factorials, I'll simply multiply 3 in this. I'll simply multiply 4 in this. I'll simply multiply 5 in the above. 6 factorial is 720. You have to remember till 10 factorial. You have to remember till 10 factorial. Can you please write it down? Can you please write it down, guys? Guys. So, this is the definition of factorial. Okay. This is the definition of factorial. This is how you define factorials. Right? Can you find this sum for me? 1 into 1 factorial, 2 into 2 factorial, 3 into 3 factorial, 4 into 4 factorial, 9 into 9 factorial. Can you please find this sum for me? Can you find this sum for me, guys? Guys, can you find this sum for me? Perfect. Now, can I say that this is r into r factorial? Now, can I write this r as r plus 1 minus 1 into r factorial. If I multiply this r plus 1 here, this becomes r plus 1 factorial minus r factorial. So this gives me 2 factorial minus 1 factorial, 3 factorial minus 2 factorial, 4 factorial minus 3 factorial, dot 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 till 10 factorial minus 9 factorial. If I add them, I see the cancellation happening like this. This becomes 10 factorial minus 1, which is equal to 3628800 minus 1, which is 3628799. Right? Right? This is the answer. This is sequence and series combined with number theory. This is a 2 marker for you all. And it is a problem of JEE Main. This was in JEE Main. This was asked in JEE Main. Right? 3628799 is the correct answer. Right? Is this the correct answer? Is this the correct answer? Obviously, it is the correct answer. Now, what is the sum of digits here? Can you tell me the sum of digits here? Can you tell me sum of digits here? Is it 43? Is it 43 or 44? 43 or 44? Is it 43 or 44? 25, 33, 44, I believe. Sum of digits is 44. Third to fourth step. 1, 2, 3. See, this is r times 1 to 9, right? So I have put in 1 here, then 2 here. This is r equals 1. This is r equals 2. So I am putting the values of r here. Okay. So in this problem, what can they ask you? Sum of digits. They can ask you sum of digits. Am I making sense, guys? Am I making sense? Okay. Perfect. Perfect. Right? So this is a brief concept about factorial. Then highest power of P dividing n factorial. Right? P is prime. P is prime. Right? So the formula is greatest integer of n times n upon p plus n upon p square. Right? Let me give you an example. Find highest power of find highest power of 3 dividing 50 factorial. This is the question asked in JEE Main 2025. So 50 upon 3 plus 50 upon 9 plus 50 upon 27. Very simple. 16 plus 5 plus 1, that is 22. 22. Okay. Okay. Thank you, Alpha Chestnut. Got it. 16 plus 50 plus 5 plus 22. Now this is the question. Find number of zeros at the end of 42 factorial. 42 factorial. What if p is not prime? Then it is not applicable. Then it is not applicable. We'll see. Done. 42 factorial. Now, here, one common mistake is this. 42 by 10. This gives me 4. This is not the correct answer. This is not the correct answer. Right? It will not have 4 zeros because this is not prime. So, you can see that 42 factorial is 2 to the power m, 5 to the power n, and so on. Now, can you simply say with common sense that m is greater than n? And to make 10, you need as many 2 as there are 5. Right? So, can I say the answer will be n? Can you say that your answer will be n? Can you say that your answer will be n? Because if you have n powers of 5, you will definitely have n powers of 2. Every power of 2 and every power of 5 will merge and will give you 10. That is the number of zeros. This is Legendre's formula. This is called Legendre's formula. Right? So, this is how you cater. This is how you cater composite numbers. Got it, Chaitanya? You were asking, sir, how do I find for composite numbers? This is how you find it. So, 9 is your correct answer. 9 is your correct answer. Okay? 9 is your correct answer. Okay, 9 is your correct answer. This is how you do it. This is how you do it. Okay? Very simple. Perfect. Perfect. Right? Legendre's formula. Then we have binomial theorem. Binomial theorem is very, very important. But see, like, we just need to find. For us, we need only the statement of it. We do not need anything else. And that too, we just need 1 plus x to the power n. This becomes 1 plus nx plus n into n minus 1 upon 2 factorial x square plus n into n minus 1 into n minus 2, 3 factorial x cube, and so on. Right? And so on. Right? So, with binomial theorem, can you give me 1 plus x to the power 4? This is all we need. Believe me, this is all we need. This is all we need. I will tell you why. Because we are after the remainder problems. So, we need only that much binomial which is essential for remainder problems. Rest of the binomial theorem we will study with combinatorics. It is part of permutation and combination. It is part of permutation and combination. Okay? Yes. JEE 2028, the news is real. Just a second. Just a second. So this is 1 plus 4x plus 6x square plus 4x cube plus x to the power 4. Right? 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 Now I can find last two digits using binomial theorem as well. If you remember, this was my problem. I can write it as this. See, 9 and minus 9, 9 to the power even and minus 9 to the power even are one and the same thing. Can I write it as like this? Rest here, all the numbers will be divisible by 100. So this becomes 100 cube. And if you simply solve this number, you will get minus 90. Last two digits will be minus 90. And since your remainder cannot be negative, you just add 100 here to get 81. So this is how you do it. Okay. Can you note it down and write done? Can you note it down and write done here? Okay. Hello, hello, hello. Yes, this is the one. Hello, 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 hello. Okay. Done. So this is how you write. Right? So this is the last problem of the day. This is the last problem of the day. In the next lecture, we are going to study invertibility, Wilson theorem and Fermat theorem. Okay. Wilson theorem, Fermat theorem. This is the part of next lecture. After that, we are going to do Chinese remainder theorem. After that, we'll be doing base, what do I call it? Base system. Then we will do greatest integer fraction part. One more lecture of number theory. In 9 lectures, basically number theory will get over. Meanwhile, you have to study geometry as well. Your algebra lectures will start soon. Okay. Okay. If you can find this answer, I'll be very, very happy. Now, my observation here is that this is 24 square. And 24 is 25 minus 1. Okay. Let's do it. Can I write this as 5 into 5 to the power 2024? Then can I write it as 25 2024, not 2024, 1012. Can I write it as 1 plus 24 to the power 1012? Now, if I expand it using binomial theorem, I can write it as plus 24 square, then something. This whole number is divisible by 576, which means my n is congruent to 5 times 1 plus 24 times 1012 mod 576. Now I will be more creative here. I can be more creative. I have 124 here. I have 124 here. Can I write it as 1008 plus 4? 1008 is divisible by 4. This is the beauty of it. 5 remains here, 1 remains here. 1008 times 24 is multiple of 576. We ignore it and we get 4 here. So I get 97 times 5. What is 97? This is 97 times 5. 97 times 5 is 485. So 485 is my answer. 485 is my answer. This is a very advanced problem. Easily 3 marker. Easily 3 marker. Okay. Easily 3 marker. Do you agree that this has the potential to be a 3 marker? Do you agree that this has the potential to be a 3 marker? I think you would agree. You would agree. And this is very difficult to understand. That is why, see, like, I do not give much time in these lectures because anyway, all these problems will take 8 to 10 minutes to think on your own. First of all, you have to be comfortable with binomial. Then you have to be comfortable with calculations because I have done fast calculation here, right? So that is why each IOQM lecture should take 4 to 5 hours to understand. And that is why I am taking only 1 lecture per week. This is the reason why I take 1 lecture per week. Am I making sense, guys? I hope I am making sense. Right? Right? See, why did I remove 1008? So it was written as this, right? I wrote it as this. Then I wrote it as this. Right? What is 1008? It is 24 times 42. Right? It is 24 times 42. Okay. So if I write it as this becomes divisible by 576 and this goes into the modulus. This goes into the modular. This is divisible by 576. Hence, my answer is 5 times 97. Got it? Such a beautiful number, 1008, 24 into 42, right? 24 into 42. Perfect. First of all, we will study concept of invertibility, mod prime. Mod prime. Right? What do I mean by invertibility mod p? It has a very simple thing. So I take a set A which consists of 1, 2, 3 till p minus 1, where p is a prime number. P is a prime number, right? P is a prime number. Then I write 1 into 1 is congruent to p minus 1 into p minus 1 congruent to 1, mod p. And then I write, this is first. Secondly, I write if A belongs to capital A, right, there exists unique B belongs to capital A set such that AB is congruent to 1, mod P. And A and B are called inverses of each other. Inverses of each other. Right? Inverses of each other. For example, and B is written as A to the power minus 1. This is the concept of invertibility, right? This is the concept of invertibility. Okay. Okay. This is the concept of invertibility. B is equal to A inverse. Now, let me go through an example so that you all can understand. Let's take the prime number 11, right? So can I say that my set A is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now my first part says that this number and this last number can be like they are self inverse. So 1 is the inverse of 1 and 10 is essentially minus 1, right? 10 is essentially minus 1 mod 11, right? We are talking about mod 11. So this is the first sentence. If you are getting till here, please write DN. Please write DN in the chat. Please write DN if you are getting till here. Hello, hello, hello. Please write DN if you are able to understand till here. Done. Nice. Now, what did I say? See, like every A has a unique inverse. 1 is self inverse, minus 1 is self inverse. Let's talk about 2. Let's talk about 2. Can you see that 2 times 6 is congruent to 1? Mod 11. So 2 and 6 are inverse of each other. 2 and 6 are inverse of each other. Similarly, 3 times 4. 3 and 4 are inverse of each other. If I talk about 5, 5 and 9 are inverse of each other, which leaves me with 7 and what else? 8. They are inverse of each other, right? So every number has a unique inverse. 6 has 2 as inverse, 2 has 6 as inverse, 3 has 4 as inverse, 4 has 3 as inverse, 5 has 9 as inverse, 9 has 5 as inverse. Similarly, 7 and 8 are inverses of each other, right? Am I making sense? Am I making sense? Am I making sense? No, not for every number. This is for prime numbers. This is for prime numbers. And why this happens for prime number, we will do it in the next page. So like this is the concept of RMO. This will help you in writing the answers. That is why we prove it, like we prove everything. Although these are name theorems, you can use these theorems directly in RMO, right? You can quote them. This is like by Fermat Little theorem. I am writing something, right? Right? So we are doing whole calculation mod 11. So invertibility is a concept which is dependent on which divisor are you taking. So if you are taking 11 as divisor, then 2 and 6 are inverse of each other, right? Otherwise, if you see 2 times 4 is 1 mod 7. So when we are talking about mod 7, 2 inverse is 4, 4 inverse is 2. So inverses are dependent on the choice of divisor. If you are taking mod 11, basically the inverse is different. Getting my point? Getting my point? Getting my point? Right? Now, with example, we can understand that this is unique, but we have to prove it, right? Do you agree that we have to prove it? Right? Uniqueness of B has to be proved. Uniqueness of B has to be proved. Do you agree? Do you agree? Right? So just write DN so that I can move on to the next page. Can you write DN so that I can move on to the next page? Very good, Abhimanyu. Right? Let's go on. Let's move on. Okay, perfect. Now, I am going to prove it by contradiction. Right? Let B and C belongs to A such that AB congruent to AC mod P congruent to 1. Right? Let's just write this. Okay. Now this means that A times B minus C is congruent to 0 mod P. Right. Now since this is a prime number, and now you will understand why we are doing this thing for prime number. Can I say that A is co-prime with P, and since this is congruent to 0, it implies P divides A times B minus C. Now since A and P are co-prime, this automatically concludes that P divides B minus C. And how can it divide B minus C? How can it divide B minus C? The only possibility is B equals C. So your choice of B and C, can only be equal, which means B and C has to be equal, right? 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 Do you agree? Do you agree? Done? What does mod P represent? Please refer to the earlier lectures. You'll not be able to understand this lecture before going through the first two lectures. This is not a Tom and Jerry show, it is a Sherlock Holmes show. Sherlock Holmes show are connected to each other. These are not something which you can see and laugh it out in every moment. You have to see all the previous lectures to understand this. Right? No, no, no. A is co-prime. See, like all these elements are co-prime with it, right? See, like all these are remainders mod P, right? So all the remainders are co-prime with P. That is the definition of prime number. That is why this is the whole point of taking the prime numbers, right? Right? This is the whole point of taking the prime numbers. So now what we are reasoning here is, if these two are congruent to 1, leave this part. If these are congruent basically, then this is congruent to 0 as per our properties, the properties which we have studied for mod. And this is mod P, by the way, this is mod P. So what is congruent to 0 means? Congruent to 0 means P divides this. Now since A is co-prime with P, P cannot divide A. So P has to divide B minus C. And P divides B minus C. See, what is B minus C? B and C are these numbers, right? Right? So can you take any two numbers, subtract them and get P or 2P or 3P? No, you can get only 0. You can get only 0, right? Right? So that is why we say B equals C. Okay. So this proves the uniqueness. This proves the uniqueness. Okay. Now, if I simply say 1, let's multiply these two numbers. 2, 3, 4, P minus 1. Okay. So these are even numbers. So I have taken P as odd prime. Odd prime. So can I say that these are even number of terms? Even number of terms. These are even number of terms. Can I say this thing? These are even number of terms. Can I say these are even number of terms? Right? 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 I am talking about this product. So this product is actually P minus 1 factorial. P minus 1 factorial. This is what? P minus 1 factorial. Right? But if you see, this is 1, this is 2. There will be among these numbers 2 inverse. this is 3. There will be one number which is 3 inverse, and so on. And lastly, p minus 1 is minus 1. All other numbers will have inverse here. Now 2 times 2 inverse is 1. You have 1 everywhere, and in the last you have minus 1. So can you say that p minus 1 factorial is congruent to minus 1 mod p? This is your Wilson theorem. This is called Wilson theorem. This is Wilson theorem. This is Wilson theorem. Please note it down, guys. Please note it down. This is the definition of factorial. This is the definition of factorial. What is n factorial? If you have not studied it, please write it down. N factorial is n times n minus 1, n minus 2 till 1. So it is a continued product till 1. It is a continued product till 1. Got it? So what did I get? P minus 1 factorial is congruent to minus 1. Right? So one important corollary here is if p minus 1 factorial plus 1 is divisible by p, then p is a prime number. Then p is a prime number. Then p is a prime number. It's a very, very important thing. It's a very, very important thing. Like it cannot happen for non-primes. It cannot happen for non-primes. It can happen only for prime numbers. How do you get 2 inverse? See, like earlier I proved that among the set 1, 2, 3 till p minus 1, there are inverses of each other. Right? We proved it. So there will exist some basically some inverse. So just to give you a context, let's write for 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Right? Now 1 is 1, 2, write 6 here, which is 2 inverse. Then 3, 4, with 5, write 8, no, 9, and then 7 and 8, and then write 10 as minus 1. So can you see, this is 12 which is 1, this is 12 which is 1, this is 45 which is 1, this is 56 which is 1, right? This is how we get minus 1 in the end. This is how we get minus 1 in the end. Okay? Okay? Are we getting it? Done? Perfect. Perfect. So let's do some problems. Find remainder when 11 factorial is divided by 13. So if you are asked this question, how will you do it? How will you do it? Give me the answer. Give me the answer. 1. Anuj is saying 1. Yash is also saying 1. Okay, let's see. Let's see. First of all, can I say that 12 factorial is congruent to minus 1 mod 13, right? Now, I need 11 factorial. So, I will write it as 12 times 11 factorial is congruent to. Now, minus 1 is congruent to minus 1 plus 13, that is 12. That is 12, right? So, it is 12 mod 13. Since 12 and 13 are co-prime, we can simply cancel that. So, 11 factorial is congruent to 1 mod 13. Okay. 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 Do you get it? Do you get it, guys? Guys. Done? Perfect. No, 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 no. P minus 1 is not present. That it is 11. No. No, 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 no. Don't do this. Don't do this. Don't do this. Don't do this. I won't write it. Like, I do not consider this as a valid like this thing. So what you are trying to say here is, sir, you can simply write P minus 1 factorial is equal to minus 1. Then P minus 1 into P minus 2 factorial is congruent to P minus 1. And then you can cancel here, and P minus 2 factorial is congruent to 1. I would not remember it as it like this. This is a logical explanation, but I won't remember it like this. I won't remember it like this. Okay? It is upon you to decide. Okay? Another problem. Find remainder when 42 factorial is divided by 47. What is the remainder when 42 factorial is divided by 47? Let's see if you are able to do this. Let's see if you are able to do this. Yes. 42 factorial is divided by 47. So if you are watching it in recording, then you can simply pause this video and to solve it, right? I am going ahead with the solution. Again, can I say 45 factorial is congruent to 1, right? You told me to use that. Okay. Now simply write 45, 44 and 43. These are the additional numbers. 42 factorial, right? Now, this is 1. I can add 47 here. So, it will be congruent to 48, right? So, I can write it as 15. I can write it as 16. Then, I can write it as 42. I can write it as 8. Oh, sorry, 22. Sorry, 22. 22. Right? Now, you have 15, 22 and 43 is as additional number. Right? Write 42 factorial separately. You have 8 here, add 47 in it. So you will have 55. 2, 5, 3. Right? So you have 6 here now. So 42 factorial times 6 times 43 is congruent to 1, which is again congruent to 48, which again gives you 8. So you have 42 factorial times 43 as congruent to 8. Okay. Are you getting my point? Are you getting my point? Are you getting my point? Mod is mod 47. We are solving mod 47 now. We are solving mod 47. Right? Right? We are solving mod 47. Now we have to find multiple of 43. Right? We have to find multiple of 43. So basically, see this 8. You can add only multiples of 47. So 47q plus 8 is equal to 43q, 43p. So can I say 8 times, just a second. Can I say 47q minus 43p is equal to minus 8? Right? So if you see, yes. So this is the equation now. If you see, this is the equation now which you have to solve. Right? So simply, if you take q equals 2 here and p equals 2 here, sorry, what I'm trying to say, if you simply take p equal to q equals to minus 2, what do you get? Just take minus 2 common, and then you get 47 minus 43 equals minus 8. So this is one solution. Right? Minus 2, minus 2. Okay. To get the next solution, you have to add 43 here. So if you add 43 here, you get 41. Okay. And for the next solution here is, you add 43, so you get 45. 40, like you have to add 47 here. This was an indeterminate equation. We solved it in basic of mathematics. We solved it. You simply have to add 47 here. The coefficient of q is to be added here. The coefficient of p is to be added here. 41 and 45. So, but this solves the question for me. So since I have 41, so I simply have to write 42 factorial times 43 is congruent to 8 plus 47 into 41. 47 into 41. Right? Right? Now, if you solve it, what is 47 times 41? See, like 47 times 41 is actually equals to 44 square minus 3 square. Right? 44 square is 1936. So this is 1936 minus 9 is 1927. And then you are adding 8 here, which becomes 1935. So this is 1935. And have faith, it is divisible by 43. Because we have calculated it. So this is 4. Right? 43 4s are 86, 172. And then 215. So 45. So 42 factorial is congruent to 45 mod 47. Abhimanyu, did you get it? Abhimanyu, did you get the answer? Yeah, see, like, I understand your point, but did you get the answer? 45. I guess Yash Pillai was the first one. Yash Pillai was the first one who got the answer correct. Yash Pillai was the first one who got the answer correct. I believe. Got it? Perfect. You both got it. That is the only important thing. Right? Now let's move on. Let's move on to the next thing. Let's move on to the next thing. Now, let me see. Just a second. Yes. Let's take any. Let A belongs to capital A. That again, that set. A was 1 to P minus 1. Consider a set B, which is A, 2A, 3A, 4A, P minus 1A. Right? I have this as my set. Right? How many elements does this set have? Number of elements in this is P minus 1. Right? It consists of P minus 1 elements. Yes, Anurag. It is there. It is there, obviously. Anurag, it is there. How much rank did you get? How much rank did you get in JEE Main? Right? Let's go ahead. Let's go ahead now. Now, what I will say that every element of B is having a unique remainder. Unique remainder. So what I'm trying to say is A is congruent to R1, 2A is congruent to R2, P minus 1A is congruent to this, and all these remainders are unequal. All these remainders are unequal. All these remainders are unique. Okay. All these remainders are unique. All these remainders are unique. Let me prove it again. Again, I will go through. Now, since like A is coprimer, I'm just writing it here. I will go through contradiction. Okay. So Ri is I times A congruent to J times A. I minus J, same logic, times A congruent to 0, which is possible only when I equals J. Right? It is possible only when I equals J, because then P divides this. P can divide I minus J times A only when I minus J is equal to 0. Right? Am I making sense, guys? Am I making sense? Yes, the price amount will remain the same. Right? Am I making sense? Perfecto, perfecto, perfecto. Let's move on. Right? Now let me multiply all of them. Let me multiply all of them. A, 2a, 3a, p minus 1 into a. Now all these remainders are nothing. See, like these remainders are permutation of these remainders, because these are the only remainders which are possible. See, like these are p minus 1 remainders. Mod p, you can have only p minus 1 remainders. Like one remainder is 0 obviously, but we are not taking 0 into our set. So there are only p minus 1 remainders. All of them are unique. It means this complete product has to be equal to this product. And now we can cancel. 1 gets cancelled with 1, 2 gets cancelled with 2, p minus 1 gets cancelled with p minus 1. All of them will get cancelled. How many a do I have? P minus 1. Everything is cancelled here. Mod p. This is your Fermat-Little theorem. This is your Fermat-Little theorem. This is your Fermat-Little theorem. Got it? Got it? Right? Sir, if this is special case of Euler, then why don't we study Euler first? See, like, Abhimanyu, now that you have studied Euler, right, you must have understood that the proof of Euler was much more difficult than Fermat. So, to help everyone understand Euler before going through these two theorems is a tedious task. Like I have done it before. I have taught Euler first, but the learners were very uncomfortable studying Euler first. Right? Perfect. So A is co-prime with mod P. You can find it like this also. And then your need for A to be co-prime with P goes away. Right? If A is not co-prime with P, then also this is valid, this is valid, then also this is valid. Right? Perfect. So see, like in all the remainder problems that we have studied, we need a power which, when you take the power on A, it should become 1. So FLT helps us in finding that power. Right? So for example, this was a problem in JEE Main. This was a problem in JEE Main. Find remainder when 5 to the power 2027 is divided by 11. Divided by 11. Can you find me the remainder? Can you find me the remainder? Find remainder when 5 to the power 2027 is divided by 11. Done? 3 is the answer. Let me check. Let me check. Now, What, how does this help me? 5 to the power 10 is congruent to 1 by FLT. This gives me 5 to the power 2020 is congruent to 1, which is perfect. No problem. But I have 7 powers additional. I have additional 7 powers. So 5 square is congruent to 3. 5 to the power 4 is congruent to 9. 5 to the power 6 is congruent to 27, which is congruent to 5 mod 11, right? Which is congruent to 5 mod 11. 5 to the power 7 is simply 25, which is again 3. I think, yes. Now, if you multiply these two, you get 5 to the power 2027 is congruent to 3 mod 11, which is your answer. Which is your answer. Okay. Okay. So, the real benefit about this is you got this first, right? You got this first, right? Right? You got this in the first step. Otherwise, without knowing this theorem, majority of the JEE aspirant try to find it like this. Try to find it like this, right? Like this. Okay. I hope I'm making sense, guys. I hope I'm making sense. But what if, sir, what if my remainders, like my divisors are non-prime? What if my divisors are not prime? What happens then? Right? What happens then? Let us see. Let us see. Let us see. How to calculate 5 to the power 7 mod 11 quickly. Like this. I have shown you the steps. Right? I have shown you the steps. Okay. Now let's solve. Right? In the last lecture, we solved simultaneous congruences, right? Let's solve this. Solve the simultaneous congruence. Congruence, right? Not 5. 2 to the power 100 congruent to mod 4 and 2 to the power 100 is congruent to mod 25, right? So the solution will be something mod 100, right? This is what we have studied. We'll always be able to find answer mod 100. That is LCM of 4 and 25. So can you fill in these 3 blanks? Can you fill in these 3 blanks? Fill these 3 blanks for me. Fill these 3 blanks for me. Ranker reward program is based on the ranks. So if you get first rank in JEE Main, you get 11 lakh rupees. It is like that. One. Fill in the blanks. So 0 comes here, right? Obviously 2 to the power 100 is divisible by 4. Okay. So this comes here. Now if I talk about mod 25, I clearly know that 1024, right, it is 2 to the power 10, is congruent to minus 1 mod 25, which gives me 2 to the power 20 congruent to 1 mod 25. It is about knowing the powers of 2. That is why I gave powers of 2, right? That is why I gave powers of 2. 2 to the power 100 means 1 mod 25. So this gives me 25. No, 1, right? This gives me 1. This gives me 1. Okay. So if I write the sequence of numbers which are 1 mod 25, it will be like this: 51 and then 76. So if you see, this is 1 mod 4, 1 mod 4, this is 2 mod 4, this is 3 mod 4, and this is 0 mod 4, which is required. So the answer will be 76. So the last two digits will be 76. Last two digits of this number is 76. This is going to be a problem in IOQM 2025 for sure. In IOQM 2025, you will be asked last two digits of something. It is a certainty. It is almost certainty. Right? 014? How did you get 4? How did you get 4? How did you get 4? Everyone is writing 4. How come everyone is writing 4? Have I made some mistake here? Or I am right and you are wrong? I think you all are wrong. This is a 3 marker. This is a 3 marker. I think you all are wrong, guys. Okay, bye Abhimanyu. Right? Perfect. But, sir, we were lucky here. We could remember 2 to the power 10, then we could raise it to 2 to the power 20, and that is how we got 1. How to deal with divisors which are non-prime? Right? How to deal with divisors which are non-prime? Right? How to deal with divisors which are non-prime? Okay? Should we do something about it? Are you ready to study? Are you ready to study that? Are you ready to study that? Yes, that is how we get Euler quotient. So let's define a function, right? Phi n represent number of positive integers less than n which are co-prime with n. Okay, which are co-prime with n. Okay, so this is called Euler quotient function. So if you see, phi 2 is 1, phi 3 is 2. Basically, see, like less than 2, there is only one natural number which is co-prime with 2. So 1. Less than 3, there are two numbers, both of them are co-prime. If you talk about phi 4, right? So write all the numbers less than it. This is not co-prime, this is co-prime, this is co-prime. So this will be 2. Phi 5, will be 4. Please tell me what will be 5, 6? 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 5, 6 is going to be 2. Because only, see, like 2 is 1 is co-prime, 5 is co-prime, 2 is non-co-prime, 3 is non-co-prime, 4 is non-co-prime. So 5, 6 is 2. Right? 5p is definitely p minus 1. P is prime because all the numbers less than 3, less than p will be co-prime with the prime number. Okay? So this is a very important thing. Right? Right? Okay? 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 So now let me write a formula for phi n. So phi n is, if n is p1 to the power a1, p to the power a2, right? So this becomes n times 1 minus 1 by p1, 1 minus 1 by p2, so on, right? For example, let me calculate 500. 100 is 2 to the power 2 times 5 to the power 2. So I will write 100 first, then all the prime numbers like this, all the prime numbers like this. Okay, so this becomes 100 into half into 4 by 5, this becomes 40. Okay, this becomes 40. What is phi of 42? 42 has 3 prime numbers, 2, 3, 7. So what do I get? 42 into 1 by 2 into 2 by 3 into 6 by 7, I get 12. So 542 is 12. Right? 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 If you are able to understand it, just take 2 minutes of time to absorb everything. Just take 2 minutes of time to absorb everything. Am I making sense, guys? Am I making sense? Sir, your lectures are best only in Hindi. I think by virtue of being I am alone teaching in English, it becomes best in English also, right? I am the only one who is teaching in pure English, right? So, and if I am the only one who is racing, then I am going to win because I am the only racer. Don't you think? Yes. There are certain topics which you should definitely do from JEE. quadratic should be done from JEE, sequence and series should be done from JEE. Why cyclicity of 2-digit number is 20 if its phi is 40? Anuj, you have to give me the answer of this first. You have to give me the answer of this first. Do you agree that this is correct? This is Fermat. This is Fermat, right? This is Fermat. Do you agree? Do you agree that 5 to the power 10 is congruent to 1? But is 10 the smallest number so that it is congruent to 1? No. 5 to the power 5 is also congruent to 1. You can see. You can see. You can see. So, although 540, although 500 is 40, it does not mean that it is the smallest power which gives 1 as remainder. Getting my point? For that you need Carmichael functions. For that you need Carmichael functions. Carmichael functions gives you the minimum power. Carmichael functions give you the minimum power with which you can raise and get the remainder as 1. Right? No, I won't teach Carmichael function. Carmichael function is not that relevant. I have not seen any problem of Carmichael function. Right? Okay, moving on. Moving on. Let's move on. Let's move on, guys. So, prove that phi P1 P2 is equal to P1 minus 1 into P2 minus 1. P1, P2 are distinct primes. These are distinct primes. You do it while I get the water. Let me get the water. You do this. Yes. Just use formula. It's very simple. It's very simple. It's very simple. Sir, phi of P1, P2 is actually equals to, as per the formula, it is P1 times P2 times 1 minus P1. Oh, sorry. 1 minus 1 by P1 into 1 minus 1 by P2. Okay. So, if you simply take the LCM, you get P1 minus 1 into P2 minus 1. Okay. 5 times P1, P2. Right? So trivial. Yes. Yes. Right? In fact, what he is trying to say, if A and B are co-prime, then phi A B phi AB equals phi times A into phi times B, right? Can you write this? Can you write this? Can you write this? Right? Let's move on. Right? Now, again, we take a set. Let's take set A, A1, A2, AK, phi n is equal to K. I am taking this as consisting of all numbers co-prime with A, with n. Now I am not taking n as a prime number. N is any. N is any divisor, right? So these are the numbers which I am taking consisting of all numbers co-prime with n. So obviously it will be k. In total, there will be k such numbers because phi n equals to k, right? Right? Now, again, I will take another number. B belongs to A. So B is also a co-prime. And capital B is the set which is equals BA1, BA2, BAK. Similar line of working as we were doing. Now I am going to write that all these are unique. All these are unique. Again, by contradiction, if Bij is congruent to Baj, this gives me B times Ai minus Aj congruent to 0. Since B is co-prime with n, Ai minus Aj congruent to 0 implies Ai equal to Aj. So all these are unique. Now again I am going to, and these unique remainders are these only. So I'll just simply multiply them to get this. And that is how I get Euler theorem, which gives me b to the power n is congruent to 1 mod n phi n. Right? B to the power phi n is congruent to 1 mod n. This is the general theorem, right? Where B and n are co-prime. Can you write this down, please? Sir, can I crack IOQM if I start now? Yes, you can do it. Obviously, you have to put in more efforts. Sir, will JEE help in IOQM? Sir, if one's IOQM syllabus is done in 2-3 months from your book, how should he revise? By giving tests. Give a lot of tests. right? Thank you, Yash. Thank you for the gratitude, Yash. Perfect. Let's move on, guys. Now, this is a very, very important theorem. This is a very, very important theorem because it opens door for all the things. Now, remainders are much more easier. And just take, let P be a prime number. Then we know phi P is P minus 1. So, this is the theorem. This is Euler-Totschen function. This is Euler-Totschen function. This is Euler theorem. A is co-prime with P. So do you get Fermat theorem as a special case of Euler theorem? This is Euler theorem. So like now this is FLT. FLT is a special case of Euler theorem, right? Early bird. I was early bird. I was never a night out. I was never a night out. I was always a early bird. See, like I cannot control my sleep. I need 7 to 8 hours of sleep. Otherwise, I cannot perform. Otherwise, I cannot perform. Right? Perfect. Now, this becomes much more easier. 2 to the power 100, right? We wanted to do mod 25 here, right? So see, like what is 525? It is 25 times 1 minus 1 by 5, 1 minus 1 by 5, it gives me 20. So 2 to the power 20 is congruent to 1 mod 25. That is how we get it, right? Right? Am I making sense? Am I making sense? Am I making sense? Right? Yes, it is perfectly all right, Chaitanya. If you are not being able to understand the proofs, then it is okay. Only tell IOQM. For RMO, you'll have to do better. For RMO, you'll have to do better. Right? A to the power P minus 1 is congruent to 1 mod P. 2 to the power 20 is congruent to 1 mod 25. Yes, by watching lecture again. I'll be teaching till 5:20. Right? In fact, I think this is the last question. This is the last question which I am going to do. A, oh no, 2 to the power, let me write 2 to the power 20, 2007 is congruent to dash mod 1000, right? Find, you have to calculate this. Today I finally watched your live lecture after covering the previous ones. Nice. CRT. Yes, you can do it directly. See, like the powers. The powers are very easy here. You can do directly with the Euler-Totschen function. The powers are very simple here. No. You can use Euler. Yes. Phi. 1000 is 400, right? So 2 to the power 400 is congruent to 1. Can you write it like this? Can you write it like this? Can you write it like this? Yes, finally. See, like Yash is actually looking at the lectures very, very properly. He has noted this condition that sir, this number and this number has to be co-prime to apply Euler. So you cannot apply Euler here. This is a wrong statement. This is a wrong statement, right? So to do it, how will you solve it? Let me show you how. So 2 to the power 2007 is equal to 1000 cube. Now this is divisible by 8, this is divisible by 8. So you will assume remainder to be 8R. Okay. Now this is 125. This 8 gets cancelled. This is 2004. So 2 to the power 2004 is equal to 125 Q plus R. So now I will solve this. Mod 125. So what is phi 125? It is equals to 100. So 2 to the power 2000 is congruent to 1 mod 125, which gives me 2 to the power 2004 is congruent to 16 mod 125, and it seems the answer is coming out to be same. So your R is 16, so 8R is automatically 128. I guess your answer is coming out to be eventually the same. The answer is coming out to be eventually the same, but it is wrong explanation. If you do this question like this in RMO, you will get 0 marks. I will teach, Rajiv, I will teach CRT in the next lecture. I will teach CRT in the next lecture. So it is merely a coincidence. Why I have used 8R here? Because this number is divisible by 8, this number is divisible by 8, hence the remainder has to be divisible by 8, right? Right? Right, guys? Right, guys? So this is merely a coincidence that you are getting the answer correct. What a coincidence, but it is, right? It's a funny coincidence, right? It's an amazing coincidence. Right? Got it. Now, should I write a 5 marker for you? Let me write a 5 marker for you. Right? Are you ready for a 5 marker? If you do this, I'll give you a special gift. This is a PJ exclusive. What do I call it? PJ exclusive. Right? Let ABC be last 3 digits of 7 to the power 9999. Just a second. Last 3 digits. Should I use last 3 digits? Yes. I have to use last 3 digits. DEF be last 3 digits of 11 to the power 999. GHI are last digits of 13 to the power 9999. Find, this is 5 marker, find last 2 digits, of ABC plus DEF plus GHI. See, like these are 3-digit numbers, which are essentially the last 3 digits. A special gift for those who get the answer. ABC plus DEF plus GHI. So yes, your bet is 11. You can attempt only once. You can attempt only once. Let's do it. Let's see. Now, last 3 digit is basically mod 1000. Let's do certain things. And there's a very nice manipulation here. So what is 5000? It is 400, right? You can calculate it. So 7 to the power 10,000 is congruent to 1, and it is congruent to 1001. You see, this is 7 into 11 into 13. So I can cancel 1 power here, and you cancel 7 here. So 7 to the power 999 is congruent to 143. By the same logic, 11 to the power 999 is congruent to 7 into 13, that is 91. 13 to the power 9999 is congruent to 77. Right? So just add these 3 numbers. You get 211, and last 2 digits are 11. So, see, what is Chinese remainder theorem, right? The title you must have studied. You must have seen Chinese remainder. What is the meaning of this theorem? What is the meaning of this theorem? How does it help? Okay, so let's talk about it. Let's talk about it, guys. So first of all, I'll start with a very simple problem. You have to answer this. Find minimum value of mod x plus mod y such that 13x plus 17y equal to xy belongs to integer. Let's try to solve this. Can we solve this one? So the solution of this problem is done by something called Bezout lemma. Bezout lemma. I am going to give you some time to solve it. But what does it say? Let me speak out loud. If HCF of A and B is H, if HCF of A and B is H, then there exists PQ belongs to integer such that AP plus BQ equal to. This is what we call Bezout lemma. A times P plus B times Q is equal to, right? Now, what is so unique about this lemma? What is so unique about this lemma? Just to make you understand, let's assume that, let me take two numbers 4 and 8. Can I say that their HCM is 4, their HCF is 4, right? So what this is saying is that you cannot have two integers P and Q. You will have no solution, and it will have no solution, because this whole thing is divisible by H. This whole thing is divisible by H. HCF. HCF of 4 and 8 is 4. So HCF will divide the left hand part, it will divide the right hand part. That is why we can find two integers P and Q's. This whole thing actually becomes equal. This is the important. This is the important thing, right? Are you getting my point, guys? Are you getting my point? Yes. Perfect. Now let's move on. Let's solve this one. So if you see, 13 and 17 are co-prime. They are prime also, but they are co-prime. Co-prime means their HCF is 1. HCF of 13 and 17 is 1. Right? So, when we were kids, how we used to calculate the HCF? I think this is how we used to calculate the HCF. If you remember, in last you have this as your HCF, right? So if I write these things, if I write this division in terms of Euclid division lemma, then can I get this 17 is 30 times 1, and then this becomes my dividend, and 4 becomes my divisor. So I'm getting 4 times 3. Okay. Similarly, in the end, I have 4. This is my. Now just see here. Just see here. In my equation, I want 13, I want 17, and I want was my. So I'm just circling them, whatever I require. I require 7, I require, I require. So 4 is something which I have to do away with, right? So I'm writing in this equation, I want 13, right? I'm writing this 1. In fact, this 4, right? I'll just simply replace it. I'll just simply replace by anyway. See, like I have, in fact, I can. This is what I want. I can simply have 4, the value of 4 coming from here. Can you see? I write 4 like this: 13 minus 1 upon 3. If I put this value of 4, what do I get? 17 is equal to times 1 plus 13 minus 1. Now let's multiply 3 everywhere. Can you see this? Can you see this? Then the equation. To see properly, if you compare this and this, you can see that my x is 4, y is minus 3. This value is minimum. This value is minimum. Bezout lemma always gives the minimum value of mod x. This is how to evaluate it. This is how to evaluate it. So to find first solution of this equation, we use a mechanism like this. This is called Bezout lemma. The mechanism is Euclid algorithm, more than like finding the HCF, and we are just back substitute. 13x plus 17y equal to 1. One solution is x equal to y equals minus 3. So if you remember, if you have studied my basic lecture, Then if my first solution is this, to get the next solution, I have to add 13 here and subtract 17 here. Right? Again, add 13 here, subtract 17 here, and so on. Right? Just verify. What is, so I am saying 13. This is also a solution. Let's verify this. 13 times minus 30 plus 17 times 1. Yes, this is indeed coming out to be. This is indeed coming out to be 1. Right? 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 Girish Jain. Girish Jain said that, sir, I got 7. Got 7 as answer. So this is the mechanism. Can you write, everybody? Can you write UDAN if you have understood? If you have understood it, please write UDAN, understood, done and noted. Understood, done and noted. Please. Yes, ISI will be covered. So that I have understood it properly, I have understood. Let's do one more problem. Any prime number, 23x plus, let's say 37. Let's try to solve. Let's try to solve this. 23x plus 37y equals 1. Right? You can pause the video and you can solve it. But, and like after that, you can see my solution. Let me do it. Again, similar mechanism, 23 times 1. Then this becomes my dividend. This becomes my divisor. Then 15. 9 times 1. 5. 9. 5 times 1. 4. 5. 4 times 1. My HCF. My HCF. What do I need in my equation? Let's circle them. Let's circle. I need 27. I need 20. Like, just from here. I need to remove this 40. To remove this 40, I have to go till here. Because, see, like, I can remove this 14 from here. But then, will come. To remove 9, 5 will come. To remove 5, 4 will come. Finally. Right? So, let's write 9 as 5 minus. This gives me this 4 as 5 minus. This gives me 5 times 2. This equation is helping me. 5 becomes, right? Now let's see the value of 14 times 1. 5 becomes, okay. From this equation, you get the value of 9 times 2 times 3. 9 becomes the value of, replace the value of 9. Okay. So let's write it down. 23, 14 times 1, 14 times 2 plus 1, 20, 14 times 5. From here, we are getting 23 times 3 plus 1 upon 5, because 14 was the last value we needed. get removed. Let's write it down here now. You can see finding like this is much more lengthier, but then Chinese remainder theorem is a concept which is largely oriented to RMO and INMO, right? You will not find very difficult problems from it in uh, IOQM, but it is very important concept, RMO, and right. That is why we need, and like you can see from the calculation that it is getting very lengthier, right? Right? Okay. Now, when I replace the value of 14, this is the value of 14 in this. Let's see, what do I get? 37 equals 23 times 1 plus, what was my 14? 23 times 3 plus 1 on 5. Yes. Now I'm multiplying 5 and 5 equals plus 1, right? At plus 8 plus 7 5 1. Pairing this equation with this, x equals minus y. Just to confirm, 37 times 5. 37, if you see what is 37 times 5? 37 times 5 is 185. 23 times 8 is 184. Right? That's it. X equals minus 8, y equals 5. Anonymous person. Got it. Are we clear about it, guys? Are we clear about it? You can write done. So you can move. You can move. Right? Now after this, we can actually write the statement of, you can write this statement. Chinese. Let us write. What does CRT say? If n is congruent to remainder 1 mod divisor 1, n is congruent to R2 mod D2, and so on till I have Rn mod Dn, and then there is a condition. Di's are pairwise co-prime. What do I mean by pairwise co-prime? If I take any combination of these divisors, let's say D2 and D4, let's say D3 and D6, let's say D1 and Dn, all the pairs are co-prime. This is the condition. Then n will have a solution R congruent to mod L, where L is LCM of D1, D2. Okay, this is the statement of CR. It says that it says about the existing, does not help us finding. How do we find the solution? How do we find this R? We find this R using. So let me show you with an example. This statement, this whole statement looks very strange, but when we see it using certain values, you will be able to understand. So let me give you an example using very small divisors, right? Very small divisors I am going. Okay. So let's say example n is congruent. Okay. And n, by the way, this is called simultaneous congruence. Called simultaneous. This is called simultaneous congruence. Okay, okay, just hear me out. Okay, n is congruent to 2, n is congruent, and then n is congruent. Let me take one. In fact, let me simply solve this for you, right? So if I write all the numbers which leaves 2 as remainder upon division, I can write them. If I write n congruent to 3 mod 30, right, like, right? So what I'm trying to say here is, let's find the common number between, let's find a common number which satisfies both. Common number which satisfies both. You will see that n equals 40 solves it, right? I will tell you how to solve. I will tell you how to solve. We will study. But n equals 42 solves it. You can see 42 leaves 2 as remainder upon division by 5. 42 leaves 3 as remainder upon division. Great. What is the next number? What is the next number? If you add m of 5 and simply add 60, right? If you add 65 here, you get 1 not. Now check for 107. Is it satisfying both? Yes, obviously it will satisfy. So why it will satisfy? Well, 42 plus 65, right? I'm writing 42 as 13 times q plus 3. If I'm adding 65 here, I'm adding actually multiple of 3. So this becomes 13q1 plus remainders remain intact. If I'm adding multiple of 13, my remainder will remain intact, mod 13. If I'm adding 65, it is also multiple of 5, which means that the remainder mod 5 will also remain intact. So these remainders will remain intact if I add LCM or any multiple of LCM, right? 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 Hence, that is why we have this solution of this. This is what C is saying. There exists a R here. Mod L. L was LCM of these all these numbers, all these divisors. LCM of 5 and 13 here is 65. If I take 65 LCM, then I am getting the solution for 65. The answer is, are you clear about the statement of CRT? This was just to let you know the statement of CRT. Then with the help of another problem, can I do number theory before sequence? I think yes. Number theory is great, literally very, very great. I really like number. Number theory is something very amazing. Sir, R can only be found by that AP method. So like this is very interesting. Some students who have studied AP are saying like find also part of G. This is what I tell, that JEE concepts are very, very much related. IOQM preparation must for all the JEE, right? This concept is asked in JEE, finding common terms of AP. Okay, okay, yes, yes. So let's solve it. Let's solve. If you want to solve, give me the solution of this. Right? Give me the solution of n congruent to 1 mod 5, n 3 mod 7. Let's solve this. Let's solve this, guys. Right? You can pause the video and solve this question. And I think by the time, now how I solve it, let me tell you how I solve it. First of all, these two are very small. Right? I will try to combine these. I'll simply write that n is 5p plus 1, and it is also, which means I have to solve. Right? 5p. Now this is Bezout. This is Bezout. HCF or any multiple. By observation, 5 times 3, 5 times 6, 7. Can you see it? Because these are small divisors, we can apply our number sense and get the answer. We can apply our number sense. Okay. This means I can choose P as n becomes is 6. This becomes obviously Q 6. Sorry, 31. So solution of these two, n congruent 31 mod LCM of these two, 35. Now I have come. Now I have to solve these. Will how mod 17. This is 17 1 plus 50, 35 Q1 1. This gives me 17 minus 35. Again, it is to be solved using without lemma. Okay, it is to be solved. But if you see here, find 1. You can see Q1 becomes 3, Q1 becomes 4, 1. Now you get answers. And size if P1, if I'm putting P1 equals 3, my n is 22. Mod, what is 35 times 17? Or rather, 35, 5. This is my answer. Right? You can add, like, not satisfied. Getting what you, if difference between 5 and 10, you get n 0. Interesting. Solve these, you can apply these smart methods. I agree. But it is very difficult. Obviously, it is difficult. We are talking about RMO INMO concept. We are not talking about IOQM here. IOQM is long gone. IOQM is done. Right? Sir, your voice fades away. My voice fades away in between. Sit. Sit. I don't think it should happen. Hello, 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 hello. Hello, 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 hello. Let me hold it here. It is happening because This mic is a bit loose. This mic is a bit loose. Let me. Uh, is it okay now? Is it okay now? Now let me give you another method for it. Let me give you another method. And like this method is self-developed based on my JE teaching, right? So n was congruent to 1 mod 5 and n is congruent to 3 mod 7. N was congruent to the mod 7, right? Let's solve. Let's solve this. Okay. If I write all these numbers, right? Please see properly. This is 1 mod 5. But let me see what are the remainders of these numbers mod 7. I am writing mod 7 remainders here. I am writing mod 7 remainders here. Okay. Mod 7, if I write mod 7 remainders here, this is 1, this is 6, this becomes 4. This becomes 4. Mod 7 I am writing. 16 is 2. Now are you seeing it? 1, 6, 4, 2, then becomes 0. Then minus 2 is 5, 3. This is the number which has 3 as remainder. Are you seeing the pattern here? If you are not seeing the pattern, then 1, then it becomes 6, then decreasing by 2. Why it is decreasing? Please understand. 5 is minus 2 mod 7. That is why when we talk about mods, remainders are all you have to do is to adjust. Like 1 can be written as, right? Then 0 can be interpreted as 7. Mod 7, 0 can be represented as 7. Then 5, 3. And you needed 3. So please see 1, 2, 3, 4, 5, 6, 7. So seventh term of this AP will be same. What is seventh term of this AP? This AP is 5q minus 4. What is the seventh term? 5 into 7 minus 4 equals 30. So that is how you calculate. Okay. Okay. Yes, Chinese remainder theorem. The statement of Chinese remainder theorem is right. Hello. Right. Now let's see. I have 31. Now I'm writing PC. Now my congruences are 31, 5, n is congruent. 15 mod 7. Now always write the bigger congruence. Let's write this bigger congruence. So I'm writing 1 or 30, 31, 66. Now calculate remainder. Now adding 30, which means actually plus 1. 5 is congruent to 1 mod. 35 is congruent to 1 mod. So in terms of 7 mod 17, I'm simply adding 1. I'm simply adding 1. Okay. If I add 1, what is the remainder here? I have to add. I got lucky. I got lucky. 15 is okay. Okay. This is my number. You have to watch it twice or thrice to actually understand what is going on. Because this thought process may seem very complicated, but very intuitive. You have understanding of brief understanding of AP. You have understanding of AP, it will be very simple. There is it enough to watch your two. Vinayak edits. We are premiering lectures of my previous year IOQ, and you just have to follow. Right? Just follow that. We are taking care of it. Sir, why 14? Remainder of 30. You divide 17. When you divide 30 by 17, we are not generating this number. We are not generating this number. Okay. Okay. Is it clear? Is it clear? Guys, is my voice clear? The voice problem still persists. It is coming and going. Is it? It is coming and going. Hello, 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 hello. Hello, 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 hello. It should not be the case. It should not be the case. Voice should be very clear. Is it clear now? Is it clear now? Is it clear now? Is it clear now? Can you comment? Can you comment, please? Okay, perfect. Right. So let's see if you have understood it. Let's see if you have understood it. Let's solve this one. N congruent to. Okay. Let me write. Let me make question for you. Just a second. N is congruent to 1 mod 2. N is congruent to uh, N is congruent to 4, 5. N is congruent to 0 or about 7. Is it divisible by 7? N is solve this congruence. Sir, are we going to study about binary exponent? We are not going to study about it. Mohit, there is no such rule. There is no such rule that can we combine all the divisors. It is, see, like, it is your choice how to combine. So, for example, if I were to do it, if I were to do this, first of all, see, like, calculate the LCM. The LCM is coming out to be, the LCM is coming out to be 2310. So obviously my N is congruent to something mod 2310. And I have to evaluate this something, right? My choice of, see, like, the first step to do is to convert these 5 congruences to congruent, right? Do this first. Do this first. Do this first. Okay. So if I see these three gives me something mod 40. These two gives me mod. This is my choice. I will combine like this, right? I will combine like this. See, like, the basic thing is close these two. But should be okay. Okay. Binomial theorem in number theory. Binomial theorem, obviously, I will be covering binomial theorem. Right? Okay. So let's combine. Let me write. See, very easy. One combined, and 7 is the first number. 7 is the first number. 7 is the first number. I can write n congruent. This satisfies first. So I have combined 1, 2, and 4. 1, 2, and 4 I have combined. Let's talk about 3 and 5. Let's talk about 3 and let's talk about 3 and right. 3 is 4 mod 5 is 2 mod 11. Like, there is something very amazing about mod 5. 4 mod 5 will have 4 or 9 as last digit, right? That is the beauty of 5. So I will simply solve mod 11. Mod 11 is 5, 37, 49 is my smallest number, right? 49 is my smallest number, not 49 in fact. I had to add 11. Add 11, 4, right? 24 is my smallest number. This becomes 24 mod 5, right? Am I making sense here? Am I making sense here? Are these the two congruences? Are these the two congruences? Right? Right? Okay. So now my second step is to solve these two congruent. 24 mod 55. Right? I'm going to write down this here. 24, 79, so on. But I will write mod 42 here. What is 55 mod 42? Is actually 13. So my remainder here is 24. It is becoming 37 here. You can see plus 13. Plus 13 is the key. Right? Plus, okay. Eventually, I need to have 7 here. Eventually, I need to have 8, 1. Right? Can you see it? Can you see it? Now, this I'm adding simply adding plus 13. 8, 1, 4. What I'm doing here is you'll just see the magic. Right? Right? So, here's our just recreating remainders here. Right? Right? One more. Right? Now, can you see 8, 5, 8, 5, 2? Right? The minus 3, minus 3, minus. Simply minus 3, minus 3. Right? Then minus 3. Now, please see here. 7 is of the time it is required. Why it is required? Because we are subtracting 3 everywhere. So I can see 3 series here 24, 21, 8. Then another one is 37, 34, 30. Another one is 5. Right? This sequence is of the type this will have 7. This will have 7 somewhere down the line. Now, what is this? If you see, this sequence is 12 times 3. So if you see this 11th term. Okay. Now, 11th term in this problem. 2 more, 34. We are going like this. Right? Then we will have 11th term. So if I see, if I take chunks of 3, I will have 30 terms. Then this one is 32nd term of this whole AP. If I talk about this AP, the 32nd term will leave 7 as remainder. I will solve it using Bezout lemma also, don't worry about it, right? So 32nd term. If I talk about the 32nd term, so this AP 5 You give me 30. What do I get? 0.17631. Answer is 17. So 1729. The answer becomes n congruent to 17 mod 2310. 2310. Okay. Ramanujan Hardy number. That is how I make these questions. I take a very special number. Okay. Okay. Right? Let us solve. Let us solve as out. So see, like we got till here. Now let us solve using Bez out. In fact, this will be actually simpler. 42q plus 7 is equal to 55p plus 24. Right? It is like it was. Okay. Okay. Now I will solve. 42q minus 55p equal to. Okay. Right? Let's solve this one. Yes. So again, I will write 55 as 42 times 1 plus 13. 42 is 13 times 3 plus 3. 13 is equal to 3 times 4 plus 1. That is how I have 1. I will replace this 13 by 13 minus, what was it? 13 minus 1. So this 42 becomes 13 times 7, 13 times 4 rather, times 12. 13 times 13. 68 times 4. Okay. Then do I need 42? Yes, of course I need. And 42 times 4 plus 1, 130. So 5, 42 times 1 plus of 13, 1 by 13. This becomes 55 times 13 equals 42 times. Gosh. So my solution is, you would say, sir, how do I get 17? How do I get 17? It's very simple. 42 times 7 minus 55 times 30. Right? Can you see? 42 times 7. I simply multiply with minus 70. So 42 times minus 289 minus 55 times minus 220, 70. So here I have it. I have the solution with me. Right? Now to get next solution, since fraction is here, just have to add 40. Right? So let me add 55 times 6 here. 330. Right? This becomes 330. So let me add 330. If I add 330 here, is it not? Yes. That is my solution. That's it. I don't have to go further. Because I is found 42 times 41 plus 7 be my n. What is this? 41 times 2, 82. 41 times 4 is 164, 1722 179. Right? So there I have it. This is the answer. But it requires a lot of mental calculation. You have to be fast in calculation. Is it not? Right? 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 So you just have to solve for one and get the number. The process. It's a very difficult process to see it. But sir, what is the use of all this? The use of all this. So let me solve. Let me solve RMO 1990 problem, which asked find last three digits. Find last three digits 2 to the power 19. This was the question. Now my Euler function, my Euler totient function. Euler function gives 2 to the power 4. It does not help. The totient divisors and the dividend are co-prime. Okay. Okay. So how to solve it? How to solve it? Basically, last three digit are remainders mod 1000. Right? Remainder mod 1000. If you see, this is 8 times 125. So if I write n congruent to something mod 125 and n congruent to something mod 8, this will have a solution n congruent to something mod 1000. By CRT, I will have this solution. This will be my answer. This is the last three digits. N is 2 to the power 19. So what you need to help me here is very weak in calculation. So just find this for me. Can you tell me what is this? Can you tell me what is this? 2 to the power 1990. XDAC you will understand. Zero. Yes, obviously it is divisible by 8. Perfect. Help me here. Help me here. Help me here, guys. Mod 125. How to solve it? Now I'll solve this. I Euler totient. 2 to the power, this is 100. 2 to the power 100 is congruent to 1. Mod 120. Okay, this means 2 to the power 1000 is congruent to 1. Now, how to solve 2 to the power 199? How to solve 2 to the power 1990? I have a solution. I have a method here. I have a method here. Right? Let me help you out. See, 2 to the power 2000 can be written as 126. 2 to the power 1999 is 63, or it can be written as 188. 188. 188. Remove two powers. This becomes, you divided by 47 becomes 25, and this is also divisible by 4. 1995 becomes 40. So we have reached till here, congruent to 43, which again gives 160. This is a jackpot. 168 is actually divisible by 8. So 1992, 146, 173, 198, 99, 2 to the power 1990 congruent to 99 mod 125. This is I have. This is what I have. Right? Right? 2 to the power 1990 is congruent to 99 mod 125. 99 or 44 or 24? 99 only. Is it 99 or something else? 99 or something? And have I done correctly? Have I done correctly? You need to verify, guys. Or 10. 4 9 4 9 5. 99 is correct. 99 is certainly correct. Okay. 99 is correct. If I see this becomes, then it next term is 220, right? And then check for mod 8. Check for mod 8. 224. Then add 250 to it, because this is divisible by 4. But it is not. Oh, it is divisible by, it is 8 also. It is divisible by 8 also. This is divisible by 8. So 224 is your 224 is right. No, 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 no. 2 to the power 99 is not one mod. 2 to the power 100 is congruent to 1. 224 is the correct answer. Hindi classes are going on in recorded. Hindi classes are going on recorded for. Right? Check last power 19. Two 24 is correct. 224 is correct. 224 is correct. Checked it. Chat GPT as well. Right? Right? This concludes our Chinese remainder theorem. Right? This concludes our Chinese. I know it is a bit difficult, but this, can we move ahead now? Can we move ahead? Can we move ahead? Right? Perfect. Right? Now, write another theorem. Sn congruent to n. Or sum of digits Sn congruent to n mod Sn congruent to n mod 9. Sn congruent to n mod 9. Okay. Okay. Sn congruent. Right. Let's see the proof of it for 4-digit number. Can I write this 4-digit number as 1000A plus 100B plus 10C plus D? Now simply isolate the sum of digits. Can I write it like this? Right? The sum of digits. Can you see that this is divisible by 9? Can I say that this n congruent to Sn mod 9? This n is congruent to Sn mod 9. Start from the first lecture, Shubham. That is how you will know what is mod. You will understand mod. Okay. 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 So, question. Find S of S of S of S of S of 2 to the power. Let's assume that this is asked. Right? S of S of S. Right? 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 Now, what is happening here? Let me write a big number for you. 2, 3, 6, 7. Okay. So, what is the sum of digit here? 2 plus 3, 5. 5 plus 6, 7. 7 plus 18, 20. So, can you see Sn is congruent to 8? Now, what is S of Sn? Is it coming out to be 8? Is it coming out to be 8? So, if we apply S multiple times, it actually converges to remainder mod. Converges to remainder. So, this is what we are going to do. What is 2 to the power 1990? Can I write it as what is 59? 1 minus. So, 2 to the power 6. power in a 2 to the power 19. The answer will eventually converge to 7. Right? This is live, guys. This is live. This is live. Am I making sense, guys? Right? Hello. So what is the proof? Converges like that. Right? See, it is very simple. S of n is congruent to n. S of Sn will be congruent to Sn. Take my point? All of these will leave same remainder. All of these, right? All of these leave, right? So how will we know if Sn is very good? This is a very good question. That is why I have written sufficient number of n. How we know? Let me tell you. Let me tell you. So basically, 2 to the power 1990 is less than 10 to the power 1990. Right? 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 Obviously. Right? So this is a 1990. So the max sum of digit can be when all these are 9. 1990 times. So this becomes 1990 into 9. Right? So let's just take it 18,000. So the max SN is 18,000. And in fact, let us write 1700 so that I can maximize the sum of. If you just simply write the sum of digit of this becomes already is in. If you apply S 2 or 3 times, this number will become 2 digit or 3 digit. If you keep on if you keep on applying S of n, you get this. Right? 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 Okay. Okay. Find if n is 4 digit number such that of n 7, find all possible values of S of n plus S of n plus, right? Can you find it? Can you find it? Sir, I have studied this, but आप nice. So let us approach this problem. Now, it is a 4-digit number. So one way that it is something something, and it has, let's say, till 5 here. If you add 4 in it, this simply becomes 9, and these 3 digits remain the same. So in this case, your SN, in this case, your SN 15. But if it is something like 6 and you add 4 here, now this cannot be 9, can max be 4, can max be 4. In this case, you have 1 here, right? So whatever was the sum of digit, which was 5 of, you add 1 here. So you get 5. The sum of digits become, these are the only two options. These are the only two options, 6 and 15. There is no other possibility. There is no other possibility. No, 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 no. Can only be 6 and can only be 6 and can only be 6 and 50, right? So a similar type of problem came in IOQM. You saw IOQM 2020. A similar type of problem came in IOQM. Okay. So today we are going to study a very important thing, that is Diophantine equation. Diophantine equation basically means when the variables are more and equations are less. Variables are more and equations are less. And then we use the condition of congruence, we use the condition of divisibility to find the solutions. And in majority of the questions, we find that the solutions are integers, right? So let's start with a very simple Diophantine equation, right? When the variables are more and the equations are less. So find A, B, C. This is the start problem. A, B, C belongs to natural number such that A square plus B square equals 8C plus 3. This is a very famous problem. It has only one equation and 3 variables. So find ABC belongs to n such that it means you have to find solution in natural numbers. All ABC should be natural numbers. A square plus B square should be equal to 8C plus 3. Okay. So on Academy it showed that Ramanujan enclosed. No, 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 it is not the case. You can simply buy Olympiad subscription of 1 year. The link is in the description. Simply buy Olympiad subscription of 1 year, and then you will be allotted the batch. Yes, no solution is the answer. Why no solution? Because see, now A square is congruent to 0 or 1 mod 4, right? B square is congruent to 0 or 1 mod 4. Okay, and if you see RHS is 3 mod 4. If you add these two, A square plus B square is congruent to either 0 or 1 or 2 mod 4. It will not give 3 mod 4. In fact, I find it very fascinating. Just imagine that you cannot find any two squares which add up to a number which gives 3 as remainder upon division by. Such an interesting fact. Such an interesting fact. Right? 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 I'm not in IOQM nights batch, right? Not take it and just then tell me, sir, why are you not teaching in IOQM nights batch? I have never promoted this thing that I am in IOQM nights. IOQM nights batch is being run by a different team of an academy, right? Okay. So this was a starter question. Now We will do category 1 problem. We will basically try to do certain things. So first is xy equals to integer, right? This is the first category of Diophantine problems. In this question, usually x and y belongs to integer, right? And the underlying principle is very simple. X and y are divisors of I, right? X and y are divisors of, okay? X and y are divisors of I, okay? 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 Right? So, very simple. Let me begin with a very simple problem. Find ordered x comma y belongs to integer. It can be natural number as well, such that xy equals minus 42. Can you solve this one? Can you solve this one? Find ordered xy belongs to integer such that xy equals minus 42. So when you are doing this problem, you can actually pause the video and attempt in full and then see my solution, right? If you do not get ample amount of time to solve the problems, you can actually pause the video and see the solution later. Okay? Okay? Diophantine equations are somehow related to interviews. Some of them are related to. Like actually, indeterminate are type of diophantine, you can say. Right? Now, I will simply list the divisors of minus 42. Basically 42. Let's put 42. 1, 42. 2, 21. 3, 14. 6. Are these the 8 divisors of 42? These are the 8 divisors of 42. Right? These are the 8 divisors of 42. Okay. Now, to get the product negative, one of them has to be negative. One of them has to be negative, right? It is a very simple thing to think. One number has to be negative. Okay. And what I'm thinking here is, see, like when I have minus 1 here and 42 here, 42 here, minus 1 here, look closely. Minus 1 here, 42 here, 42 here, minus 1 here. And xy belongs to integer, right? The product. And if I get 1 here, 42 minus 42, then minus 42. So corresponding to a one divisor pair, I am getting 4 solutions here. That is what you have to think. That is what you have to think. This is the general way to think it. Are you getting it? See, why I have written all the divisors in this format, so that I can actually pair them. If you see these pairs, all of them give the product 42. 1 times 42 is 42, 2 times 21 is 42, 3 times 14 is 42, 6 times 7 is 42. And then you can actually see minus 1, 42, 42 minus 1. You can have 4 type of arrangements particular to a divisor pair. This means since you have 4 divisor pairs, you will get 16 solutions. You will get 16 solutions. Okay? You will get 16. Am I correct? Am I correct? Am I correct, guys? See what Keva, your answer of 10 is. Right? A quick trivia to you all. Yes, you have to give this answer. How is the answer this? How can this be the answer of this question? How can this be the answer of this question? Tell me, Yash. How can this be the answer of this question? Tell me. Can anybody tell me how can this be the answer of this question? This is the answer when you calculate in base 2. So 10 in base 2 is 2, 100 in base 2 is 16 is the number of solutions, right? Base 16, not base 16, base 2. Base 2. 10 in base 2 is 2, right? Right? Perfect. Let's move on. Let's move on. Let's move on. Okay. Please note it down later if you have not written it already. Now, obviously, the questions like these do not come directly, right? We will revisit these problems in permutation and combination. In combinatorics, we will revisit these problems. But for now, what we have to do, we have to do a different type of problem, right? So let's see this. Find m comma n belongs to positive integer such that 1 by m plus 1 by n is equal to 1 by. Let's solve this. Let's try and solve this. Let's try and solve this. Okay. Right? 15 solutions. 15 solutions. Obviously, we have to find the ordered pairs. Okay. Let's get on with it. So if you simply see, if you take the LCM and everything, you will get this equation. Right? I will give you 2-3 type of solutions of these problems. Can I write mn minus 12n minus 12n equals 0? Now, if you take m common here, n minus 12, and then if you take minus 12 common here, and now forcefully create minus 12 here so that you can take n minus 12 common. Now, everything in mathematics has to be done correctly. So, if you have forcefully created minus 12 here, minus 12 times minus 44, you have to add 144 on the right hand side. Now, these two equations are equivalent. You take common here, m minus 12 times n minus 12 is 140. You again have the solution. You again have the solution. And now, I'll simply replace m minus 12 with capital N, n minus 12 with capital N, 144. Now, let me do the listing again. Let's write the divisors. 1 times 44, 2 times 72, 3 times 48, I believe, 4 times 36, 6 times 24, 8 times 18, 9 times 16, 12 times 12. 12 times 12. This is a perfect square. 144 is a perfect square. If you see, one divisor pair with two solutions this time. Why? Because m comma n are also natural. M comma n are also okay. Okay, because small m and small n are natural. Capital M and capital N are also natural numbers. Okay. Now let's see 140. So every divisor pair, you see 144, 144. Every divisor pair gives me two solutions. Two solutions here, 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 two solutions. But this is a problem. If you have 12 comma 12 here, you cannot interchange. Interchanging was giving me extra solution in this case, but not in this case. So particular to this case, you will have only one. 1, 2, 3, 4, 5, 7. 7 times 2 is 14. 14 plus 1 is 15. So you have 15 solutions. 15 solutions in this equation. 15 solutions in this equation. Right? 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 Am I making sense, guys? Am I making sense? Am I making sense, guys? Done? Perfect. So do Mn belongs to Z plus. Written Z plus. It is written clearly in the question. But the both belongs to Z. Both have Z plus security. Okay. Can we qualify IOQM? We start from 9th and 10th. Also any until like I've already given the roadmap, right? You can refer to the roadmap. There is plan A as well as plan B. Now you can do plan B. Plan A is to complete everything. It is for those learners who want to attempt RMO with full range. But if you want to do this also, I call it. If you want to do only IOQM, then plan B will work. Like that is do 9th and 10th effective. Okay. Perfect. Now we will see some application of these things. Find all n belongs to natural number such that n square plus 19n plus 92 is a perfect square, right? Is a perfect square. You have to find all n such that n square plus 19n plus 92 is a perfect square. Okay. 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 N square plus 19n plus 92 is a perfect square. You have to find all such n's. All such n's. Sir, are AOPS books problem good for IOQM? AOPS, in fact, AIME problems are directly asked in IOQM. There are many problems of AIME which are directly asked in IOQM. Okay. Right? Now let's do it. Whatever it is asking, just simply write in the equation. What is it saying? That sir, n square plus 19n plus 92 is a perfect square. Let's write it. Since n is a natural number, obviously q has to be taken has to be taken a natural. Now, if I multiply it with 4, nobody should panic, right? I'm simply multiplying 4, right? 4q. Now I'll do a very simple trick here. It is 2n whole square. I'm simply completing the perfect square. 2 times 2n plus 19 19. And see, if I have to complete this perfect square, I have a square plus 2ab, which means I need to have a b square. See, I had 368 available. I had 368 available, out of which 361 has been. I'll simply write 7. And this becomes 4q. Very brilliant thing to do. If you can see here, this is 2n plus 19 whole square plus 7 equals 4q square. 4q square. So can you see here that this is the odd number and this is an even number, right? 4q square is an even number and obviously it is a square of even. So what I will simply write, this is even square minus odd square, right? This gives me 7 equals even plus odd times even minus. Now, what are the substitutions that I have used? E is 2q. This is one of my substitutions. The second substitution which I have used is that odd is 2n plus 90. 2n plus 90. Later, I will use the value. See, like I am worried about n because n is something which is asked from me. Q is a variable introduced by me. E is the variable introduced by me. O is the variable introduced. You can clearly see that there is only one solution, and O are natural numbers. E is 4, O is 3. E is 4, O is 3. Okay. E is 4, O is 3. Okay. Yes. So if you put O equals 3, you have 2n plus 9, which gives n equals minus. It is not a natural number, which is not a natural number. So if we were asked find all n belongs to integer, we would have given this as one of the answers. But now we are not getting any answer. In fact, we can verify. Let's put n plus 92 minus 19 times 8, 130. What am I getting? 1 times 8, 2, 4. The perfect square, which is a perfect square. Okay. Okay. Guys, I hope you are seeing my geometry lectures. Last Sunday, I gave you a 7-hour marathon of geometry. Obviously, it was recorded. This Sunday, this Friday, you will be getting another marathon, and that is of circle geometry. So you should refer to those videos. You should definitely refer to those videos. Okay, guys? N equals minus 8. Are you getting it, guys? Are you getting it? Isn't it just like trial and error, hit and trial? It is that. That is the beauty of IOQM problems. These solutions are obviously hit and try. These solutions, like equating E plus O with 7, E minus O with 1, this is a part of hit and trial, but there's a method to it. Basically, we are doing it using a class of problem that is xy equals integer. If you see, it also falls into this category because eventually you are getting this. Eventually you are getting this. Isn't it? Eventually you are getting this. Okay. Now, an interesting geometry problem. An interesting geometry problem. Right? A vertex is shared by two n-sided regular polygon and one m-sided regular polygon as shown. Right? This is a vertex. It is an n-sided polygon. It is an n-sided polygon. The m-sided. This is the vertex being shared. Let's call it A. Find all ordered m comma. Find all ordered m. Very simple thing. Nothing is given yet everything is given. Nothing is given yet everything is given. and Vibes channel, Rajiv Kumar. See, like, the day you stop comparing yourself from other people, you do not know their journey, you do not know about them. The day you stop comparing yourself with others and the day you start working on your self growth, that is the time when you actually start improving, right? Like, ask certain things from you. Have you made notes of all the chapters that you have studied in IOQM? Point number one. Have you solved all the PYQs of IOQM? Point number two. Have you maintained a proper homework copy of the IOQM problems that you do? Are you referring to any particular study material? For example, if you have referred to my book, then have you solved each and every problem? If you have not done these parts of the journey, if you have not completed these parts of the journey, how can you expect result? You cannot expect a result like this. The input has to be super strong. And all those extraordinary, so-called extraordinary kids must have done all these things. No, M is not equal to M. M is not equal to M. M is not equal to M. See the solutions, no, Rajiv. Rajiv, see the solutions. See the solutions from my book. That is the part of the book. Try to grasp it. And see, first of all, see all the 90, 100 lectures that I have taught. Like, see, like, it is a very specialized exam. You need to have a mentorship. You need to have proper live sessions. That is why we have courses like Ramanujan. Take ours or somebody else's. We don't mind about it. But take a proper session. Right? Anuj, this is not the equation which the equation is that this internal angle plus this internal, like M and N are not angles. M sided. These are the polygons. Right? So internal angle, right? This is the this is the angle of this is the angle. This is the measure of internal angle of n-sided regular polygon. You put n equal to 3 here, you get 64 here. You put n equal to 6 here, you right? So this angle, so this is the equation which I have. 2 times this angle and these angles are will be equal. 180 degree plus m minus 2 upon m into 180 degree equals 360 degree. The measure of these three angles, the sum of these three angles will be equal to 1, right? This is 2. Okay. So this is 2 times 1 minus 2 by m plus 1 minus 2 by m equals 2. 2 and 2 gets cancelled properly. You get 1 equals 4 by n plus 2 by m. This is the equation that we get. This is the equation that we get. Am I making sense, guys? Now, this is the type of equation which we solved earlier. Let's solve it again. Right? If I take m and n as L, 4m, 2n, I simply take it here, m 4m minus 2n, 0, so m minus 2 times n minus 4 equals 8 is what I'm getting. Right? Now, if this can be 8, this can be 1. Right? Correspondingly, my m will be 10, n will be 5. Okay? Can you see it? My m will be 10, n will be 5. Okay? If I take 1 and 8, my corresponding m will be 3, 12. Okay? Corresponding to 8 and 1. Corresponding to 2, I will get 4 here. Corresponding to 4 here. Corresponding to here. So m comma n, the ordered pairs are 10 comma 5, 3 comma 12, 4 comma 8, 6 comma 6. These are the four solutions. These are the four solutions. These are the four solutions. Okay. These are the four solutions. People are saying, sir, these solutions, these questions are very easy. Yet nobody was able to give these four ordered pairs before I wrote them. How did you do it? Can you show the factorization? How did I do it? See, it was like this. What I always do, let me give you another way to do it. Should I give you another way to do it? That will be much simpler, right? Method 2 I will give. But let me explain the first method. Let me explain the first method. First of all, from these two terms, take m as common. Now I have n minus 4 here. Take 2 common so that I have n. Now forcefully generate 4 here. Since it is n minus 4, minus 4 times minus 2 is 8. Put 8. You have m minus 2 times n minus 4 equals 8. Let me give you another method to do it, which is much simpler. Can I say that m into n minus 4 is equal to n? Can I say m equals 2n upon n minus 4? Right? Now, you can see m belongs to integer plus. M is a side. M is a side. This is much easier to do. So, my 2n upon n minus 4 has to be integer. If I simply subtract 8 and add 8 here, why I am subtracting 8? So that I can generate n minus 4 above. This becomes, so this becomes 2 plus 8 upon. Now this has become a very simple, problem now. Because all I have to do, n minus 4 should divide 8. So n minus 4 equals 1, n minus 4 equals 2, n minus 4 equals 4, n minus 4 equals 8, which gives me n equals 5, 6, 8 and 12. When I put these values here, right, let's put n equals 5 here, 10, 6, 8, 2, 4, corresponding to 12, I get 3. Is it much simpler? Is it much simpler and easy to follow? It totally depends on you how do you want to proceed. It totally depends on you how do you want to proceed. Sir, I have already enrolled in. I don't know. See, JEE 2028, if you are not sure if your coaching will be able to solve it, will be able to complete the syllabus, you can always refer to the free lectures available at Olympiad Corner. Next class will be on next Wednesday. I am taking classes every Wednesday, right? We have the schedule, no? Like I started in the month of April and we are continuing. And after JEE Advanced, we will be having more educators coming in. We will be having combinatorics from SPS sir. We will be having like combinatorics from SPS sir. We will be having algebra from a very star educator. Yes, my book is enough for IUQM. Right? Perfect. Done? Are we done? Now let me give you another problem. Find all integer n such that n square minus 19n plus 94 upon minus is an integer. Very simple problem. another type of a diophantyne problem. Can you do it? Can you do it? This is the beauty of this channel. That is why I love this channel. Everybody wants me. Everybody wants me here. Three and five. Are you sure? Are you sure? This is a very interesting problem. It's a very interesting, and it includes, see, like this problem gives you the amalgamation of a theory of algebra. Very simple application of polynomial theory. A very simple application of polynomial. Now, write your answers very, very properly. First of all, as you have seen, can I say that this is a quadratic polynomial? And if I'm dividing it with a linear one, then I will get remainder as R. And how do I get remainder R? I simply put n equals 4 here. I get 16 plus 94 minus 76. What is remainder? 110 minus 4. 34 is the remainder. Right? So I'm replacing this whole thing with q times n minus 4 plus 34 upon n minus. And this, obviously this q is integer. Now read this problem very, very carefully. Find all integer n. Find all integer n such that this is an integer. Nowhere natural number is written. This means that n minus 4 has to divide 34 integrally. Integrally means n minus 4 can be equal to plus minus 1, plus minus 2, plus minus 17 and plus minus 34. So I should get 8 values as the answer. 8 values as answer. Right? I should get 8 values as my answer. Right? So n equals 5, 3, 6, 2, 21, minus 30, 38. These are the 8 values which I have. Can you confirm? Can you confirm? Can you confirm? These are the 8 values which are my solution. These are the 8 values which are my solution. Got it? Got it, guys? Got it? Can you note it down? All these problems were related to like that xy equal to I type of problems. How did you get these 8? Calculating. Right? Like for every mathematics teacher, for every enthusiast of mathematics, calculation has to be like, it is an integral part. Arithmetic is an integral part. Right? Right? Okay. Done. Yes, like you have seen all these lectures. Have we studied the formula of number of divisors in this English course? Do you remember? Can you confirm so that I can do accordingly? Can you confirm? We have done all type of problems. I think we have done this problem, right? Yes, number of divisor problem we have. I also, okay, J 2020. Got it. Perfect. So I am satisfied with this problem now. Right? Now we will do a different type of problem, right? Right? If A, B, C belongs to natural number, find sum of all possible A plus B. See, it's a very complicated problem. Find sum of all possible A plus B plus C. So what you have to do, you have to find all ordered pairs, add them, and then add the final solution. So that A, B, C, A plus B plus is a 3 marker. Now you can see we are dealing with 3 variables. We are dealing with 3 variables and only one equation. Right? What are the odds of this? What are the odds of this? Tell me. Perfect number 6. Right? Now you must have solved it very easily. Right? You must have solved it using hit and try. Right? Now I will solve it using ordering. Let's assume that A less than equal to B less than equal to C. This gives me A plus B plus C less than equal to 3C. What is the value of A plus B plus ABC less than equal to 3C, which gives me AB less than equal to 3. Which gives me AB less than equal to 3. It has two solutions: A equal to 1, B equal to 1, A equal to 1, B equal to 2, A equal to 1, B equal to. These are the three solutions of this inequality. Since A and B are natural numbers, you can confirm. If A equals 1, B equals 1, this gives me C equals C plus 2, which is absurd. If A equals 1, B equals 2, I get 2C equals C plus 3, which gives me C equals 3. This is one acceptable. A equals 1, B equals 3, 3C equals 4 plus C, which gives me C equals 2. But this solution is not accepted. This solution is not accepted. Since I have assumed this. In fact, only one solution is this, and then I will do the permutation. See, A, B, C. I can assume it to be 1, it to be 2, it to be 3. So there is only one triplet, and now I will do the order. 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Okay, you got it. And then I simply have, I will add it to 6, 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 add it to 6. And I add these 6 numbers and I will get answer. 36 is the answer. 36 is the answer. Right? Now without, yes, that is the thing. Without loss of generality, I have assumed A less than equal to B less than equal to C. And then I have got this inequality with which I am solving it. Now, this is a proper method, isn't it? This is a proper method, isn't it? This is the proper method, isn't it? No, 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 no. See, like what I meant, right? What I meant was corresponding to all ordered triplets, add, and then the sum which you get, add all those sums. That is what I meant. That is what I meant. Right? That is what I meant. Not distinct A plus B plus. Ordered triplets. So can you explain after AB less than equal to 3? AB less than equal to 3. Now you have to, this is hit and try. But these are very limited cases, right? A and B were natural. So AB less than equal to 3 gives A equal to 1, B equal to 1, A equal to 1, B equal to A equal to 1, B equal to 1. Why I'm taking A less than equal to B? Because I have assumed it like this. I have assumed it like this, right? So, and corresponding to all these cases, I'm simply putting A equal to 1, B equal to 1 here. If I put A equal to 1, B equal to 1 here, I will get C equal to C plus, which will not give me any solution. Out to be the eventual output. A equals 1, B equals 2. A equals 1, B equals to 2. When I'm putting it here, I'm 2C, C plus C, which gives me C equals 3. It's a valid solution because it actually satisfies this inequality. When I'm putting A equal to 1, B equal to 3, I'm getting the same solution but arranged like something else. So I'll simply take this solution, which is the only solution which is possible, and then I'm ordering. I'm permuting. This is called permuting. Can it be solved by AMGM? Right? I always get this. I always get this query. Because this is the product of numbers. This is the sum of numbers, right? Right? Okay. Let's do it, guys. Let's do it. Let's do one more such problem. Let's do one more such problem. Should we do one more such problem? I assumed A less than equal to B less than equal to. And then since A is less than equal to B less, A plus B plus C less than. How did I do this? This is actually A plus B plus C less than equal to C plus C plus C. Right? C equal to C, B is less than equal to C, A is less than. That is how I got it. Right? That is how I got it. Okay. Now, okay. Now, here I am giving you let A less than equal to B, less than equal to C, less than equal to D, such that A, B, C, D, E equals A plus B plus C plus D. A, B, C belongs to natural, right? Find all possible values of, find all possible values of A plus B plus C plus, do same level of reasoning, do same level of reasoning. Let A less than equal to B less than equal to C. What's your age? I am 42 years old. I am 42 years old. 42. Like what are the ordered 5 tuples that you are getting? Yes. What are all 5 tuples that you are getting? One, one, one. No, 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 no. We do not have to permute. Yes, you are getting it all wrong. You should not permute here. Should not permute here. Written A less than equal to B. Why there is need of permutation? Why there is need of permutation? Why there is need of permutation? Right? Now this is the problem. This is the problem here. Last time you got the solution using hit and last time you got the solution. This time you will not get. You will not get solution through only hit and trial. Let me give you the solution of it. Right? Right? Again, since A less than equal to B, less than equal to C, less than equal to D, this means that the sum is less than equal to 5E, 5 times E, right? And this gives me A, B, C, D, E, since the product is equal to the sum. So the product of A, B, C, D is less than equal to 5. Now just assume, this is the beautiful part. If A equals to, my B, C have to be, if A equals to 2, it implies A, B, C, D have to be greater than equal to 60. Why? Because B, C, D are greater than equal to. The least value which B, C, D can take is 2. 2 to the power 4 is 16. With this means, is the contradiction, hence A has to be 1. This is the only possible value of A. This is called boundedness. Now, B, C, D less than equal to. Again do the reasoning. If B equals 2, my B, C, D will be greater than equal to 8, which is another contradiction, hence B. So my C, D is less than equal to. This is where I am. This is I am. Okay. Okay. So my problem is now very simple. My A and B have come out to be 1 and 1. So the problem is CDE 2 plus C plus C plus D. Okay. This is what I have got. Now C is 1, D is 1, 2, 3, 4, 5. Right? These are the 5 solutions. For C equals 2, my D equals 2 only. It cannot be 3. So let me put C equals 1. If I put C equals 1, this is the case. DE equals 3 plus D plus E. DE minus D minus E plus 1 equals 4. D minus 1. D minus 1 gives me 4. This gives me D equals 2. E equals 5. Since my D is or D equals 3, E equals 3. Right? These are the two solutions that I am getting from this equation. So I am writing the tuples here now. 1, 1, 1, comma 3, 3. Now just verify. Just verify. If you add them up, you are getting 9. Right? You are getting 9. If you product them up, you are getting 9. This is a valid solution. 1, 1, 1, 2, 5. This is another solution. One solution, two solutions. Let's add them. 9. Let's add them. 10. Okay. Okay. So this is when your C was 1. Now if I take C equals 2, it automatically gives me D equals 2. Let's see if I get the solution. 4E equals 2 plus 2 plus 2, 6 plus E. So my E equals 2 again. Nice. So 1, 1, 1, 2, 2 is another solution. From 8, you add them up, you get 27. 27 is the answer. Is it? Can I say this is a 5 marker? Amazing 5 marker, isn't it? Amazing 5 marker, isn't it? Right? Am I making absolute sense, guys? Are you enjoying? Are you enjoying Diophantine equations? These are the problems which, when you solve, make your mind sharp. These are the problems which open your mind. These are the problems which open your mind. How 1, 1, 1, 2, 2? I assumed C to be 2. No, 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 no. My mistake. My mistake. 1, 1, 2, 2, 2. 1, 1, 1, 2, 2 was not the solution. 1, 1, 2, 2, 2. Okay. Okay. Was my mistake. So all the viewers who are watching me live, from which states are you? From which states are you, people? If you are seeing it in a recording format, you can leave a comment. Yes, IOQM is objective. IOQM is objective. Gujarat, Jharkhand, Karnataka, UP, Rajasthan, Jharkhand, Madhya Pradesh. We used to have a learner from Kerala. Perfect. Got it? Diophantine, we all are enjoying. So these were boundedness problems. Now, let A be belongs to 1. Let's say 100. Okay, let's say 100. Does that? Does that? Does that? A square 4B square in C square on 2 equals AB plus AB plus 4BC plus 2AC. Please tell me. Complex numbers are not part of complex numbers are not part of this. Should we study solution of triangles for IOQ? Obviously, solution of triangles are very much Raman level. A equals 2, B equals 4. Very good, yeah. Stewart gave up. Very good. So in these type of problems, if you see very carefully, you are getting A square plus 4B square plus 16C square equals 2AB plus 4AC plus 8BC. If I put 2b equals q, 4c equals r, I get a square plus q square plus r square. Now 2ab becomes aq, 4ac becomes ar, and this becomes qr. So if, and this is a very well known inequality, you remember a square plus b square plus greater than equal to ab plus bc plus ca, and equality holds when a equals b equals c, when equality holds. So the equality is holding. This means a equals q equals r, gives me a equals 2b. Okay, now what I have to do? While calculating the solution, I can simply equate it with, if you see, my solution is c comma 2c comma, this is my solution. So if I put c1, I get 2 here. This is ordered triplet. If I put 2 here, I get 4, right? Can you see here that I can take till 25, so that I get 100 here, right? I will get in total 25 solutions. In total, I will get 25, isn't it? 25 solutions, right? See, like, that is the beauty of these lectures. That is the importance of studying from. I'm very, see, like, my main USP is that I am updated educator. I remember all the IOQM PYQs. I will give you the problems which are related to IOQM, right? This, and there's a distinction. You can have problems coming from RMO, you can have problems coming from from INMO perspective. But at this point of time, you really have to do the solving as per the IOQM curriculum. How did you get 4c equal to? See, like, my A equals 4c. If 2b equals 4c means b equals 2c. So I have replaced A with 4c, b with 2c. So this is called general solution. This is how you write general solution. This is how you write general solution, right? This is how you write general solution. Okay. Okay. Okay, 2023 was a very difficult IUQM. Acknowledged it. In my opinion, IUQM should be easy only, unless they want that, unless they say that we don't want many letters getting selected for IUQM. Unless they say this. And anyway, see, if you are preparing for RMO, right? If your eventual aim is RMO, so you have to complete theory till RMO. Right? Sir, what are cutoff marks? I will make a video out of, I will make a video of it. I will make a video. Okay. Do you get it? Perfect. Now, let's do one more problem. Let ABC belongs to, let ABC belong such that mod A minus B equals 1, mod B minus C equals 2, mod C minus D. Find number of possible values of, mod A minus D. Okay. Okay. Let's do it. Let's do it, guys. You do it. Let's see. So can I say that A minus B equals plus minus 1, B minus C equals plus minus 2, C minus D equals plus minus. If I simply add them, A minus D equals plus minus 1, plus minus 2, plus minus 1. So the maximum value is 4. After that, can I take these two as positive and this as subtraction? Then I get 2 here. And then 2 as positive and 1 in subtraction. These are the only three values of mod A minus. By 2 mod A minus T, only these three values will come. Only these three values will come. Right? Right? It's a very special thing. Without loss of generality. Without loss of generality means whatever you assume, you are not losing out on. Okay? 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 Sir, as a 10th grader, how to prepare for IOQ? The 10th grader, how to prepare for IOQ? I have given the roadmap for it. I'll have a poll. Right? Done? Okay, perfect. Question. Sir, for a proper full syllabus, which playlist be followed? Which playlist to? Okay, I'll give you another problem of diaphragm. Right? Solve the equation. Integer means the solution should be integer. Okay, x cube y cube a square plus b square 20 2025. Right? 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 Integers. So see, like this is very, very trivial. A equals 0, B equals 45, A equals 45, B equals 0, A equals minus 45, B equals 0, A equals to B. So every pair will give me 4 solutions. Right? Every pair will give me 4 solutions. Right? And yeah, and another solution is plus minus B plus minus A plus minus 30 B. 4 solutions here, 4 solutions here. In total, I have 12 solutions. 12 solutions. Okay. Okay. In total, I have 2 solutions. Got it? 24. Why did I write? Did I write 20? I'm not written 24. So this is hit and try. This is pure hit and try. Pure hit and try. Basically, this question is dependent on your understanding of Pythagoras. See, like 3, 4, 5 is a Pythagoras triplet. If you multiply anything in 3, 4, and 5, it will be a Pythagoras. For example, if you multiply 2, if you multiply 3, if you multiply 4, right? Everything is a Pythagoras triplet. So how do you get 45? By multiplying 9 in it. So that is how you get the solution of these problems. That is how you get solution of these problems. So just try to think with any multiple of 5 as any multiple of 5 as the hypotenuse. What are the two sides of triangle? So this is called interdisciplinary approach. What is interdisciplinary here? One discipline is geometry, one discipline is algebra, one discipline is number theory. We are actually integrating all these three things in a single problem. Getting my point? Getting my point? Right? Good. Let's move on. Let's move on. This was interesting. This was interesting, isn't it? This was interesting. This was also interesting. Now, another question. Another question. This is actually not a proper Diophantine type of problem. Still, it's a good. Find remainder. Find remainder when 1 plus 42 plus 42 square plus 42 to the power 25 is divided by 1807. Very interesting problem. This is the last problem of this lecture. Very interesting one. My question is, how should I start and from where should I start? I'm a student of class and I've almost come. Netherlands, you can go to the IOQM 2025 please. Start from the first line. That is how you start if you want to follow the recording. If you want to follow the recordings, just do that. Okay. No, 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 no. 1807, 1807. You will not be able to factor. You will not be able to factorize. No, 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 yes. Not CRT. See, like, this is how, this is where your number sense will come into. What is 42 square? Is it 1764? What is 42? 42? What is 1? Just add them up. You get 1807. So 1807 is actually 1 plus 42 plus 42. Okay. Now the beautiful part. Right? Just write them in decreasing order. Right? Take this 3 consecutive 3 terms. You get 42 square plus 42 plus 1. Similarly, you get 42 to the power 20 and then again 42 square plus 42 plus 1, isn't it? And so on. These are in total 26 terms. You will eventually get 42 to the power 1. Everything is of the type, every power is of the type TQ plus 1. So can you say 1 is the remainder? Can you say 1 is the remainder? Isn't this beautiful? A wholesome different perspective. A wholesome different perspective. Okay. Do you get it? Do you get it, guys? See, like, there's no point asking how did you think of it. See, like, I am a mentor, you are my mentees, you are the learners, I am the educator, I have the experience, I have done these type of problems before. The only thing which you should be getting here is, like, you should be doing here is write this thing in your notebook so that now you do not forget it. There's no point asking how to think like this. Once you have got the exposure, now when you get this problem in the examination, you should be able to think like base system. Okay. Base system is also called, it is also called scales of notation. Scales of notation. Okay. This is called scales of notation. Right? What is the scale of notation? Now let's go back in time. Let's go back in time. Right? Just imagine that I have how many, assume that these are oranges in white color. How many oranges are these? How many oranges are these? Right? We will start algebra very soon. What is the mic issue here? Can you tell me what is the mic issue? Is the sound low? Is the sound low, guys? Is the sound low? How many oranges can you see? Just a second. Let me adjust the volume. Let me adjust the volume. Let me adjust the volume. Increasing the volume right away. Increasing the volume right away. Hello, hello, hello. Am I audible now? Is it nice? I think my voice is audible now. I think I'm more audible now. Right? I'm more audible now. Yes, perfect. Now, you are writing it as 15. Right? But let's assume why you are writing 5, why you are writing 15, because you know that you can use the digits up to 9, 0 to 9. Now 0 to 9 are 10 digits, so we call it a decimal system. Right? Now just imagine you were to write this in base 5. Base 5 means you have only 5 digits available, that is 0, 1, 2, 3, 4. Just imagine. So how would I count it? 1 orange, 2 orange, 3 orange, 4 orange. Now I have 5. Now I have to write 5. But the problem is my single digits are over. I cannot do anything else. Right? So when my single digits are over in decimal system, what do I do? To write the next number, I write 0 and then add 1 here. This becomes 10. Now we are so used to it now that we find it very natural. But if I write it here, you will be a bit confused. But just imagine, you cannot use any single digit number to represent 5. 5 is the new 10, right? I would say 5 is the new 10. Then this is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. So what I'm trying to say, sir, the sound is quirky. The sound is okay. I'm not able to get what you are trying to say. I think the sound quality is good. The sound quality seems to be good here. I'm not seeing any disturbance here. Sound problem. Just a second, let me listen to it. I'm not finding any problem. To be honest, I'm not finding any problem. So let's proceed. So this is how you write 15 in base 5. Right? So in this particular section, what we are going to do? We are going to do conversions, any system to decimal. Right? Any system to decimal and decimal to any system. And we will focus on binary and hex. These are the two systems which we are going to study. Okay? Right? Clear? Am I clear, guys? Am I audible now? Am I clear now? I'll hold it here. It seems that you people are facing problem. I'll just hold it here, right? So that whenever I move, it does not create any disturbance. Okay. So this is the this is the basic nature of this particular section. You can note it down, but let me proceed. So let us write from any system to decimal. It is very, very simple. So just imagine. So this was 30 base 5. All you have to write 3 into 5 to the power 1 plus 0 into 5 to the power 0. The way we expand the numbers. So I think in your junior classes, you must have written this number in expanded form like this, right? We are assigning place value to each digits. We are assigning place values. So what am I doing here? I am assigning the place value. This is unit digit, this is tens digit. This is how to do it. And if you calculate, you are getting 15. So was 15 your original number? So to convert from any base to base 10, you simply have to write it in expanded form, right? So you can simply write A1, A2, A3, A4, A5 base B is equal to A1 into B to the power 4, A2 into B to the power 3, A3 to the B to the power 2, A4 B plus A5 to the base 10. This is how you convert from base B to base 10. This is how you convert from base B to base 10. Okay. Okay. Right? Okay. Those, see, like all these are digits. Very good. Very good. So these AIs belongs to 0, 1, 2, B minus 1. This is the base. Right? This is how the base is. Obviously, B is less than equal to 9. B is less than equal to 9 here. Okay. B is less than equal to 9. I think we are very well positioned to understand one more problem. Right? Let's do 2-3 problems based on it. Let's understand 2-3 problems based on it. Okay. Okay. Right? Are we ready, guys? Are we ready, guys? Okay. Perfect. Let's write. 1, 2, just a second. 5 base B is equal to 200 base 10. Find value of B. Let's write. Let's try and understand this. Let's try and understand this. Right? Is it 13? Let's see. B square plus 2B plus 5 equals 200. B square plus 2B minus 195 equals 0. B plus 15 into B minus 30. Now base cannot be negative. So hence I can say my B is 13. My B is 13. Can I say this, guys? Can I say this, guys? Right? My B is 13. If I start right now, how much do I have to study from? See, like, just start from the first lecture. Devote 4 to 5 hours every day. By the end of August, you will be able to complete your syllabus. Right? And the important aspect here is, if you are starting now, you have to complete the book also. Right? You have to do all problems from the book. That is how the preparation is. Preparation is not a tick mark activity that you just have seen the lecture, you are not writing any notes, you are not giving any test. See, like any type of competitive exam preparation consists of 5 things: studying from the top educator, following a proper study material, following a proper test series, doing analysis after every test so that you can understand your strengths and weaknesses. And fifth part, which is very important, is final revision. Once you have completed the whole syllabus, you should be able to revise the complete syllabus. And that is possible if you have class notes in place. That is possible if you have in place. Right? That is how it is. B equals 13. Nice. Let's do one more. Let's do one more, shall we? Now, let's see. If 1425 equals A naught plus A1 plus A22 square plus AN 2 to the power n. It is written, right? AI belongs to 0, 1, right? Find sigma AI I0 to n, right? Right? And I'll give you a very innovative method. I will give you a very innovative method to understand this question. Please tell me. I think 5. Let's see. Now, basically, my AI is 0 and 1. If you see clearly, it is a binary system. Binary system means only 2 digits are allowed, that is 0 and 1. Okay. Now, I am interpreting 1 as present. Right? In the school, we have present and absent, no? Like your teacher must be asking your name, right? Rachit, you say present, ma'am. Girish, present, sir. Saharsh, present, sir, right? This is how it is. But if you say Yash, he will be absent. He'll not say anything. So we are writing 0 for absent, 1 for present. Okay. So the trick here is, what is the largest power of 2 which is smaller than this number? 1024. I get 201. Again, largest power which is smaller than this, 140, 45. Then 128, 17, 16, and then this is 2 to the power 0. So 2 to the power 0 is present, 2 to the power 4 is present, 2 to the power 7 is present, 2 to the power 8 is present, 2 to the power 10 is present. So can I write 1425 as 2 to the power 10 plus 2 to the power 8 plus 2 to the power 7 plus 2 to the power 4 plus 2 to the power 0? It is nothing but, what I'm trying to say here is that A10 equals A8 equals A7 equals A4 equals A0 equals 1. All these 5 numbers are 1. Other than them, everything is 0. Other than them, every single thing is 0. Right? So the answer is 5. The answer is 5. Right? And that's a very good part. One learner is trying to say what is the base 2 representation. If you see what is the base 2 representation, I will start writing from right side. My A0 is 1, A1 is 0, A2 is 0, A3 is 0, A4 is 1, A5 is 0, A6 is 0, A7 is 1, A8 is 1, A9 is 0, A10 is 1. This is my base 2 representation of 1425. Right? This is the way to go. This is the way to go for binary. And binaries are very special because This is binary, right? Okay. Okay. A tan, A8, A7, A4, A0, A1. Sir, what if I start any IOQM? You can start, that's what I'm saying. Do 4 years of preparation. Do 4 hours of preparation every day. Okay. Now let me write uh, from from base 10 to any system. To any system. Right? So, let's say I have to write 1425 base 10 to 1425 base 10 to just a second. Let's see in base 8. I will follow very, very simple rule. Let me write powers of 8. Powers of 8. Let me write powers of 8. 8 to the power 0 is 1. 8 to the power 1 is 8. 8 to the power 2 is 64. 8 to the power 3 is 512. 8 to the power 4 is 4096. Right? Again. So, 512 is what I have. So, what I will do, I will subtract multiples of 512. Multiples of 512. If you see, I am subtracting 1024, which is 2 times 512. Let me subtract it. What do I get? 401. 401. Okay. Then 64. Some powers of 64. 64 6 are 6 4s are 24. 384. So this is 6 times 64. Okay. I am getting 17 here. 2 times 8. Right? And 1. Which is 1 times 8 to the power 0. So if you see properly, this is my number 2621. Right? This is how to write base 8. But this is not the most elegant way to write it because this is slightly confusing. What you have to write, you do not have to worry. Just simply keep on dividing it by 8. If you divide it by 8, write remainder here. Write remainder here. Right? So and the quotients here. 1, 62. 62 is 7. 65, 8. Remainder is 1. Divide by 8. Quotient 2, 2. 22, 2, 2. Remainder is 2. Again divide by 8. Write quotient here. What is quotient? 2. Remainder is 6. And then final remainder is 2. Once you get the quotient 0, stop. And then write in reverse. 1, 2, 6, 2. Are you getting the same answer? Are you getting the same answer? Are you getting the same answer? 2621. Rachit is saying, sir, 2621 is my answer, which is correct. Is IOQM harder than JEE Advanced? Please say. Of course, IOQM is much harder than JEE Advanced, man. IOQM is way harder. Yes. Okay, guys. Perfect. Right? Right? Then let me do one thing. 2, 3, 2, 2, base 10. You have to convert it to A, B, C, D, base 9. Find A plus B plus C plus D. Right? Tell me the answer. Tell me the answer. Can you speak more loudly? I'm already speaking more loudly. I was already speaking very loud. Got it? Is it 10? Let's see. Let's see. Right? Remainder is 0. Remainder is 0. Clearly it is divisible by 9 obviously. So you have 2, 52. 52 is 5 and then 72. Again 9. So the remainder is oh man, this is not, it is, the remainder is, let me write the quotient, 2, 78, 28 and then 6, right? 1, 3, 3. So the number is 3160 base 9, which gives me the answer 3, 1, 3 plus 1 plus 6, that is 10. Right? Right? 3 plus 1 plus 6 is 10. Okay. This means if a number is larger than a number in base 10, then its base is less than 10. Yes. Stewart Keva, you can conclude. You can definitely conclude this. You can definitely conclude this. You can definitely conclude this. Okay. Right? I hope I am making sense here. I hope I am making sense here. Okay. Okay. Let's do one more problem. Let's do one more problem. Okay. Right? Let 2, 3, 4, not 2, 798 is a naught plus a1 3 to the power 1 plus a2 3 to the power 3 plus a3 3 to the power 3. Now this is here is a catch. Ai belongs to -1, 0 and 1. Find sigma ai. Now there is a catch here. Sir, how did you get 3? Remainder. 3 was remainder. Okay, you have understood it. 0. Are you sure? Are you sure? So how do we write it? So this is, so like, first of all, since base 3 is involved here, I will write 798 in base 3. See, like, 798 divided by 3, it's a very big number. It is going to be a very big number. But what I know is it is 729 plus 729 is 3 to the power 6, right? Then when I subtract 729 here, I get 969, right? Then I plus add 54, right? Which gives me 15 plus 9 plus 6. So this is 1 into 3 to the power 6 plus 2 into 3 to the power 2 plus 3 to the power 3 to the power 3, 3 to the power 2 plus 2 into 3 to the power 1. Now what I am going to do here, I will replace 2 with 3 minus 1. Okay. Okay. Every 2 is to be replaced by 3 minus 1. What do I get? 3 to the power 6 plus 3 to the power 4 minus 3 to the power 3 plus 3 to the power 2 plus 3 to the power 2 minus 3 to the power 1. Again, I will write this 2 as 3 minus 1. So what do I get? 3 to the power 6 plus 3 to the power 4 minus 3 to the power 3 plus 3 to the power 3 minus 3 to the power 2 minus 3 to the power 1. Right? If you calculate it, you will get that this is the answer. So my A6 is 1, A4 is 1, A2 is minus 1, A1 is minus 1, and hence the sum is 0, which is correct. You guessed it correctly. Good. 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 Yes, yes, yes. That is the beauty of it. Treat minus 1 as 2. Treat minus 1 as 2. You would have got 0 here only. Right? Treat 2 as minus 1. Simply. That is the beauty of it. Right? You could have simply got 0 here. Right? 1, 2, 1, 2. Okay. Okay. Done. Okay. Perfect. So this is a very important question of base system. And now the question which I'm expecting this year. The question which I'm expecting this year is this. Right? 2, 3, 4 base 8 plus 3, 6, 5 base 8 is base 2. Right? Base 2. A1, A2, A10. AI belongs to 0 and 1. Find sigma AI. This is the question I'm expecting this year. This is the question I'm expecting this year. Please do it, guys. Please do it, guys. A10, A10, A10. 4. 4. So what I'm doing here, let me add base 8. Now, you just simply have to add. 5 plus 4 is 9. What is 9 in base? What is 9 in base? 2. Base 8. 11. 8 is 10. Carry over 1. 6 plus 3 plus 1 is 10. What is 10 in base 8? 12. 3 plus 2, 1. So this is my number. This is my number. 621 base 8. Now simply write 6, 2 and 1. Write 6 in base 2. Write 2 in base 2. Write 1 in base 1. Base 2. This is your answer. This is your answer. Right? So see, like 8 is 2 to the power 3. 8 is 2 to the power 3. 8 is what? 2 to the power 3. Okay. So what I have done here, I have simply written 6, 2 and 1 in 3 digits and then simply add them, or I would say join them. So this is your number, which means your sum of AI is 4. Okay. That is how you have done. That is how you have done. Right? That is how you have done. No, no, no. It is not a 2 marker. In the new scheme of things, it may be a 3 marker. Ah, yes, it is a 2 marker. In fact, it is a 2 marker, I guess. I guess it is a 2 marker. Right? Right? No problem. See, like you can do with other way also. This is the short trick. Okay. 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 Now let's do it. Right? Find 42nd term of the sequence which is made by sum of powers of 3 in increasing order. Right? Example, like first few terms I'm writing, what is 3 to the power 0? 1. What is 3 to the power 1? 3. Then I simply add these. Why 4 is here? Because 4 is power, sum of powers of 3. Then I have 9. Right? After that I have 10. Why 10 is here? Because 10 is powers of 3. Then I have 12. Why 12? Because 12 is 3 to the power 1 plus 3 to the power 2. So whatever the number is, if I can represent it as sum of powers of 3, then it is written in the increasing order. So you have to tell the 42nd term of this progression. You have to tell the 42nd term of this progression. Okay, okay, Stewart Keva. Right? Start from 3 to the power 0. 271 is what people are saying. The answer is 255. It will be 255. 255 is going to be the answer. That is what I think. 255 is going to be the answer. I will tell the reasoning of this. I will tell the reasoning of this. Now, see, like, what am I doing here? This is 3 to the power 0, 3 to the power 1, 3 to the power 0 plus 3 to the power 1. Now, I am writing coefficients here. I am simply writing coefficients here, right? 3 to the power 5, 3 to the power 4, 3 to the power 3, 3 to the power 2, 3 to the power 1, 3 to the power 0. So, I am writing coefficients here. Okay. 1, 1. 9 is 3 to the power 2. So, 0, 0, 0, 1, 0, 0. Now, if you see here, it is 1, 2, 3, 4 in binary. It is 1, 2, 3, 4 in binary. So, what is being done here? What is being done here? I am writing binary numbers here. So, if I see, if I go in the decreasing, if I go in increasing manner, I simply have to write 42. 42 is this, right? 32 plus 4, 36. Oh no, my mistake. 32 plus 10. So I have to write 1 here and then 0, 1 here. Okay. So 32 plus 8, 40. 40 plus 2 is 42. And then simply see what is it? It is 3 to the power 5 plus 3 to the power 3 plus 3 to the power 1. What do I get here? 243. 273 is the correct answer. Yes. Some of the learners were correct. Actually, some of the learners were actually correct. 273 is the correct answer. 273 is the correct answer. Okay. It is a complete coincidence that I asked 42. 42 has nothing to do with my classes. 42 has nothing to do with my classes. Sir, this type of question was asked in pre-INMO 29. Sum of powers of true. Yes, this is from where I have taken this question. So what you had to observe here is just write, see, like when you are writing the powers of 3, the most important thing which you need to think is there is a relation between the coefficients and the powers of 3. So the coefficients of powers of 3 is either 1 or 0. So that is how you had to think that it is related to binary. And that is why I told you people that binary is a very, 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 very important system, right? And that is why it is used in computers as well. So what I'm writing here is, I'm simply writing presence or absence of powers of 3. In the first number, my 3 to the power 0 is present, rest all the powers are absent. In 3 to the power 1, 3 to the power 1 is present, rest all the powers are absent. In 3 to the power 0 plus 3 to the power 1, 3 to the power 0 is present, 3 to the power 1 is present, and then all the other powers are absent. Then I am doing similarly for rest of the numbers as well. And when I see the pattern, this is 1 in binary, this is 2 in binary, this is 3 in binary, this is 4 in binary, this is 5 in binary, which means the 42nd term will be 42 in binary. So I have written 42 in binary and simply replace the powers of 2 with powers of 3. That is the whole thing I have done. Okay. 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 Yes, Girish, you have understood it. You have understood it. Got it? I hope I'm making sense here. Okay. Got it? Will we learn coordinate geo? Obviously, you'll learn coordinate geo. We will be learning coordinate geo for sure. I hope I have made sense here. I have made sense here. Sir, will we learn coordinate geo? Yes, we will learn. What else? Now, this was a very amazing problem. Another problem which I think will come. Right? I am writing it here. Uh, Actually, that won't come because it includes logarithm. It includes logarithm. That is why it won't come. Right? Now let's write if 72 is a0 plus a1 minus 2 to the power 1 plus minus 2 to the power 2a2 plus a3 minus 2 to the power 4 3 so on. Ai belongs to 0 and 1. Find sigma ai. Let's see if you are able to do it. I'm not sure if you will be able to do it or not. I'm not sure about it. Right? I'm not sure about it. Obviously, there has to be a method to it. There has to be a method to it. It is 2 to the power 3 plus 2 to the power 6. Yes, I think you will be able to get it. I think you will be able to get it. Wah, Ramu Naidu. Where are you from, Ramu Naidu? Don't tell me you are from Jammu, because that's very intuitive from your name. Ramu Naidu, are you from Jammu? Because I have not seen you earlier. Vizianagram. Where is it? Where is this place? Vizianagram. In this course only I'll start algebra, obviously. Andhra Pradesh. See, like, this is why I launched this course. To teach people from Andhra Pradesh, to teach people from Karnataka, to teach people from northeast of India where Hindi is not prominent. That is why I started teaching in English. Finally, my mission is reaching to the correct people. Finally, we are reaching. So, guys, please watch out for the SPSR lectures as well. They are geometry lectures. They are from also in English. We will be teaching complete English course this year. That's for sure. Before IOQM, we'll complete everything in English. That's for sure. You can rely on us, right? And all the lectures will be taken by very sincere and very senior teachers. I consider myself senior, although with my skin, you can see I'm very young, but I'm very experienced. And then SPS sir is there, and we will have Akash Gautam sir, who will be teaching algebra. My focus will be to teach you, will be to take problem solving sessions. This is my promise to you all. We will be doing one session every week live in English. So see, like, what is 72? First of all, write it as powers of 3, powers of 2. Now, I cannot have 2 to the power 3 without a negative sign, because minus 2 to the power 3 gives me negative here. Okay. So what will I do? I will simply write 2 to the power 3 as 2 to the power 4 minus 2 to the power 3. That is the beauty of it. 2 to the power m plus 2 to the power m is equal to 2 to the power m plus 1. This is a very beautiful property which is being applied here. 2 to the power 6 plus 2 to the power 4 minus 2 to the power 3. This gives me a6 equals 1, a4 equals 1, a3 equals 1. And my summation ai is 3. This question came in IOQM 2018. In 2018, IOQM was conducted twice because of the torrential rains in Maharashtra and Kerala region. In Maharashtra and Kerala, the paper was done again. So in the pre-RMO, this question was asked. Right? 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 Am I making absolute sense here, guys? every year they give a question from base system, which is a good thing for us, right? Which is a good thing for us. Thank you, Ramu Naidu. Please spread the word in your region that they are not alone. If they want to study for IOQM for free, this is the channel. Just tell them to be here. Spread the word. Please help us in spreading the word. Is this asked in JEE? Yes. Yes, in some sense or the other. Everything that we study in IOQM is directly or indirectly asked in JEE. This is pre-IRMO 2019. Okay. Pre-IRMO 2000. Like, see, like Sayak is saying it is, sir, pre-IRMO 2019. Okay. Okay. Just a second. I'm making a question. Okay. So this is another question. This will be asked in IOQM 2025 for sure. This will be asked. Right? You can take it from me. If 42.21875 is equal to a naught plus a1 2 to the power 1 plus a2 2 to the power 2 plus a5 2 to the power 5 plus b1 2 to the power minus 1 plus b2 2 to the power minus 2, so on. ai comma bi belongs to 0 and 1. Find sigma ai plus bi. I equals 0. Simply whatever is written. There is no b0, which is okay. There is no b0, which is okay. Right? There is no b0, which is okay. Okay. Let's do it. Sir, please, we will do it. We'll do it. First of all, we are learning. At the time of learning, we should not think about which problems will be coming. At the time of learning, our aim should be to learn thoroughly. सर आपका IOQM ओलंपियाड कॉर्नर पे इस साल एक भी कोर्स नहीं है फॉर IOQM. नहीं, व्हाट इज दिस यार, व्हाट इज दिस? दिस इज ओलंपियाड कॉर्नर, दिस इज IOQM course. I am teaching every Wednesday on, like, for IOQM English. Every Friday my marathons are running for IOQM Hindi. Then you are asking me, sir, is there no course for IOQM? What are you trying to say, man? What are you trying to say? What are you trying to say, man? Olympiad goal, see, like, we have already launched on Olympiad goal. It is Ramanujan course, but Ramanujan course has a cost. You have to buy, you have to purchase 1 year or 2 year subscription of Olympiad goal. That is how you get Ramanujan course. You can get the recordings of my courses from last year. Okay. Now, what is happening here? It is very simple. See, like, it is very simple that 42 can be written as, very simple, 32 plus 8 plus 2, which gives me 2 to the power 5 plus 2 to the power 3 plus 2 to the power 1, which gives me A5 equals A3 equals A1 equals 1. Am I making sense here? 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 Right? Now, what about 0.21875? What about 0.21875? No worries. Let me write it as a fraction. 1, 2, 3, 4, 5. Okay. Let me cut it using 25. Power table of 25. 8. 187 is 7. 125 is 5. Nice. This gives me, see, like this was 5 to the power 5 into 2 to the power 5. So I have two powers I have cut. It is again divisible by 25. In fact, it is divisible by 125 times 7. What is this? 6. No. 5 to the power 3. So 5 to the power 1. 35. Is it? And then this is 7. I was doing rightly actually. I was doing right. 7. So this gives me 7 upon 32. Right? I can write it as 1 plus 2 plus 4. Right? So this becomes 1 by 32 plus 1 by 60 plus 1 by 8. Which gives me 2 to the power minus 5 plus 2 to the power minus 3 plus 2 to the power minus 4 minus 3, which gives me B3 equals B4 equals B5 equals 1. So I have 3 AIs as 1, 3 BIs as 1. In total, I have 6 non-zero constants. And if I add all of them, I will get 6. Right? 6 is the correct answer. Right? Right? Yes. Ramu Naidu, this is something similar. Okay. This can become 5 marker if AI, BI belongs to -1, 0 and 1 year. Sir, how can we get those ideas like getting 7 so that the problem is simpler? This is with experience. Ramu Naidu, the thing about mathematics is that you have to spend time with it. It requires time, right? That is why I tell my learners, you need to calculate, you need to multiply, you need to divide, you need to take powers every single day. If you remember 10 powers of 2, 8 powers of 3, 8 powers of 5, if you remember table still 50, if you remember square still 50, if you remember cube still 15, then you start getting these ideas, right? You start getting these ideas, right? That 7 had to be written as powers of 2, right? Sum of powers of 2. This is what is needed. And it comes with time. Just imagine if this had a shortcut, everybody would be following it and everybody would be a math genius, right? But you can find very few people, right, who are this good, who have this level of manipulation. This means it comes with years of experience. This comes with a lot of practice, right? Now the last problem. I hope you get it. I'm very hopeful that you will be getting it, right? I hope you get it. Number 1543 AB 24 to the base 9 is divisible by 8. Find A plus B. Find A plus B. Obviously, AB belongs to 0, 1, 2, 8. Right? 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 This is a very interesting problem and very conceptual. Very conceptual. People are writing answer like anything. Ten. Girish Jain is correct. Girish Jain is correct. Girish Jain is correct. See very, very carefully. This number 1, 2, 3, 4, 5, 6, 7, 8. This number is this. Right? Right? If you see properly, this is, I can write it as 1 into 8 plus 1 to the power 7, 5 into 8 plus 1 to the power 6, 1 plus 4, right? Plus 4, right? So if I see mod 9, you can see 1 plus 5, 8q plus sum of digits. So what is the divisibility rule of 9 in base 10? It is sum of digits should be divisible by 9. How do we get it? Through the proof. Through the proof, which is like this. So in the similar manner, in base 9, the divisibility rule of base 8 is that sum of digits should be divisible by 8. Very simple. Corresponding. And this is what we call abstraction. This is what we call generalization. In mathematics, our journey is from studying particular cases to generalize them. Right? So, what I have to do? I have to simply add these numbers and I have to make it 8q. So what do I get? A plus 5b 8q. Right? So this gives me a plus b equals 5 and 30. This gives me a plus b as 5 and 30. Okay. This gives me a plus b as 5 and 30. See, like, first of all, let us understand what are divisors as such. Right? Divisors, what do I mean by divisors? And we'll follow certain nomenclatures here. If I talk about 6, right? 1, 2, 3 and 6. These are divisors of, basically these are positive divisors, right? Positive divisors of 6, right? Positive divisors. Okay. Usually in number theory, when our majority of the focus is on positive integers, that is natural numbers, usually we change these two things, like factors and divisors, interchangeable. Although when we talk about factors, it is positive divisors only, and when we talk about divisors, it is positive and negative both. Why we study negative integers, negative divisors, I'll let you know. But all the definitions, for example, the definition of prime number, a prime number has two divisors, right? When we are saying that prime number has two divisors, we mean positive divisors only, right? One and itself. So divisors are, unless otherwise mentioned, will be assumed to be positive. Okay, these three are proper divisors. Proper divisors. Proper divisors of 1, 2, 3. These are proper divisors of 6. Basically, all the divisors which are less than the number are called proper divisors. Okay. 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 Please write DN if you have understood the definition of proper divisors and total divisors, right? And we will use the help of combinatorics to actually find the number of divisors. Actually, this topic I was thinking to complete this topic in combinatorics. But then I thought otherwise. Let's do it in number theory and then we'll revise it in combinatorics, right? That is what I decided now. So when I say 6, right, let's use fundamental theorem of algebra, in fact arithmetic, to factorize it. It is 2 to the power 1 into 3 to the power 1, right? So if I am taking any divisor of 6, it will be of the type 2 to the power p and 3 to the power q, right? Where p can be 0 or 1 and q can be 0 or 1, right? Am I making sense, guys? Am I making sense? All the divisors d of 6 will be of the form 2 to the power p, 3 to the power q. 5 cannot magically appear in it, right? Because when 5 is not present in the original number, how can its divisor have 5 in it? Okay, and the power should be less because d divides the 6. All the divisors, that is why they are called divisors. Divisors divide the number, right? So these powers cannot be more than 1. Okay, and that is how we calculate the number of divisors. If I talk about dn is, if I represent dn as number of divisors of n, then dn is, see, I can select p in 2 ways and I can select q in 2 ways. So 4 divisors. That is how it is to be calculated. How it is coming? Let me illustrate. When p is 0, q is 0, my divisor is 1. When p is 1, q is 0, my divisor is 2. When p is 0, q is 1, my divisor is 3. When p is 1, q is 1, my divisor is 6. All the 4 divisors are listed here. If you see, for every p, I can choose 2q. And that is why for 2 p's, 2 into 2 is the total number of combinations, and that is how we arrive at the formula of number of divisors. The next step is to generalize it. But first of all, did you get this thing? Did you get this thing? How am I calculating the number of divisors? If you are clear about it, just write UDAN, understood, done and noted. If you have noted it down in your copies, just write UDAN, understood, done and noted. Sir, I am seeing you first time live. I hope I look more beautiful in live than recording. Right? Sir, is extra theory needed for RMO questions or just applications of IUQM levels? You see, like in RMO workshop, which we are going to conduct very, very soon, there will not be any new theory. There are certain proving techniques which we will teach, definitely. Inequalities is something which we will teach. But largely, we are covering the theory at the level of RMO only. Okay? Okay? Perfect. So now let's generalize it. Let's generalize it. Generalization of this formula. If I generalize it, let n be prime number 1 to the power a1, prime number 2 to the power a2, prime number 3 to the power a3, and so on. Then number of divisors of n, you just simply have to add 1 to it. Why? Let me just tell you. Let me just tell you why. Right? See, if I take any divisor, my prime number p1 can take power, if this is the representation of any divisor of n, then my b1 can take 0, 1, 2 till a1. So how many values are these? These are a1 plus 1 values. That is why I have written a1 plus 1 here, a2 plus 1 here, a3 plus 1 here. If somebody is asking me number of proper divisors, no problem, no problem. The answer will be dn minus 1. Okay, because the number itself is to be subtracted from it. Okay, okay, so this is elementary counting technique that you have taught. Yes. Okay, got it. So this is the number of proper divisors dn minus 1. Now let's take a great look on this formula. Let's apply it, right? If I talk about any random number, can you find dn for me? What is dn? For 1764. 1764 is a very beautiful number. It is 42 square. Let us find the total number of divisors. Can you write it in the chat? Can you just write it in the chat? Just write it in the chat. What is number of divisor for 1764? The step 1 is very simple. You have to apply fundamental theorem of arithmetic. When you apply fundamental theorem of arithmetic, then the dn becomes 2 to the power 2, 3 to the power 2, 7 to the power 2. Right? And then, sorry, this is n actually. This is n, not dn. So then dn becomes 2 plus 1, 2 plus 1, 2 plus 1. That is 27. Now, can you observe one fact above? Can you observe one fact here? It's a very important fact. Only perfect squares can have odd number of right, p1 to the power a1, p2 to the power a2, p3 to the power a3. Now, if I look at the formula a1 plus 1, a2 plus 1, a3 plus 1, dot, 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 I am already seeing here that if this is even, I add 1, this becomes odd. For this to be odd, all the numbers have to be odd, which means all AIs should be even. All AIs should be even. And hence this point, only perfect squares can have odd number of divisors. Right? 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 So cutoff for 11 this year IOQM. See, like all these things we will cover after I have done this. After I have we have the notifications. After the notification, we'll do all these type of videos. That what should be your target score, what are the cutoffs, right? Okay. Okay. For now, you should focus on learning. Like just focus on learning. Okay. Now let's write down. Let's write down all the divisors of 1764. There is a process of writing it. When you are enlisting the divisors, you should do it in a pattern, right? If you are writing 1 here, just write 1764 here, so that the product is 1764. If you are writing 2 here, simply write 882 here. If you are writing 3 here, then what comes just divided by 3, it will be 5, 8, 8. Okay. 588. 244. Oh, 294, 197. No, it will not be 288. It will be 288, right? 288. It will be 288. It will be 588 only, right? Have I? Yes, I think I have evaluated it correctly. 299. No, 294, and then 294 divided by 2 is 147. Yes, correct. Then 4. When I'm dividing it by 4, it should be a perfect square of 21. This becomes 441. Are you understanding the pattern? These things are called divisor pairs. These things are called divisor pairs. Right? This is a divisor pair, this is a divisor pair, this is a divisor pair. So if I continue, keep on continuing, if I keep on doing it like this and write it like this, then I will have this D1 D27 equals D2 D26 equals D14 square. D14 is actually nothing but 42 equals 1764. Right? Right? If I'm listing the divisors like this, and there comes one important point. If Di, Dj is a divisor pair, and Di is less than Dj, then Di will be less than square root of n, and Dj will be greater than square root of n. Very important point. Very important point. Right? Because that is how you multiply them and get n. Right? Just see this. You are multiplying these two and getting n. So one number has to be less than root n, that is 42, and one number has to be greater than root n, that is again 42. This number is greater than 42, this number is less than 42. So in this row, every number will be less than 42 except obviously the last one. This is something which is different about it. And in this list, in this column, you have every number greater than 42 except this number. Are you getting my point? This is a very important highlight. On this thing, we had a question in IOQM 2024. And this question was covered in my book. I had made a video of it that the questions are coming directly from the book. But to be very honest, this question came in AIME, American Invitational Mathematics Examination. Okay. Right? There is your IOQM series available now on YouTube. My IOQM, see, like my IOQM is available everywhere. Right? My IOQM is available in English and as well as in Hindi. Okay, please show the question again. The question, see, like we were just listing and we have just written the property. Another property is 1 divides every number, n divides every number, n divides itself, 1 divides itself. One is identity with respect to number of divisors. All these things are there. Okay. So I think we should definitely do a problem here so that all of us can understand how we have to calculate the divisors. Should we do some problems based on it? I think we should. Now, question number 1. Find all two-digit numbers which have 4 divisors. which have 4 devices. This is this is a IOQM PYQ. This I think came in 2022 or 2023. I'm not sure about the year, but this question came. And this question is inspired from KVPY examination, which used to be a very standard examination. बताइए 30. Got it. So, see, like now there is an algorithm to this problem. Obviously, this is something which is hit and try. But again, this is a directed hit and try. So, first of all, you have to understand that the n will be of the form P1, P2 or P1 cube. This is the first step. Because in this case, if it is a product of two prime numbers, then the number of devices are 4, or P1 cube, which means the number of devices are 4. Now, if I take case 1, which is simpler, which is if n is of the type prime number to the power 3, this gives me 8, 27. Prime number cube. We need prime number cube. Don't write 64 here. 64 is a silly error because 64 is actually 2 to the power 6, which has 7 devices. Right? You have to make sure that you are writing cubes of prime numbers only. Now, this is rejected since it is not a 2-digit number. This is going to be the only number. So, 27 is your one number. Now, let's talk about the second one. Second case is n is of the type PQ. Again, just see how categorically and how while making the case, I am making sure that there is some logic to it. I am taking P less than Q here, right? And then if I take P to be 5, what are the possible values of Q? Q can be 5 because again it is making it a 2-digit number. Then 7. I'm then just simply writing all the prime numbers 11, 13, 17, 19. And I can clearly see that since the product has to be a 2-digit number, the biggest prime number is 47. Okay, this you have to do mentally. 21, 23, 25, 27, 29, 31, 33, 35, 37, 41, 43, 47. So how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It is very important that you list it like this. Now, when prime number P is 3, and since I have taken P less than Q, I cannot take the case of Q equal to 2. Obviously, it is anyway rejected since it is a single digit number. Q becomes 5, 7, 11, 13, 17, 19, 23, 29 until 31. Because 31 times 3 is 93. How many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9. Then P equals 5. Q becomes, again, you cannot take Q equal to 3 here because Q equal to 3 and P like 15. The case of 15 is already covered, right? And like if you do it like this, you will ensure that there is no repetition in the cases. 7, 11, 13, 17, 19, 5. If I take case of P equals 7, Q becomes 11, 13. Right? These are the two cases. That's it, I guess. No more cases. Only these are the cases. So how many are these? 22 and 7, 29. 29 here and 1 here In total, there are 30 games. Have you understood the logic here? Have you understood the logic here? 30 is the answer. The PYQ session is next. Okay, guys, I hope you have understood this problem. This is a very important problem. And all the learners who are seeing it in recording, if you have understood something and if you like the lecture, please do leave a comment so that I know some of you are seeing this in recording. Also, in recording, like all the learners who are live also, this is my message to you all. If you're not understanding anything, just bookmark it. Just mention that this is the question which I am not being able to understand, and then just see the recording later. Okay. Okay. Now, question number 2. Let's see question number 2. Okay. Let n equal 2025 to the power 6. This is a red hot problem this year, right? Find number of divisors of n which have odd number of divisors. Odd number of divisors. Which have odd number of divisors. Which have odd number of divisors. So, strategy for revision. Strategy for revision. We have not completed the syllabus yet and you are asking the strategy for revision. I hope it is not the revision strategy for the final. Power is 6. Power is 6, guys. The power is 6. This is 6. What is IOQM? IOQM is Indian Olympiad Qualifier for Mathematics. It's highly coveted examination. It has huge respect. Now let's solve it. First of all, every time the first step is to write the factorization of this number. What is 2025? If you see 2025, it is 45 square. This means 3 to the power 4 into 5 square. Am I making sense here? So what is n to the power 6? This is 3 to the power 24 and 5 to the power 12. Am I making sense, guys? Am I making sense that n is 3 to the power 24, 5 to the power 12? Has everyone got it? And see, then the logic behind this problem is all the divisors which are favorable. Find number of divisors of n which have odd number of divisors. This means my D has to be a perfect square. So my D will be of the type 3 to the power 2p, 5 to the power 2q. And you can clearly see here that my p can take the value 0, 1, 2, 3 till 12. Why I am stopping at 12? Because 2 times 12 is 24, which is the limit for P, which is the limit for the power of 3. Similarly, when I talk about Q, my Q can be simply till 6, right? 0 till 6. So how many ways can I select P? 13. How many ways can I select Q? 7. 13 times 7 is 91. Got it? 13 times 7 is 91. So 91 is the correct answer. 91 is the correct answer. Few of you have written 90. Many learners ignore 1. 1 is also perfect square. Do not ignore 1. Obviously, we should count 1. Why not? Why not count 1? How many divisors does 1 have? 1 itself. Right? It is neither composite nor prime. What is the definition of composite numbers? Numbers having more than 2 divisors. What are prime numbers? Which have 2 divisors. So what is neither prime nor composite? 1, because it has only 1 divisor. This is my sincere request to 11th class learners. Do not prepare for IOQM separately. Just give the examination in continuation of your JEE preparation. All you need, simply, what you need is simply number theory and geometry, which you can cover from this channel. Right? Are you getting my point? Are you getting my point? Okay. Right? Sir, IOQM, live problem solving. How do I develop problem solving? See, like IOQM is like, it is a long journey, right? You do not become god of manipulation one day. It's a daily process. Every day you improve this much, right? We had this thing, right? You must have seen this in reels or somewhere, that 1.01 to the power 365 is somewhere equals 37. And 0.99 to the power 365 is like, it becomes negligible. What do I mean by this calculation? If you just put in 1% more effort every day, it compounds to 37 eventually. So 1 times 1 times 1 times 1 times 1. If you are putting 100% effort every day, 1 into 1 into 1 into 1 eventually becomes 1 only, right? Howsoever times you multiply 1, you will get the answer 1. But if you are multiplying 1.01 365 times, you are getting almost 37. This is the power of compounding. You improve every day. You will not get results in 1 week, you will not get results in 1 month, but in full year you will get results. And it's a long-term game. You are going to get results in the long run, right? You must have seen interview of Muhammad Anas, who got All India rank 42 this year. He studied for IOQM in class 9th and 10th, right? He did not get great RMO selection or INMO selection, but he was able to develop the manipulation, and he got 102 marks in mathematics. Mathematics question paper was very difficult this year in JEE Advanced. Still, he was able to get 102 out of 120, which was very instrumental for him in getting a rank like 42. 42 is a great rank. Okay. Okay. Yes, this is Atomic Habits. Very good. I am taking it from Atomic Habits. It's a very nice read. It's a very good book. Yeah, we'll launch a batch from basics. We'll definitely launch a batch from basics, right? Okay, we will launch a batch from basics. Don't worry about it. Right? Let's do another problem. Find number of divisors of 2025 to the power 6 which are less than 2025 to the power 3, but do not divide 2025 to the power 3. Okay. Okay. Yes, we will launch a new batch very, very soon. Okay. Just solve this one. Okay. Am I clear, guys? Tell us. Find the number of divisors. (42). No. So see, this problem is very simple. My n square, I will call it n square, right? I will call it n square is 22 5 to the power 6, and this becomes 3 to the power 24 5 to the power 12. My n is 25 to the power 3, which is actually 3 to the power 12 5 to the power 6. So the question is very simple. Find number of divisors of n square which are less than n but does not divide n, right? So my algorithm is very simple. I will calculate the number of divisors of n square, right? It becomes 25 times 13, that is 13 5s are 65, 13 2s are 325. Okay, what are the number of divisors of n? 13 times 7 is 91, right? If you see in these 325 numbers, right, in these 325 numbers, 162 are less than n, 162 are greater than n, and 1 is actually equal to n. Okay, are you seeing this properly? And out of these 162 numbers, in this 90 are less than n and 1 is equal to n. So can I say that out of these 162 numbers, 90 divides n. So if I subtract this 90 from here, I will get 72, which is equal to the number of divisors, 72 are the number of divisors, which are divisors of n square less than n, but do not divide n. Because 90 of these, see, like all 90 are counted here also, because it's very simple. If A divides B, B divides C, it implies A divides C. So if A is divisor of B, B is divisor of C, then A is divisor of C. Okay. So all these 90 numbers are counted in these 162. Out of these 162, these 90 are dividing n, which means 72 are the numbers which do not divide n. And this is the answer. This is the answer. Okay. Okay. Not 71 is not the answer. Right? 72 is not the answer. 72 is the answer, 71 is not the answer. Am I making sense here, guys? Am I making sense? Am I making sense here? So this is where some of the alphanumeric problems also come. This is where some of the alphanumeric problems also come. Right? Find number of numbers of the form AB, 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 which have just a second, which have 32 divisors. Very interesting problem. Very interesting problem. Which have 32 divisors. This becomes a very interesting problem. Right? A is not equal to 0 here. So this means that it is a 6-digit number. It's a 6-digit number. It is a 5 marker, guys. If you do it, it is a 5 marker. It is a 5 marker. Okay. It is a 5 marker. What if n itself is a perfect square? That you have to see. बताओ दोस्तों. Batao. Have you got the answer? Have you got the answer? 5. 5. Now it's a very interesting thing. First of all, let us analyze this number. This is AB, AB, AB. This means AB times 10101. Right? Now if I factorize 10101, I will get 3 times, 7 times, 13 times 37. Have you got it till now? Have you got it till here? Have you got it till here? Have you got it till here? Now, obviously, I already have 4 divisors. I already have 4 prime numbers as product. So, I have 2 cases now. If my n becomes 3 times 7 times 13 times 37 times a prime number, which is obviously not equal to any 4 of them, I will get dn equals 32. But P has to be a 2-digit prime number. A 2-digit prime number greater than 10 and not equal to 13 or 37. Okay. Now this is where it helps that we have 25 prime numbers in top 100. So out of these 25, I am subtracting 4, which are essentially single digit numbers. So I have 21 2-digit prime numbers. Then I am subtracting 13 and 37. So in this case, I am getting 90. In this case, so see, like this was PJ exclusive. This is the question which I have given for the first time. And I can clearly see that many of you are not getting the right answers. All the previous ones in which you were getting the answer were either PYQs or old problems. This is a new problem. And I could not get answer from any one of you in the basically the given time. Right? Why not 5? See, like this prime number cannot be 5. This prime number cannot be 5. If this is 5, your number becomes 50505. And I have written A is not equal to 0, which means it is a 6-digit number. It has to be a 6-digit number. Okay. Then my another case is if somehow I get power 3 somewhere. If I get power 3 here maybe, then this becomes 27 times 10101. Right? This is 272727. And this is 3 to the power 3, 7 to the power 1, 13 to the power 1, 37 to the power 1, which essentially has 32 divisors. 4 times 2 times 2 times 2. This is the case which is usually missed in this problem. Okay. Okay. Just see, like, Garg, solve it, no? 50, 50, 50. How many divisors does it have? Solve it. If you are claiming any answer, check for yourself, na, how many divisors does it have? 50, 50, 50 does not have the required number of divisors. Okay. So, you needed 32 divisors. This is the problem. You cannot change the nature of the problem. Sir, how can we practice the lessons taught in this course at home? Aditya, very simple. You have to solve my book. My book is available on Flipkart, Amazon, everywhere. You just can buy it, and the solutions are also written at the end. Are you getting my point? These are the two things. So in total, you have 20 cases. If you try to make this 3 to the power 1, 7 cube, I think 7 cube will also work. 7 cube will also work. It is 21. 7 cube will also work because it will be 3 into 7 into 13 into 37 into 7 square. 7 square is still 49, which means 4949 4949 will give me the correct answer. In fact, this is 9. 3 cube. Oh, I got it. In fact, I have made a mistake here. 3 cube will not work. 3 cube will not work because 3 cube will give me 90909. Okay, because 1 3 is already counted here. I was counting 3 here also and here also, which was my mistake. So only this number 494949 will be acceptable, because this is 3 to the power 1, 7 cube, and 13 to the power 1 and 17 to the 37 to the power 1, and it will give me 32 divisors. So the answer remains 20. It is like we got it correct by luck. We got it correct by luck. Right? The only case of this type will have power 3 above 7. 7 can have power 3, nothing else. Because 13 square is 169, 37 square is 1369. Okay. Wish it happens in IOQM. Yeah, we'll have to see. I don't think it will happen. Right? Got it. Perfect. Let's move on. Why you removed KUPI problems from your book? I think it was a mistake. I will again reintroduce them. Why did you subtract? Sir, I subtracted 2 because this 2 represents these two prime numbers, 13 and 37. 13 and 37. Okay. Getting my point? Okay. Question. Now another question. Let's do another problem. Okay. Find number of two-digit numbers with dn equals 8 and dn is equal to twice of dn. dn is number of divisors, right? Number of divisors. Okay. 8. What is dn? Dn is written here. Dn is equal to twice of dn. This question is very simple. This question is very simple. Basically, you have to calculate dn equals 4. You have to find all n such that dn is 4. Right? So the answer has to be 30. We have already calculated this number. We have already solved this number. Right? We have already solved it. Right? dn is twice of dn, which means, and dn is number of divisors. So all you had to do, I have just put an extra layer. Right? So if this was mac veggie, this is mac veggie with cheese. Nothing more than that, right? It is not a new problem. And still learners got confused. So in many of the problems that you face in IOQM, you will face a language problem as well. What is dn definition? It is written number of 2-digit number with dn equals 8 and dn equals this. Oh, I got your point. Where I should have written where dn is this. Where dn is this. Right? This was the meaning of the problem. It will be very clear in IOQM. When it comes in IOQM, it will be very clear. I got your point. I got your point. I did not write it properly. Okay. Now, sum of all divisors. Sum of all divisors. Right? Sum of all divisors. Right? So, first of all, I am going to write a formula here. If I am going to write a formula here, right? 1 plus r square, r to the power p minus 1. If this is s, right? Multiply by r and write it like this, right? And I'm just shifting r to the power p. See, like if I multiply r here, every term will get multiplied by r. So this 1 becomes r becomes r square becomes r cube, and r to the power p minus 2 becomes r to the power p minus 1, and r to the power p minus 1 becomes r to the power p. If I'm subtracting it, I get r to the power p minus 1. This everything will get cancelled. R minus 1 into s. So my s becomes r to the power p minus 1 upon r minus 1. Right? 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 Are you getting it? Are you understanding this sum? This type of progression in which every number is getting multiplied by a constant to get the next number, this type of progression is called geometric progression. Right? You will study this in Ayush Patni sir's lecture. Ayush Patni sir's lecture, you'll understand this. So this is sum of GP. Right? So now just see, let me illustrate, let me explain you the sum of divisors. If I call sum of divisors as Sn, right? Let's take the case of 6. Right? Divisors of 6 are 1, 2, 3, 6. So I have to add all of them. Now, can you see that I can write it like this? Can you see it? Can you see it? Right? And if you see properly, it is 2 to the power 0 plus 2 to the power 1, 3 to the power 0 plus 3 to the power 1. And it is not a coincidence that it is coming like this. It is coming like this. See, every term of this product, 2 to the power 0 into 3 to the power 0, 2 to the power 0 into 3 to the power 1, 2 to the power 1 into 3 to the power 0, 2 to the power 1 into 3 to the power 1. All these terms are actually divisors. So basically, if I generalize it for this number, 1 plus p1 square, p1 to the power a1, 1 plus p2 plus p2 to the power a2, this product will give me the sum of all divisors. This product will give me, and when I apply this formula here. How many terms are here? A1 plus 1. So P1 to the power A1 plus 1 minus 1 upon P1 minus 1 into P2 to the power A2 plus 1 minus 1 upon P2 minus 1. This is the formula for sum of divisors. This is the formula for sum of divisors. Got it? Done. Please write done. Understood, done and noted. Thank you, Garg. 100% हो जाएगा. Gayasuddin is saying, sir, if we do complete of your book, then will we qualify IUQM for sure. Perfect. This is good. This is good. Now question. See, this is the last problem. This is the last problem of the day. Yes. This is the last problem of the day. Actually, we cannot do it now. Find sum of, find all n less than 100 such that S of n equals 2n. Sum of all divisors equals 2n. Right? Right? Got it? You can buy my book from Amazon. It is called IOQM Mathematics. See now, This is a problem related to memorization. See, like, if you see properly, just a sec. If you see properly, yes, so these are called perfect numbers. What are perfect numbers? Perfect numbers are like 6, which are sum of their proper divisors. So if you see 28, 1 plus 2 plus 4 plus 7 plus 14. And there are only 2 numbers which are less than 100, and if you see properly, this becomes 2 to the power 1 into 3 to the power 1. This is 2 to the power 2 into 7 to the power 1. Okay. So usually it is of the form something like, I forgot the form. It is 2 to the power something into another prime number, right? And we can actually solve it. We can actually solve to get it, right? We can actually try to find. So like, this is one of your GBQ. You have to find general. Just write it in the comment section. You have to find the general term, general expression for perfect numbers. What are perfect numbers? Perfect numbers are those which adds up, like, so such that their proper divisors adds up to the number itself. Okay. So the answer will be 2. Okay, guys. Am I audible as well as visible? In today's lecture, we will try to complete all the previous year problems of number theory, right? So we have done all the concepts which are essential to crack all the problems, but obviously it is not like JEE that you have done a particular type of problem in a class and you will be able to do all the problems of previous year. So this is from 2017. 2017 was the first year when pre-INMO happened. Earlier it used to happen in Kolkata and Mumbai region, but in 2017 it was started as the essential stage before INMO. So let's see how many positive integer less than 1000 have the property that the sum of digits of each such number is divisible by 7 and the number itself is divisible by 3, right? The number itself is divisible by 3 and the sum of digits is divisible by 7. It essentially means that a plus b plus c, it will be a 3-digit number such that its sum of digit is 21. Are you getting it? Right? It is going to be a 3-digit number, right, in decimal, because we have to honor the divisibility rule of 3 as well. So a plus b plus c equals 21. Okay. So what do? We assume a to be 9, then b plus b becomes 12, and we have 13 solutions, right? Or not 13 solutions, in fact, it will be from 9, 3 to 3, 9, that is 7 solutions. Okay, then a equals 8, b plus c equals 11, we will have 8 solutions, a equals 7, b plus c equals 10, we will have 9 solutions, a equals 6, b plus c equals 9. How many solutions will we have? This was the key step. Now we are just counting. So this will become more clear when you go through our combinatorics lecture, right? Right? Yes, it will be from basics. So b plus c equals 9 means 10, a equals 5, b plus c becomes 14. Just a second, what am I doing? Oh, I'm solving it all wrong, right? Because when a equals 8, my b plus c actually becomes 13 and it gives me 6 solutions. A equal to 7, b plus c becomes 14, which gives me 5 solutions, right? 5, 9, 9, 5. A equals 6, b plus c equals 15, 4 solutions. So basically it will go till 1. And what is 1 plus 2 plus 3 till 7? It is going to be 28. So 28 is the correct answer of this problem. 28 is the correct answer of this problem, right? Let me verify the answer. It is yes, 28. So it's very simple. There is a method called beggar's method, which you will study in permutation and combination chapter, but that this can be done like this also, common sense. But like I said, the first step is very, very important here, that a plus b plus c equals 21. Okay, got it? Now, moving on. 28 is the answer, like I said. Now, the sum of positive integers n such that root n plus 1 less than 11. So now it has bit of algebra involved here. It has bit of algebra involved here. What will we do? See, what is it saying? That root n plus 1 plus root n is less than 11, right? This is a whole number. Okay. Now, if I rationalize it, can I just simply write it as this? Less than 11. Okay. But will it help me? I don't think it will help me. No problem. So, see, like basically, you have to understand here that root n plus 1 and root n. If root n plus 1 is 6, obviously root n will be less than 6, right? But it will be very, very near. So, what I am trying to say is, if n is 35, right? So, there is some hit and trial involved. Let's just say n equal to 35. This means it becomes root 36 plus root 35, which gives me 6 plus root 35, and it is obviously less than, obviously it is greater than 11, you can see. So, n has to be less than 35, right? N has to be less than 35. Obviously, n equals 1 is a perfect solution. 2 is also there. Now, when I take n equals 24, let's see. This becomes n plus, this becomes 25, this becomes 24, and obviously it is less than 11, because this is 5, this is 5, right? This is 5, this is less than 5. Now, when we take n, and after this, we will have problem. So, n equals 1 to 24 is not a problem. In fact, n equals 25 is also not a problem, because when you take n equals 25, you will have sufficient number. So, what we will do, we'll simply square this one. Let's square this thing. So, if you square it, you get 2n plus 1 plus 2 root n times n plus 1 less than 121. Okay. Okay. Because now you have to see this product. Now your square root is only in one number. Now let's say if n is 25, let's start taking this one. In fact, let's take n equals 30. Then this number becomes 61. 2 root 30 into 31. Let's see. Less than 121. Is it satisfying this? I think root 30 into 31. This becomes less than 30, which is not the case, because this is greater than 30. Now let me take n equals 29. This is 59 plus 2 times 29 into 30 less than 121. This becomes root 29 into 30 less than 31, which is the case, correct. So, n equal to 30 is not satisfying, n equal to 29 is satisfying. So, from n equals 1 to n equals 29, everything will satisfy. So, in all the number theory problems, in fact, all the combinatorics type of problem, you have to arrive at an expression which you can analyze. So, I can analyze this expression, right? I could not analyze the expression in which I had 2 square roots. I cannot do that simply. This is my limitation. So, only like this is not satisfying, this is satisfying. So, there is hit and trial involved, but it is targeted hit and trial. In IOQM problems, in non-routine problems, we have some, I would say, some sort of hit and trial, yes, but it will be targeted hit and trial. Okay, perfect. Moving on. So, 29 is the answer. Number theory has a lot of weightage, right? It has lot of weightage. Now, suppose x is a positive real number such that fraction part of x and x are in geometric progression. Now, what is fraction part of x? Actually, this is x. Every x can be written like this. And this fraction part is always between 0 and 1. Right? Find the least positive integer n such that, suppose x is a positive real number such that, oh, this is obviously this. It is like this. Okay. So, I square equals f into I plus f. This is what is given to us. Because the condition of geometric progression, if A, B, C are in geometric progression, your B square equals AC. Your B square equals AC. Okay. It depends on learner, right? Lot of effort is actually done by the learner, right? Just a second. Yes. Okay. So this is the one. This is what I have. So if I see here, I can see that f square plus IF minus I square equals 0. And if I solve my f, it becomes minus I plus minus root 5I by 2. And since f is positive, I can simply write it like this. And now see, if I equals 0, this becomes 0, and if I equals 1, my f becomes root 5 minus 1 by 2, which is acceptable since my fraction part is always between 0 and 1. Okay, since my f is always between 0 and 1. So, what am I getting here? My fraction part is root 5 minus 1 by 2. This is what I am getting. This is the condition, and my I is 1. So, my x, the number, becomes I plus f. So, my number becomes root 5 plus 1 by 2. Right? Find the least positive integer n such that x to the power n is greater than 100. So, but now this becomes hit and trial, right? Obviously, this becomes hit and trial now, because this now essentially becomes, this is 2.23, it becomes 3.23 by 2, almost equivalent to 1.61, right? So, 1.61 to the power n greater than 100. So, I need a least power n, right? I need a least power n. So, the n will be almost equivalent to 10. Now, this is something which is very bad. I think there has to be something given here. Like this problem came in 2017. Since it is an Olympiad problem, there is lot of estimation involved. So, what learners did? Learners tried to find certain things, right? So, this is how it is. There is a method, there is a JEE method to it. Like, let me tell you the JEE method. See, basically, when you do root 5 plus 1 by 2 to the power 10 plus root 5 minus 1 to the power 2 by 10. This essentially, this becomes, if this is I plus f, this is already f1, this becomes I plus 1. So, in JEE, we will be studying this, but you can neglect it for now. This should be given here. My whole point is that 1.61 to the power n, there is no way to calculate it, right? This is just hit and try and then. Okay, let's move on to the next problem. This was third problem. So, this is 10. Now, suppose an integer x, a natural number n and a prime number p satisfy the equation, this equals p to the power n, find largest value of prime number p, right? Now, prime number has a property that it has only two divisors, right? Like I said in the beginning of this lecture, we have done the basics which are required to ace any problem. But there is a lot of thought process involved in dealing problems like this. So for example, first of all, we will actually factorize it to this. Now see properly. This is p to the power n. Okay. Now obviously, can I say that this is p to the power alpha, this is p to the power beta, right? This is p to the power alpha, this is p to the power beta. Okay, yes, right? And now, if you see properly, p to the power alpha is x minus 6, p to the power beta is 7x minus 2. Now, if I multiply it by 7 and subtract it, p to the power beta minus 7 p to the power alpha becomes how much? 7x and 7x gets cancelled. I think it becomes 40, is it? Does it become 40? Does it become 40? Right? Does it become 40? Can I say this, that this becomes 40? Are you aligned with this equation? And now, let's assume if alpha is greater than 1, basically what I am trying to say, if you are able to take power p common, then p will divide 40 and the possible values of prime number p becomes 2 and 5 only, right? 2 and 5 only. Now, let's try to solve it. Suppose an integer x, and now integer x is satisfying. So, if p equals to, you have 7x square minus 44x plus 12 equals 2 to the power n, right? And you have to find a solution such that x is a solution. So now you just have to find a solution here. X can be anything, right? You can take x to be anything. And this should become to the power 2, to the power n, right? So if I take x equals 7, right, then I will have to solve this also, right? If I take p to the power p equals 5, then I have to solve this, that whether this becomes, so this is 1. Now, the one more thing is that if I cannot take p common, right, if I cannot take p common, so this gives me case 1. Case 1 gives me if p to the power 1 is common, right, then my p equals 2 and 5 are the two prime factors. If p to the power 1 is not possible, then obviously alpha equals 0. So p to the power beta becomes 47 and my p becomes 47, right? Now let's see. So if p equals 47, then p to the power, so my x minus 6 into 7x minus 2 becomes 47. Obviously then x becomes 7, yes. So see, like if x equals 7, then this equation is satisfied. So this is the largest prime number. We were asked the largest value of p. So I can find some n for which these two equations may satisfy, but these prime numbers are smaller than 47. 47 is the highest value of prime number that can be put here to get the answer. Right? Right? Right, guys? Right? Okay. Now this question, let's do this one. So this question was the toughest problem of 2017 pre-RMO. 2017 pre-RMO. Right? It says let PQ be a prime number such that n to the power 3PQ minus n is multiple of 3PQ for all positive integers n. For all positive integers. So basically, what is it saying? That n to the power 3PQ is congruent to n mod 3pq. Right? Right? It says this. So here we will use Euler-Tauschent function, which we studied. So 3pq, since p and q are prime numbers, right? It is 3pq 1 upon what was it? 1 minus 1 by 3, 1 minus 1 by p, 1 minus 1 by q. Okay. So phi 3pq equals 2 into p minus 1 into q minus 1. Right? Right? This is the expression. Now, what is my Euler theorem? My Euler theorem is n to the power phi n is congruent to 1 mod phi k mod k. This is my theorem. Okay. So if I multiply this with n, this becomes congruent to n mod k. So I simply have to put phi k, phi 3pq plus 1 should be any multiple of this, like it should be equal to 3pq. Phi k plus 1, this is the one. So like I got this one, right? So, and the power is 3pq. So 3pq should be equal to some integral power of this 2 into p minus 1 into q minus 1, right? Some plus 1, right? So now we have to think of certain things. So we will increase the prime number now, right? We will do the hit and trial now. P and Q are prime numbers, right? P and Q are prime numbers. So let's take P equals 7. So this becomes 21Q, n times this becomes 14 into Q minus 1, not 14 in fact, it becomes 12. 12 into Q minus 12 to minus 13, right? Now you can see here that this is divisible by Q, this is divisible by Q. So it has to be divisible by Q. So Q can be 13 only. So if I put Q equals 13, then what do I get? 21 into 13 is equal to n. 12 into 13 minus 13, 13 gets cancelled, 21 is equal to n times 11, no solution, right? This is the way to proceed. So my P equal to 7 is not giving me any solution. Now let's assume that P equals 11, which is the next prime number. I could have taken 5 also. Now if I take P equals 11, my 3 into 11, that is 33. Let's see, 33Q times n into what was my P? 11. So 20Q minus minus 20 plus 1 is minus 19. So clearly Q becomes 19. Now let's see if Q equals 19, give me solution. Equals n into 19 gets cancelled, 20 minus 1. 20 minus 1. P equals 11, right? No, 11 and 17 are the solution. That bit I remember. But this is how we have to approach. Right? Any integral multiple plus 1 is to the congruent to 1. So this has to be equal, it's any integral multiple should give me n. No. Yes, this is what I have done wrong, I think. This is what I have done wrong. No, this won't see, like this is okay. 2 times p cube minus 1. We have to, because n to the power, yes. Actually, I should have solved this. This is congruent to 1 mod 3pq. Let's do this. So this means 3pq minus 1 is multiple of 2 into p minus 1 into q minus 1. And now put p equals 11. So if I put p equals 11, 33q is 1 plus n times 20q minus 20. Is it 20q minus 20? Yes. Okay, now since this is multiple of 33, I have to find any multiple. 33q minus 1. So 20 comes common here, and this becomes integer obviously. 33q minus n times 20 times q minus 1. Right? Now let's put more integers. No. So if q, this is another prime number. So next prime number is let's say 30. If I'm putting p equals 11, then next q is let's take it 13. So 33 times 13 equals 1 plus n into, if I put, this is 20 into 12, 240. So obviously this is not satisfied because the leading now if I put q equals 17, 33 into 17, 1 plus n into this becomes 20 into 16, right? 20, so this becomes 32. What is it? 17, 1, 5, 561, is it? 17 3s are 51, 561. So this becomes 560, and this becomes 20 into 16. Again, this is not satisfied as far as I can see. Is it satisfied? 0, 0. If I can get it, no, this is not getting satisfied because the answer is p equals 11 and 17 only. Basically, p plus q is 28. 28 is the correct answer of this question. 20, and like there is some sort of hit and try involved in this, because to the power 5 minus 5n, like this should be satisfied. Yes, just a second. So see, like p divides, now with this I can say 2 divides 3pq minus 1, p minus 1 divides 3pq minus 1, q minus 1 divides 3pq minus 1. Obviously I am making some error here. If p equals 11, q equals 17, this becomes 3 into 13, 3 into 11 into 17, right? Which essentially is 17 times 33 times 17 is 561 only. Yes, 561 only, right? And this becomes 1 plus n into 2 into 10 into 16, right? This is the thing. 11 and 17, how come 11 and 17 are not satisfying? P, Q are prime numbers. So see, like this is not satisfying for sure. This is not satisfying for sure. P equals 11. No, P equals, see, like 11 plus 17. Answer is 28 for sure. I know this. We'll come back to this, right? We'll come back to this problem. We'll come back to this problem. No, this was not wrong question. This was not wrong question. I solved it some days back. I solved it in my paid classes and we evaluated it. Anyway, let's move on. We should not get stuck to one problem. Now this is directly Wilson theorem. What is Wilson theorem? Highest common factor. So n factorial plus 1 and n plus 1 factorial. So n plus 1 will divide n factorial plus 1 and n plus 1 factorial. if it is prime, so n plus 1 equals 97, n becomes 96, and the HCF becomes 97, so answer is 97, right? Right? N becomes 97. So this is direct application of Wilson theorem. This was very simple. Now, let's move on to the 2018 problem. Consider all 6-digit numbers of the form A, B, C, C, B, A, where B is odd. Determine the number of all such 6-digit numbers that are divisible by 7. Now, I did this in class already. We have to use expanded form to evaluate it. Right? Expanded form will give me this. Now, this is already divisible by 7. So, if you see, this is congruent to how much? If I divide this number by 7, 30, 28, 98, 20, 14, 60, 56, 41, 6A. This is congruent to 6A. This is congruent to, I guess, C only, because 1001 is divisible by, then 98 is divisible. So, if you see this, I can write 6A to be congruent to minus A. So, in total, I can say, if this number is divisible by 7, this means C minus A. 7 should divide C minus A. 7 should divide C minus A, that is the only thing. So, obviously, this gives me A equals C, which gives me how many solutions? Since it's a 6-digit number, A starts with 1, so 9 solutions here. Then C equals 9, A equals 2, A equals 9, C equals 2, right? Because it will be integer multiple. So 2 here. And then my B is odd. How many B can I take? 1, 3, 5, 7, 9 into 5. So 55 solutions. 55 solutions. Right? Oh, sorry. A equals 8, C equals 1 was also there. A equals 7, C equals 0. C equals 8, A equals 1. C equals, yes, these 5 plus these 9, 14 into 5, that is 70. My mistake. C, this is 70 is the answer. Why not C equal A? C equal to A I have taken. C equal to A gives me 9 solutions. And then C minus, basically mod C minus A equals 7. That is what I am solving. Mod C minus A equals 7 is what I am solving. Okay. See, there is no guarantee. Like one learner is asking, sir, if I give my 100% the course, then will I qualify IOQM as well as RMO? It does not, nobody can guarantee you this thing. If you are looking for guarantee, do not look for this course. We try, you try. See, like it is just like playing for India in World Cup, right? Indian team will give their best. They will train. They will get the best coaching. But will they be able to win World Cup? Yes or no. It can be anything. Nobody can give you guarantee. Okay, 70. Yes, so now this is base system. The equation 166 into 56 is valid in some base b greater than equal to 10. So see, like this is b square plus 6b plus 6. I can write this number like this, times 5b plus 6 equals 8b cube plus 8b square plus 9b. Okay. Now, if I solve it, what am I getting here? 5b cube. Now, what is the coefficient of b square? 6b square plus 30. 36b square, right? 30b plus 36. 66b plus 36. Okay, equals 8b cube plus 8b square plus 9b. Now, if I solve it, 3b cube minus 28b square minus 57b minus 36 equals 0. If I take 3 common, b cube, oh no, in fact b equal to 3 is not satisfied. Or now, My rational root theorem, my rational root theorem gives me that some divisors of this will be the answer. And since my b is greater than or equal to 10, the first b which I'll check is 12. Right? So 3 into 12 cube. Let's be a bit innovative. 144 into 3b is 36, 8 minus 57 minus 57 plus 57 into 12 plus 3 into 12, right? So this is the equation, right? Have I made any mistake in the equation? Have I made any mistake in forming this equation? 3b cube minus 31b square. 31b square. 8, 5. Oh, this was 5. This was 5. So this is 31b square. Yes. So this becomes 5. So this becomes 720. This becomes 720. So b equal to 12 is the answer by integer root theorem. Right? B equal 12 is the correct answer. Right? Okay. This was 8th question. Now, determine the sum of all possible integers n such that product of whose digits is n square minus 15n minus 27. So, basically, Pn product of digits is equals to n square minus 15n minus 27. Again, we will take the cases. Now, there is no theorem like this that sum of digits of n is congruent to n mod 9. This is with sum of the digits. So, this is pure hit and trial. And it is done by boundedness of functions, boundedness of these numbers. So, just look closely. If my n is clearly, I can say product of digits has to be positive or greater than, basically greater than or equal to 0. If you see, can I say that n has to be greater than 50? N has to be greater than 15. Otherwise, this number will be negative. This number will be negative. Okay. And now, if you see properly, let's look at this number. Right? If my n is 2-digit number, the maximum product that I can get is 81. 81 is the maximum product that I can get for a 2-digit number, that is 9 times 9. And if I have n equals, let's say, just 20, then this becomes 20 times 5, that is 100, it becomes 73. The product becomes 73. If n is, let's say, 21, this becomes 21 times 6 is 126, 99. So, n cannot be more than 99. Right? Product cannot be greater than 81. So, n is less than 20, greater than 50. This is the only bound for n. Now, let's calculate P16. What is P16? It becomes 16 minus 11, obviously rejected. P17, 17 times 2 is 34, that is 7, which is obviously correct. P18 becomes 18, this becomes 27, which is obviously rejected. P19 is rejected. So, this is the only thing which is accepted. So, the only number which is possible is 17. So, sum of all possible is 17 only. This is boundedness. Right? Now, this is pure hit and trial. If you see, this is pure hit and trial, but you were able to make a bound so that you have to deal with very limited integers, right? You have to deal with very, very limited integers. Okay? Okay, perfect. Right? Okay. Now let's do this one. Let t be the smallest positive integer which when divided by 11, 13, 15 leaves remainder in the set 7, 8, 9, 1, 2, 3, 4, 5, 6 respectively. What is the sum of square of digits of t? Right? Obviously, it's a Chinese remainder theorem problem. Right? Chinese remainder theorem problem. What is it saying? That t is congruent to 7, 8 or 9 mod 11. T is congruent to 13, sorry, 1, 2, 3 mod 13, and T is congruent to 4, 5, 6 mod 17. Clearly, these are 27 cases. If you see closely, these are 27 cases. Right? Right? Am I making sense? Am I making sense? These are 27 cases. 3 cases here, 3 cases here, 3 cases here. Okay. But the good thing is, if I make progression from this, I get 18, 29 possible numbers which satisfy 7, 8 or 9, 19, 30, 41, 52, right? Obviously, I'll deal with only 2-digit numbers. I'll deal with only 2-digit numbers here. Okay. Just subtract 1, 51, right? And then 20, 31, 42, 53, ... Right? I just simply have to write these arithmetic progressions. Now here I have 14, 27, and see, like, among all these numbers I have to find a smallest number, 40, 53, right? Then 15, 28, 41, 54, 16, 29, 42, 55. I'm just simply writing it like this. Now let's form these. 18. Now, do I have 18 here but 18 here, not 18 here, right? That is the thing I'm looking at. 19 and 20, right? So, just a second, not okay, 4, 5, 6. Got it. So I've done a mistake here, 4. So it becomes 21, 22, 23. Now, can I say nothing is common here? Okay. 21, 22, 23, nothing is common here. Then 38, 39, 40. Is 40 common everywhere? 40, 40, 40. 40 is common everywhere. Right? 40 is common everywhere. Can I say 40 is common everywhere? Right? Can I say 40 is common everywhere? Right? So when 40 is divided, I think 40 is everywhere. Can I confirm? 40 gives 7 remainder. 40 gives 1 as remainder. 40 gives 34, 36, 6 as remainder. Yes. 40 is the minimum number. 40 is minimum. Okay. T is the smallest positive integer which when divided by 11, 13, 15 leaves remainders in the set respectively. What is the sum of squares of digits? So sum of squares of digit is 16. Can I say this? Can I say this? Can I say this? 16 is the, and like I have written all the arithmetic progressions. In Chinese remainder theorem we did it like this. If you see, if you saw, right? Okay, then let's move on. Xn plus 1, what is this? Let me read out this problem again. What is written here? Yeah. So it says xn plus 1 equals 1 plus x1, x2, x3, xn. Right? This is what is written here. Okay. There is nothing here. basically it is x minus 1 xn, right? Now if x5 is 43, so if x5 is 43, 43 is 1 plus x1, x2, x3, x4. So this becomes 42, 1 plus x1, x2, x3, x4. What is 42? 1 into 2 into 3 into 7, right? This becomes this. So x1 is 1, x2 is 2, x3 is 3, x4 is 7, x4 is 6, x5 is 43. So what is x6? 1 plus 1 into 2 into 3 into, this is 7 obviously, 7 into 43, right? So this becomes 43 into 42 plus 1, x6, right? So this becomes 1764 plus 43, that is 1807. What is 1807? What is 1807? It is 13 times 139. So this is the largest, so 13 is the sum, right? Right? Yes, we will obviously have more problem solving sessions. We will have more problem solving sessions of it. You don't have to worry about it. We will have more problem solving sessions. Okay. Now let's move on to the next one. Yes, let A, B, C be a 3-digit number with non-zero digits such that A square plus B square is equal to C square. 3-digit number, A square plus B square equals C square. This is clearly 345, right? Or 435. Right? This is either 345 or 435. So this is what? 1 times, 5 times. This is 5 times 69. So 23 here. This is 5 times 87. 29 here. So largest possible is 29. So in this case, 29 is the correct answer. 29 is the correct answer. Now this was simple one. But this is also lateral, right? You had to apply concept of geometry, Pythagoras triplet here. Let the rational number p by q is closest but not equal to 22 by 7 among all rational numbers with denominator less than 100. Find value of, so basically see like mod p by q minus 22 by 7 is closest. This is minimum. And q is less than 100. Right? Q is less than 100. What is the value of? So, see like one way to look at it is that if I just simply multiply it with 22, 7 times 14 times 14 and I keep Q equals 98, right? If I keep Q equals 98, right, then obviously my P can be 22 into 14 plus 1 or 22 into 14 minus 1, right? That way it becomes very close to it, right? It becomes very close to it, right? It becomes very close to it, right? So let's assume Q equals 99 then. If I have Q equals 99, then I will have 99 into 7, 7p minus 22 into 99. Now what is it? Let's see what is it. This becomes, so if, obviously this has to become 1. This subtraction has to become 1. So 22 into 99 is 8, 19, 90, 198 plus 19 is 217. Yes. So this is 2177. So if I take 7p as this, then I am done. So this becomes 311. So P is 311 and Q is 99. And I am getting a unique value here. See, basically it's like you had to understand that if I keep on increasing Q, my difference will become less. So this is the answer. So 311 minus 297 gives me 14. 14 is the correct answer. 14 is the correct answer. It's not easy. I don't think it is easy. Who is saying it is easy? It is not easy. I don't think it is easy. I don't think it is easy. Right? Done. Now this problem is also, in my opinion, it is very, very heavily knowledge based. A natural number k greater than 1 is called good if there exist natural numbers a1 less than a2 ... less than ak, if this adds up to 1. Let fn be the sum of first n good numbers, n greater than n. Find the sum of values of n such that f of n plus 5 divides, and this is an integer. Now first of all, let's try to explore what is a good number. What is a good number? See, if I take two integers cannot add to 1 simply. But I know three integers adding up to 1. Why? Because of my knowledge that 1 by 2 plus 1 by 3 plus 1 by 6 is 1. This is a very important thing in mathematics. 1 by 2 plus 1 by 3 plus 1 by 6 is 1. It's obviously knowledge based. And then I simply have to do what? If I take k equals 4, right? My main motive is, can I get these two to sum to this? And then simply I assume this as this and this as this. And it is very easy to think like this. It is very easy to think like this, right? So, k greater than equal to 3 is a good number, right? Now, what is f of n plus 5? Let fn be the sum of first n. So, this becomes 3 plus 4 plus 5, right? And n plus 5 till n plus 5. So, this becomes n plus 7, yes, upon 3 plus 4 plus 5 n plus 2, right? So, what is the sum here? This becomes n plus 5 into n plus 10 upon n into n plus 5. So, n plus 5 gets cancelled. This becomes 1 plus 10 by n. So, obviously n is divisor. N is divisor of 10. So, find sum of all possible values of n. So, n is 1, 2, 5, 10. So, the total sum is 18. Total sum is 18. Okay. Total sum is 18. 1, 2, 5, 10. Right? This is sum of progressions. This is sum of progressions. This is sum of progressions. Sir, when did the classes start of IOQM crash course? I think I explained it. I do not remember, but I'll do it. I'll do it again. Right? Find the smallest positive integer n greater than equal to 10 such that n plus 6 is a prime number and 9n plus 7 is a perfect square. Okay? The smallest positive integer n greater than equal to 10. So, now my 9n plus 7 is perfect square and n plus 6 is a prime number. Right? Right? Like we have done like this. All these things are Diophantine equations. Just subtract them. 54 minus 7 is 47 equals 9p minus q square. Right? Then just keep on putting the values of p. keep on putting the values of P. If P is 7, this becomes 63, Q becomes 4, right, and N becomes 1, right, but obviously my N is greater than equal to 10. So this number is greater than equal to 97. So my perfect square is obviously, so not P equals 7, P equals 7 won't do, P equals 11. Let's put P equals 11. It becomes 99, 99. So Q square is essentially 9P minus 47, right? P equals 11 won't do, P equals 13. 117 minus 47 won't do, P equals 17. 17 nines are 153, will not do. P equals 23. 23 nines are 207. 207 minus 47, 160. It won't do again. P equals 7 was such an amazing number. Yeah. 63. P equals 27, 29. 29 nines are 261. 261 minus 47. It won't do again. Right? We have to take on different P's, right? We have to take different P's. Right? This is 54. Yeah, this is the only thing which we have to do, I guess. 9P minus Q square. So Q square is 9P minus 47. Now, if P is 7, P is 7, N becomes 1, which is not the case. N plus 6 is a prime number. N plus 6 is a prime number. Right? So we have to keep on increasing till we get, so what is 59 times 9 is 531, is it? Minus 47 is 484, which is a perfect square. So my prime number is 59 and my N is then 53. 53 is the correct answer. 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 Obviously see, like, I have to like keep on going like this. But in my opinion, and these used to be difficult pre-RMOs, right? Pre-RMOs used to be like, only in 2024 it was easy. In rest of all the years it had difficult. Like, it was very difficult. So N equals 53 is the correct answer. Now, how many ordered pairs A comma B of positive integers A less than B and AB basically are 100 to 1000 such that GCD upon LCM is this. Now let's A is HP, B HQ, where I have PQ are co-prime obviously, and P less than Q since A is less than B, and LCM becomes obviously HPQ. So H upon HPQ equals 1 upon 495. So PQ becomes 495 and P and Q are co-prime numbers. So PQ, what is 495? It is 11 times 5 times 9. Right? Right? Now, obviously P is less than Q. So PQ. P can be 1, Q can be 495. P can be 5, Q can be 99. It can be 9, it can be 45. It can be 11. Not this. It is 55. If it is 11, then it is 45. Yes, these are the 4 possibilities. And again, if P is 1, Q is 495, what is H? What is H? Because H has got cancelled. right? Right? Obviously, then your 100 and 1000, this thing will get done. So this case is not possible, right? Because both the numbers will not be in 1. $495. Oh, this is 3 square. Damn it. This is 3 square. Yeah, but it had to be together only. Right? Now, if this is the case, let's see this case. No. If 5 and 99 are my numbers, right? My HCF can be, see, like HCF can be any number, right? So my HCF can be 20, right? 20 times 5 is 100. 20 times 99 is 1980. No, this won't give me any solution. This won't give me any solution. These two will give me solution, right? So if my P is 9, Q is 55, right? Right? Then my HCF can be many things. My HCF, minimum HCF I have to take is HCF is 12, right? Maximum HCF which I can take is 55 times 20 is obviously 19. What is 19 times 5 is 95. This is not the case. 55 times 18 is 990. So 18 is the max value. So this gives me 7 solutions. What was the other case? 11 and 45. This will give me more. So in this case, HCF, minimum HCF is 10. What is the maximum one? 45 times 22 is 990. Right? So 22. So 13 cases here. So 13 plus 7 is 20 ordered pairs. 20 possibilities of A and B. 20 possibilities of A and B. This is again a tricky one. This is again a tricky one. And you can clearly see no problem is only of number theory. The counting is inherent in all the problems of number theory. Counting and number theory go hand in hand. And that is why in my book, I have kept these chapters consecutive, 4th and 5th. Yes, this is live. This is live. Nultron, this is live. Right? Perfect. Let's move on. Consider a set E of all natural numbers n such that when divided by 11, 12, 13 respectively, the remainders in the order are distinct prime numbers in an arithmetic progression. So 3, 5, 7 are the prime numbers, right? Consider set E of all natural numbers n such that when divided by 11, 12, 13 respectively, the remainders in that order are distinct prime numbers in an arithmetic progression. It can be anything, right? Like there are only one set of prime numbers, 3, 5, 7. So yeah, obviously this question is bonus because largest number, see, like Chinese remainder theorem will give me the minimum value, which is 29, right? 29 when divided by 11 gives me 7 remainder. 29 when divided by 12 gives me 5 remainder. 29 when divided by 13 gives me 3 remainder. So 29 is the smallest number, but other than that, Chinese remainder theorem says if you keep on adding the LCM, largest number can be anything. So this question was bonus, right? Now, positive integers x, y, z satisfy x, y plus z equals 17. And now you have to minimize x plus y, z min. So obviously you have to minimize the product, yz. You have to, now this is pure hit and try, right? You cannot do anything about it. So keep y and z very, very close. So if right, see, obviously if I put y equals z equals 1, then my x becomes 159 and my this sum becomes 160, right? Right? Are you getting my point? Yes. Now if just y is 1, right, just keep y as 1, and now x plus z is 160. So this gives me the solution always to be 160, right? Right? Now if I'm keeping, yeah, this is the one. If I keep z equals 1, then my xy becomes 159, which I think, which is not a prime number obviously. And then this is what? 3 times 53. So this can give me 56 when x is 53, when x is 53 and y is 3, right? 56. See, let's see if I can get more such values. So if x is 2, my xy becomes, if z is 2, my xy becomes 158, which is 79 times 2, which is obviously wrong. Z equals 3, xy becomes 157, which is 1213. This, so z equals 4, xy is 156. What is 156? This I think is interesting. 39 times 4, right? So now then, since this is 39 times 4, if I keep x equals 39 and this is 4 times 4 is 16, this gives me 55, right? This gives me 55. This gives me 55. Right? So the minimum value I have to check. Now what is z equals 5? Xy becomes 155. This is 31 times 5. So 31 plus 25 is, right, 31 times what is z equal to 4? This, acha, this becomes 13 into 12, right? (156) is 13 into 12. So I have more possibility here. 13 into 12, right? So if I take this to be 26 plus 24, this becomes 50. 50 is the minimum value. Then 50 is the minimum value. Again, this is hit and try. I have to keep on increasing the z to get the values of x and y. And the basic inherent thing is, if my number has to be closer to get the sum, right? I had to see, like if I'm assuming z equals 4, then my sum had to be minimized, so the product has to be maximized, right? Okay, moving on. Let E denote the set of all natural numbers n such that n is between 3 to 100 and the set can be partitioned into 3 subsets. Now this is permutation combination. We'll leave this one for permutation combination. Consider the sequence. Now this is interesting. Consider the sequence of numbers greatest integer of n plus square root of square root 2n plus 1 by 2 if missing integers in the sequence are n1 less than n2 less than n3, then find the What is find the? What is find the? Find the 12th number. This is what was asked, right? Find the 12th number. Okay, now this is obviously n plus 2n to the power 1 by 4 plus half. Okay, okay, right? Right, this is 2n to the power 1 by 4. N can be taken out, right, by the property of greatest integer. If any integer is there, it can be taken out. 2n to the power 1 by 4. See, like, if you see, all the problems are not doable. And that's a very false aspiration to be in, right? Till 2023, the problems of IOQM used to be very difficult. In 2024, one can have an aspiration that all questions can be understood. So this question is very tough, for example. This question is very tough, right? So our aspiration should not be that we understand each and every problem, right? Still, let me try. Now again, if n equals 1, 2 to the power 1 by 4, 2 to the power 1 by 4, right, this becomes n. So if I take n equals 1, this becomes 1 plus 2 to the power 1 by 4 is less than 1.4. So this gives me 1 only. If I take n equals 2, this becomes 2 plus 4 to the power 1 by 4 is root 2. Root 2 plus half is 1.9. 1.9 is again 1. So this becomes 3. So the number is 1, 3. N equals 3. If I take n equals 3, right? N equals 3, then this becomes 3. 8 to the 6 to the power 1 by 4 plus half 0.5. Damn it, man. 6 to the power 1 by 4 is what? 6 to the power 1 by 4. See, like 2 to the power 1 by 2. What is 2744 5337.4 1.5? See, like 1.5 cube is 337. It does not matter. 3.375 power 1 by 4. 6 to the power 1 by 4. That's so sad, right? That's so sad. 6 to, how do I evaluate 6 to the power 1 by 4? How do I evaluate 6 to the power 1 by 4? I don't understand this thing. Oh, actually guys, this is only square root of 2n. It is only square root of 2n in the question. So it is just this, right? Otherwise they would have written yes. So n and then root 2n plus 0.5. Okay, so if n is 1, and what is the sum here? This, if n is 1, this is root 2. 1.4 plus 0.5 is, so this becomes 1, it becomes 2. If n is 2, this becomes root 4, which is 2. 2.5, this becomes 2, this becomes 4. If n is 3, this becomes root 6. Root 6 is roughly, what is root 6? Now, root 6 is roughly 2.45, not 2.5. So this becomes 2. So this becomes 5. If this is 4, you can see here that n, this is 4. Root 8. Root 8 is 2.7. So this becomes 3. This becomes 7. Right? So the numbers which are missing here is 1, 3, 6. So these are triangular numbers. If you see properly, these are triangular numbers. right? These are triangular numbers. And in fact, if you look closely, this is root n plus 1 by root 2 ka whole square. Now we have understood this thing. This is root n plus 1 by root 2 ka whole square, if you see this, right? And we are asked integer of this. So the triangular numbers are missing. So what is the 12th number? N into n plus 1 by 2 is the general term. So 12 times 13 by 2, the answer is 78. The answer is 78. Right? Yes, Ronit knew the correct question. Ronit knew the correct question. Okay, let's move on. Okay. So now find the number of positive integers less than 101 that cannot be written as difference of two squares of integers. Find the number of positive integers less than 101, right? So if you see, 4 squares are of the type 4q and 4q plus 1, right? So 4q plus 2 type numbers cannot be written as difference of squares of two numbers, right? 4q, yes. And similarly, just a second, 4q. So 9, just a second, 16 minus 9 is 7. Yes. Only this type of number. Only this type of number, right? Only this type of number, yes. My book is beginner friendly. Like combine it with my Envision book, then it is more friendly. Right? So how many are 4q plus 2 type? 25 type numbers. So 25 is the answer. Yes. Okay. Now let n be the smallest positive integer n such that n3 and n2 n3 is a number of all whose digits. What is this? What is this? n2 n3 is what? Oh, n plus 2n plus 9n has same digits. So this is becomes 45n. Right? N plus 2n plus 3n is a number all whose digits are equal. Right? All whose digits are equal. So obviously see, 45n has to be equal to 55555, right? And since it is divisible by 5, so I have to write 9 5s. I have to write 9 5s, right? So these are 9 5s. So if you see, this becomes 1 1 1 1 1. So n becomes 37 0 37 0 37. So sum of n is 30, right? Oh no, shit. This becomes 1 2 3 4 5 6 7 9. So Sn equals 37. My bad. I could not divide it properly. My bad. Yes. Now Sn denote the sum of digits of a positive integer n to the base 10 if sum of digits Sm is 20 and S of 33m equals 120. What is the value of S of 3m? Right, this is asked from me. Now if you see, S30m I can write it like this, is less than equal to, right? See, I can clearly say, just a second, 3m see, like if my SM is 20, obviously my S33m is 120. So m, just a second, my m is congruent to 2 mod 9, 33m is congruent to 66, which is congruent to 33m is congruent to 4, 3. Yes, so this is correct. It is not something which is incorrect information. So SM is 20, sum of digits is 20, and S33m is 120. So the number is very big, it seems. Number is very big, because see, like if S33m is 120, it is at least 13-digit number. It is at least a 13-digit number, right? Are you getting my point? It's at least a 13-digit number. Okay. So that is what we will do here. If S33m is 120, I can say that 33m is at least a 13-digit number will also give me only 117. So it's a 14-digit number at the least. 14-digit number. Oh, damn it. Right? So let's do it. So it's a very big number. Now, what is 30m and 3m? Right? So if you see, like, can I say that sum of digits of m and sum of digits of 10m is same, right? Because when you are multiplying it by 10, you are simply pasting 0 at the end, right? So can I say that this is S30m is equal to S3m, right? That is for sure. S30m equals S3m. This is for sure. Yes, this is for sure. Okay, and yes, this is for sure. S30m equals S3m, and now S30m plus S3m is greater than equal to S33m. Since like this is a very simple concept, S of A plus B is greater than SA plus SB is greater than equal to S of A plus B. Why? Because see, like if you see S of A, let's take A equals 18, B equals 19. So SA becomes 9, SB becomes 10. So these sum of digits are getting added separately. But when you add A and B, this becomes 37, and this number become less. This number becomes less, right? So this means, and these two are equal, and this is what I have to find. So S3m is definitely greater than equal to 60. S of 3m is greater than equal to 60. Now SM is 3SM is greater than equal to S of 3m. 60 greater than equal to S of 3m. So if I see these two inequalities, my S of 3m is greater than equal to 60, S of 3m is less than equal to 60, which implies that actually S of 3m is 60. Okay, S of 3m becomes 60. Okay. Again, boundedness. Yes. Now, again, I pre-RMO 2019. So pre-RMO in 2019, I guess pre-INMO happened twice. FKAB, a plus b to the power k minus a to the power k minus b to the power k. Let S, for how many ordered pair AB with AB belongs to S, A less than equal to B, F5 AB upon F3 AB is an integer, right? So basically see like a plus b to the power 5 minus a to the power 5 minus b to the power 5 upon a plus b to the power 3 minus a to the power 3 minus b to the power 3. So this gives me what? 5a4b plus 10a cube b square plus 10a square b cube, binomial theorem basically, 5ab to the power 4 upon 3a square b plus 3ab square. If I cut this ab, so I get 5a cube, 10a cube, right, 10a square b, ab square plus 5b cube upon 3 times a plus b. So this becomes 5 by 3 times, if you see here, this becomes a cube plus 2a square b plus 2ab square plus 1 upon plus b cube upon a plus b. Now what is it? If you see closely, a cube, if I write it like this, I should not have any problem. And then this becomes a plus b whole cube minus ab into a plus b, and then a plus b gets cancelled. A plus b gets cancelled. So the numerator is actually nothing but a plus b into a square plus b square plus ab. A plus b gets cancelled. Now since this is an integer, all I have to find is that 3 divides a square plus b square plus ab. This becomes the only thing. This becomes the only thing. Okay? This becomes the only thing that is to be looked. This becomes the only thing that is to be looked. Right? Right? So this is the strategy. Now you will get 22 ordered pairs. 22 ordered pairs. Right? Let's see question number 25. Question number 25. Consider the sequence 178. This I already did in the lecture. These are basically 16856. So you just have to see what is 16856. It is 7 to the power 4, which is 16807 plus 7 to the power, or not 7 to the power, just a second, 2407 to the power 5, right? And just simply write, convert it into 2 to the power 5 plus 2 to the power 2. And what is it? 1000100. See, like 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, this. So what is this number? 32 plus 4, 36. 36th number, right? We already did this in class. Binary. Okay. In base 2 notation, digits 0 and 1 only and the places go up in powers of -2. For example, 11011 stands for this and equals number 7 in base 10. How many non-zero digits does it have? So see, like now 2019 is obviously closer to 2048, but it is 2 to the power 11, right? So you will have -2 to the power 12, which is 4096, plus -2 to the power 11. If you look closely, this becomes 2048. 48. Now you need how much? Minus 27 in subtraction. Minus 29 in subtraction rather. Right? So this is the way to approach. Okay. Now, if you see minus 2 to the power 6, it is 64. You need minus 29 in subtraction. Okay. Just a second. So, I will add minus 2 to the power 5. This gives me 32 in subtraction. Now I need 5 in addition. So minus 2 to the power 2 plus minus 2 to the power 0. So this becomes 1, 1, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So this is the number. So how many non-zero digits? 1, 2, 3, 4, 5. 5 non-zero digits are there. Pure hit and trial again. Can I say that this is pure hit and trial? This is pure hit and trial. We were just adjusting the numbers. Right? Now, let n be the number of all natural numbers n such that n is divisible by a prime number p which is greater than root n. Prime number p is greater than root n. Oh, that's strange. And p is less than 20. What is the value of n? Damn it, man. So see, like prime number, let's take p as prime number, sum of all natural numbers n such that, and p is less than 20. So p can be 2, 3, 5, 7, 11, 13, 17 and 19. Right? And what it is saying, n denote the number of all natural numbers n such that n is divisible by a prime number p which is greater than root n. Right? So can I say that p square is greater than n? Right? Right? P square is greater than n. So in all these cases, I have to solve this inequality. So if p equals to n less than 4, right? So what is the possible value of n? Obviously p should divide, so n is 2, right? N is 2. Okay. If p is 3, n is less than 9. This gives me n equals 3 and 6. If p equals 5, n is less than 25. So this gives me 1, this gives me 2, this is giving me 4. If p equals 7, n is less than 49. So 7 multiples. So n equals 6. So basically if you see, this is 2 square minus 1, this is 3, oh no, this is 1, oh, what is it? This is, this is 2 minus 1, this is 3 minus 1, this is 5 minus 1, this is 7 minus 1. So I simply have to add these prime numbers, but 1 is common in all. No, not 1 is common, 1 is not common in all. Because these are multiples of 7. There will be some common numbers. There will be some common numbers, I guess. Right? There will be some common numbers. For example, in this case, I don't think there will be any common. I don't think there will be any common number here. 36. Let me just do it. 36, 24, 60. 60 and 70, 77 minus 8 is 69. 69 is what I am getting. Let's see what is the answer. 69 is the answer. Right? Because nothing will be common here. 69 is the answer. Okay. Now what it is? ABC is a distinct positive number. A, B, C be distinct such that B plus C minus A, C plus A are all perfect squares. Largest possible value smaller than this. So B plus C minus A is P square. C plus A minus B is Q square. A plus B minus C is R square. If I add them up, A plus B plus C is sum of P square plus Q square plus R square. right? Largest possible value of a plus b plus c less than 100. So if I simply take, and a, b, c are distinct numbers, so obviously b plus c minus a, c plus a minus b, a plus b minus c will be distinct, right? So if you see properly, this becomes, if I take this as s, so s minus 2a is p square, s minus 2p equals q square, s minus 2c is r square. Now without loss of generality, I am assuming a greater than b greater than c, which gives me, this is the smallest square. So if I take 1 square plus 2 square plus 3 square, this is 14. This is the smallest number, right? All I have to do is that this will give me solution, right? Which is not a problem, right? Which is not a problem, right? P square plus q square, all I'm seeing is that will it always give me a solution for all values of p, q, r? That is what my concern is. My a becomes b plus c minus p square, right? Which is, no, just a second, a becomes sum minus p square by 2. Okay, so my sum and p square should have same parity. It should have same parity, s and p square. So basically, yes. So if you see properly, if I subtract them, I am getting a equals q square plus r square by 2, right? B equals, so everything divided by 2. So q and r cannot have opposite parity, right? Either all of them, either all PQR should be odd or all PQR should be even. This is what I am getting. So let's do this. 1 square plus 3 square plus 5 square is how much? 29, 30, 39. 3 square plus 5 square plus 7 square, how much is it? 49 plus 9, 58. 58 plus 25 is 53. Oh, sorry, 83. This is the max I can get, which is less than 100, right? 49, 74, 9, 83. Okay, now let's do this. 2 square plus 4 square plus 6 square, 36. In fact, is this the max I can go? Yes, this is the max I can go. 64. Now what about this? 64, 16, 84. I think 84 will be the maximum value. I think, no, it is not recorded. It is not recorded. It is not recorded, guys. It is live. Debarga Roy, it is live. Right? So, my a plus b plus c is p square plus q square. But like, see, like I can do like this also. 1 plus 9 plus 9, 81. 91 is the max. 91 is max. 91 is max. Right? 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 Okay. I think there is some error in this, otherwise it's a very simple question. Consider the set E of all positive integers n such that when divided by 9, 10, 11 respectively, the remainders are in order greater. And see like this, so like these questions are repeated. You can see it, right? Now what it is saying, all greater than 1 and form a geometric progression. So 4, 6, 9 are possible remainders, right? 1 cannot be the remainder. 2, 4, 8 are possible remainders again, right? So this is a question which is not a bonus, I guess, right? 4, 6, 9 is also 1. So this this was also bonus, right? Because largest n can be anything. Again, largest n can be anything, right? Because again, this will give me a solution using Chinese remainder theorem, and the largest can be anything. So this was also bonus. Now, for n greater than equal to 1, let an be the number beginning with n 9s followed by 744. Right? Example A4 is 9999744. Define Fn, maximum of m belongs to n such that 2 to the power m divides an. Okay. What it is? See, like everything is 2 only, right? Everything is 2 only. Any number of 9s see, if I have, now let's write Fn denote A1, right? Let's write A1. A1 is 9744. Okay. So if I see 96, 144, it is 2 to the power 4 into something. It is 2 to the power 4 into 3, 144, 0, 9. So f of 1 is 4. Basically, see, like we are asked highest power. Now A2 is 99744. Right? Right? Oh, this is interesting now. This is interesting. If you see, this becomes 9000, 90,000 plus 9744. Now, it was divisible by 16. This is also divisible by 16. And this is only divisible by 16. Now, look at it very, very carefully. This is only divisible by 16, right? This is only divisible by 16. It cannot be divisible by 32 because this is odd number. Only 4 zeros are here. And since if I take common 16 here, this is odd plus this is odd. Now this can give me anything now, but odd plus odd is even. I can say it is divisible by 32. It can be divisible by 64 also. I think I'll have to calculate each and every one. I have to calculate each and every one. There is no pattern here. There is no pattern here, guys. There is no pattern. So we just have to calculate each and every one. So what is the answer? I am just simply writing the answer here. 75. 75 is the answer. Right? A number n in base 10. See, like the rules is very simple. You have to pause the video. You have to attempt if you have not already attempted it. I hope you have attempted the questions. Then you will see my solution. A number n in base 10 is 503 in base b, which means 5b square plus 3 and 305 in base b plus 2. B plus 2 whole square plus 5. Right? This is the equation and this is how you will get the b. What is the product of digits of n? So let's find. First of all, we will find base b. So what is this? 3b square plus 4b plus 4 plus 5. Okay. 5b square plus 3. So that's 2b square. 12b is minus 12b plus 3. What is it? 12 plus 5 is 17 minus 14. So it's b square minus 6b minus 7 equals 0. So b is 7. B is 7, guys. Okay. So b plus 2 will be 9. So what is this number? 5 into 7 square plus 3. This is the decimal number, right? So this is 49 times 248. So 248 is, the product is 2 times 4. It is 64. 64 is the correct answer. I hope I am making sense, right? I hope I am making sense, right? Sir, please request, answer the question, Hindi, Prashant Jain or English course, which see like English course is live, right? But if you are comfortable in Hindi, you should focus on the lectures which we are premiering on Friday. I've already told this thing multiple times. Like skip PNC, I would say. Don't skip geometry because geometry will have lot of problems. Okay. Done. Let's move on to the next problem. What is the least positive integer by which 2 to the power 5, 3 to the power 6, 4 to the power 3, 5 to the power 3, 6 to the power 7 should be multiplied so that the product is perfect square? Product is perfect square. This is a product. So first of all, identify full powers of 2. So say like this is already a perfect square. This is already a perfect square. So just remove these two. Okay. So you have 2 to the power 5, 5 to the power 3, and then 6 to the power 7. So just write 2 to the power 12 here. Remove this as well. Then 3 to the power 7. You simply have to multiply by 50 to make it a perfect square. To make it a perfect square, you simply have to multiply it by 50. Isn't it? Content wise, both the contents are same. Both the contents are same. If the person is same, the content will be same, right? Right? Perfect. 15 is the correct answer. Now, a 5-digit number in base 10 has digits k, k plus 1, k plus 2, 3k, k plus 3 in that order from left to right. If this number is m square for some natural number m, find sum of digits of m. Right? Right? So, see, it is a 5-digit number. So, 10 to the power 4 into k. This number is this. Right? 10 to the power 3, k plus 1. If I write it in expanded form, right, plus k plus 3, right, this is the number. Okay, this is the number n. Okay, and it is a perfect square. So first of all, evaluate it. This is 10,000 k plus 1000 k plus 1000 plus 100 k plus 200 plus 30 k plus k plus 3. So I can say that this is 10,000 plus 1000 k. This is 1 1 1 1 1 1 3 1k plus how much? 10203, right? 10203. Okay, 10203, isn't it? Are you getting my point? Are you getting my point? Which lectures of you complete sequence and series and quadratic equation? See for my JEE lectures. Right? Okay. Now this is a perfect square. This is a perfect square. Okay. This is a perfect square. Now just see, k can be what can be k? K can be, see like k is a digit, right? K is a digit. So k can be 1. Then this become 1, 2, 3, 1, 2, 3. In fact, we should not have done all these things. It's a very simple case, right? K has a very limited value. 1, 2, 3, 3, 6. This is one number, right? If k is 2, 2, 3, 4, 6, 5, it is rejected. It cannot be a perfect square. Then 3, 4, 5, 9, 6. Right? So this can be a perfect square. This can be a perfect square. Right? This can be a perfect square. This can be a perfect square. So just see if it is a perfect square. 1, 2, 3, 3, 6. uh, how do you do it? This, like this, 1, 1, 11, right? 1. So it can be a perfect square of 114, right? 114. So it will be how much? 4, 5, 6, right? Into 114, 114. So this becomes 12996, 12996. So this is not, this is the number, right? This is the number, and you just have to simply factorize it. I think 34596 is the number. 34596 is the number, right? Now you have to take square root of it, right? Take square root of 34596, right? So 1, right? 245. Then 1, 2, 3, 5, 7. What will be? What it will be? 29. Nines are 261. 28 eights are 204. 6. 224. Right? 3, 6. What is it? 2196. Right? I think 186. 366 into 6. Right? 6, 3, 9. Yes. 2196. So it becomes 186. M becomes 186. You know how to calculate square root, right? You know, guys, how to calculate square root, isn't it? You know how to calculate square root, right? I just assumed that you know how to calculate square root. Okay. Perfect. Perfect. 15 is the correct answer. If you add the digits of 186, it will be 15. Find sum of all positive integers n for which 2 to the power n mod 2 to the power n plus 5 to the power n minus 65 is a perfect square. Right? Again, this is IOQM 2021. Mod 2 to the power n plus 5 to the power n minus 65 is a perfect square. Okay. Mod 2 to the power n. Right? So, let's calculate F1. 7 minus 65 is 58. F of 2, 29, 36. F of 3, it will be F of 3 is, then it will be positive only. 125, 125 plus 8. Plus 8 is 133 minus 65, right? So it will be 68. F of 4, 16 plus 625 minus 65 is 576. F of 5, right? If I do F of 5, 32 plus 3125 minus 65, unit digit will be 2, right? So, if I see closely, the unit digit of this is always 0. So, n can be either of the type 4n plus 2 or 4n, right? 4k plus 2 or 4. Because the unit digit cannot be 8. So, for example, in any perfect square, unit digit cannot be 8. Okay. 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 So, this is one reasoning. And then the next reasoning is, which we have to do, like if you take f of 6, just take f of 6. It is 64 plus, what is 5 to the power 6? 5 to the power 6 is Just a second. 5 to the power 6 is 15625 minus 65. This becomes, eventually I'll get 4 here. 15560 plus 64. 04 24 65 15624. 15624. Yes. Would have simply 64 minus 65 is 156. So obviously it's not a perfect square. Find sum of all. See, like basically I think only this and this 2 and 4 will be the answer. 2 plus 4. Obviously we'll have to do some reasoning. Right? I think we have to do some reasoning to it, but this is largely the answer. Just a second. Yes. I'm just, yes, this is the 36. Which problem was it? I think it's chapter number 4. I'm just finding the answer key. Yes. Yes, this is the answer. 6 is the only answer. Correct. Now, moving on. The product 55 into 60 into 65 is written as product of 5 distinct positive integers. What is the least possible value of largest? See, like it is written as product of 5 distinct positive integers, least possible value of largest of these integers. Right? So let's 11 into 5, 12 into 5, 13 into 5. Right? Now 11 and 13 will be together for sure. Right? Then we can have 12. So one possibility is to have 1 and 5 into 11 into 12 into 13 into 25. Right? 5 into 11 into 12 into 13 into 25. Right? This is one possibility. Okay. Now, can I reduce this number? That is my whole concern. So, if I take 4 from here, right, and take 5 from here, so I get 15. So, 5 into 11 into 13 into 15 into 20. Right? Basically, this is 300. This is my largest number. I don't think I can go lower than this because these three are anyway prime numbers. Right? These three are anyway prime numbers. I don't think I can go lower than this. So 20 is minimum of the largest value. 20 is minimum of the largest value. Right? Perfect. See, like in this problem, like it has to do with congruence. So you have to take these two cases, right? And then you have to analyze the last two digits, right? It has to do with last two digits. In this case, last two digits have to be seen. The last two digits after some time, it will be such that there will be no perfect square of this of those possible combinations. Okay, got it. Right? How many numbers have exactly four positive divided factors, right? Are also considered as factor of n. So basically, this we have already done. It is either of the type PQ or PQ, right? So how many two-digit numbers? So it will be 3 to the power 3, 27. This is the only number which has four divisors and which is of two digits, right? Other than that, it should be product of two primes. So with 2, you take 5, 7 until 47. With 3, you take 5, 7 till 31. With 5, you take 7, 11, 13, 17, 19. With the 7, you take till 11 and 13. Right? That is it. That is it. So in total, there are 30 values. In total, there are 30 values. 29 from here, 1 from here. Okay. It's a very simple thing. It is very simple thing. Perfect. 30 is the correct answer. Yes. Now, let's see this. For a positive integer n, let n denote the perfect square integer closest to n. For example, 74 is 81, 18 is 16. If n is the smallest positive integer such that 91, 120, 143, 180, and then this is n, is 91 into 120 into 143 into 180 into n. Right, this is given. Find sum of squares of digits of n. Okay. So see, like, what is this? This is 100. This is 121. This is 143, right? This is 144. It will be 169 into this, right? So we have to evaluate it first, right? What are we getting? So see, this is 11 square and 13 square. So I have 13 here and 13 here. So 7 into 13, 11 is getting cancelled and I am left with only 111. Okay, I am left with only 111. Yes. Yes. So I have 7 here and then two zeros are cancelled with this 100. Okay, 112 is cancelled with this 12. So what do I have? This 12 is cancelled with this 3. So I have 22n is equal to 21n. Okay, and this is a perfect square. This is the nearest perfect square. This is the nearest perfect square. So see now, it has 3 and 7. Right? It has 3 and 7 and it has 11 and 2. So obviously this n, 22 will divide this n for sure. 22 will divide this n, right? 22 will divide this n for sure. And this perfect square will have 3 and 7. So obviously, if I simply assume it to be 441, and now I have to go nearer to 441 so that I have 22 in with me. So what is 484 minus 22 is 462, right? So if I just simply write it as 462, if n is 462, right, then what do I have? Right, the nearer square is 440, 22 into 441, right? 441 is nearer. This is 21 and 21 2 is this. So n is 462. N is 462. This is pure hit and try. Do you see this is why 22 will divide n? See, like this is 22 and this is 21. So 22 cannot divide 22. 22 cannot divide 21. So obviously 22 has to divide this. Right? So 4 square plus 6 square plus 2 square. It is 54. Right? It is 54. The answer is 54 here. Okay. Okay. Perfect. Now, a natural number n is said to be good if n is sum of r consecutive positive integers. For some r, just a second, what is this question? For some r cube 2, find the number of good numbers in the set 1 to 100. For some r greater than equal to 2. This is r greater than equal to 2, right? A natural number n is said to be good if n is, just a second guys, just a second. Yes. Sorry guys, I got an urgent call. Okay, a natural number n is said to be good if it can be written as sum of r consecutive positive integer for some r greater than or equal to 2. Find the number of good numbers in the set 1 to 100. Right? Now, if you see, if I take r equal to 2, the minimum sum which I can generate is 3. Then next is 5. Next is 7. So all odd numbers are my, basically good numbers. Okay. So I can clearly see 1 and 2 are not good. 1 and 2 are not good. 1 and 2 cannot be generated like this. If I take r equal to 3, 1 plus 2 plus 3 is 6. 2 plus 3 plus 4 is 9. Now you can clearly see here, it is an AP with common difference 3. So 6, 9, 12. So you can see here that all the numbers are of the type 4k, in fact 6k, can be generated. All multiples of 6. So see, like odd is anyway not a problem. Odd is anyway not a problem. So if I take r equal to 4, 1 plus 2 plus 3 plus 4 is 10, then 14, 18, 22, right? Like this. Okay. So only numbers which will be missing are 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and 2 to the power 6. So these 7 numbers cannot be generated. So answer is 93. 100 minus 7 is 93. Only 2 to the power numbers cannot be generated like this. Sum of consecutive numbers. Sum of consecutive numbers. Okay. Sum of consecutive numbers. The answer is 90. Yes, Shubhajit Paul, you are right. Shubhajit Paul, you are right. Now moving on. 93 is the correct answer. Yes. Positive integers a, b, c satisfy ab upon a minus b equal to c. What is the largest possible value of a plus b plus c not exceeding 19? 99. So see, like this question I solved. It is a very simple question. 1 by c is equal to 1 by b minus 1 by a. So basically you just have to write 1 by a plus 1 by b equal to 1 by c. In fact, 1 by a plus 1 by c, 1 by a plus 1 by c equal to 1 by b. Right? 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 Okay. Okay. Now, I can see here that 1 by 3 plus 1 by 6 is 1 by 2. And that simply I have to multiply. This is 11. I have to multiply it by 9. So what am I getting here? 1 by 27 plus 1 by 54 is equal to 1 by 80. So what is a plus b plus c? It becomes 99, which is the maximum possible value which is allowed. So my answer is 99. So my answer is 99. My answer is 99. Okay. My answer is 99. Find the number of pairs AB of natural numbers such that B is a 3-digit number. A plus 1 divides B minus 1 and B divides A square plus A plus 2. Now, this is a quadratic equation question. To be honest, this is a quadratic equation question. Find the number of pairs AB of natural numbers such that B is a 3-digit number. A plus 1 divides B minus 1. Right? So, A plus 1 is equal to K times B minus 1. In fact, B minus 1 is K times A plus 1. And B divides, and A square plus A plus 2 is equal to K1B. Right? K1B. This is given to me. Okay. Now what I will do here, A square plus A plus 2 minus K1B equal to 0. Right? Right? And if I write B, in fact, I already have two variables here. Just a second. So if, let me write it as a square plus a plus 1 as 1 root minus 1 okay is k1b minus 2. This gives me a into a plus 1 is equal to k1b minus 2, right? Now I can see here, see like what a plus 1 divides b minus 1, right? So I am seeing here that a plus 1 divides this. So if I take this k1b minus 2 as multiple of, right, this is b minus 1, right? If I take it as b minus 1, some multiple of b minus 1, then I will be good to go. Nonetheless, I have b to be a 3-digit number, right? B is a 3-digit number. So see like how I did it, it is a square plus a plus 2 minus k1b is equal to 0, right? Right? Now let's eliminate b from here, right? So I have a square plus a plus 2 minus k1. What is b here? K into a plus 1 plus 1 equal to 0, right? Then I will have a square plus a. Now k1k is another variable. It can be taken as k2a minus k2a plus 2 minus k1, right? 2 minus k1. Now this equation has integer roots. This equation has integer roots. So the discriminant will be perfect square. Discriminant will be a perfect square. This discriminant will be a perfect square, right? Right? So 1 minus k2 square minus 4 into 2 minus k1 is equal to q square. So basically, I think we should deal it in quadratic, right? I'll deal this in quadratic. When we do the PYQs of algebra, we'll do it there. Because this is a typical quadratic. No, this was not bonus. This was not bonus. We solved it, I remember. I distinctly remember us solving it, right? So we'll solve it in the quadratic. Okay, nonetheless, 42. Yes, this was another interesting problem. Greatest integer of n, greatest integer, square root, right? For any real number t, suppose that n is the greatest integer such that greatest integer of, what is it written here? Square root of is 4. Now this means that this value, square root of, we have to go very slow here, lies between 4 and 5, right? Which means greatest integer of lies between 16 and 25, right? Which gives me square root of greatest integer of root n to be between 16 and like my greatest integer can be 20 till 25. So this is it, and then I have to square it. So greatest integer of root n 256 625, right? So that again n is 16 to the power 4, 25 to the power 4. This is the number. Right? So my n max is 390624, which is this minus, just this minus 1. So what is the sum of digits of this? 12, 8, 24. 24 is the sum of digits. So see, like there was one particular year, I think this is the first year of IOQM, of the name IOQM. In fact, IOQM was in 2021 also. But in this paper, IOQM and INMO were together. There were some 7-8 problems of IOQM and it was ISI pattern. It was ISI pattern, right? It was ISI pattern of the format. Like it was of the format of ISI, in which there were 8 problems, 8-9 problems, objective problems, and then subjective problems because of COVID. Okay. Now IOQM 2023. Let's do this problem. Let n be a positive integer n such that n lies between 1 to 1000. Let mn be the number of integers in the set xn. Let a, mn, maximum and b is the minimum value. Find a minus b. Okay. N is a positive integer. Let mn be the number of integers in the set. Right? Okay. So for example, see, like if you take x1, you will have root 5, root 6 till square root of how much? Square root of 1004. Okay. This is your x1. Right? Let mn be the number of integers. Now, see, like basically we just have to take how many perfect squares are there, how many numbers we have in the perfect square. So let a is the maximum. Mn be the number of integers. Okay, got it. So see, like the maximum number of integers will be in this because it has a square root of 9 till a square root of 961. So it has 3, 4, 31. So these are 29 integers, right? The minimum will be in x thousand. X thousand. What is it? 4001. Because see, like the difference between consecutive perfect squares increases as we increase the number. And if you see, these are basically 1000 numbers. So now in these 1000 numbers, if you see, 4096 is perfect square of 64. Then 65 is 4225, 65. 66, what is 66 square? 66 square is 66 6 are 396. So this is 4, 3, doesn't matter actually. 38, 69. 70 square is, this is 70, still 70. So it has till 64 till 70, right? Because 71 square is, 70 square is 4900, 71 is 5041, 5041. So this is 7. So the maximum value will be 29, minimum is 7. So 29 minus 7 is 22, right? It is totally game on interpretation. How do you interpret this? Basically, you have to understand that behind these, under these square roots, there are 1000 consecutive numbers. So obviously, more perfect squares can be achieved by having smaller numbers here. So the smallest set will have most number of perfect squares, right? So 22 is the correct answer. This is log. Okay. So if you see properly, this is t, this is 6 by t is equal to 5. So t square minus 5t plus 6 is equal to 0. So t is equal to 2 and 3. What is t? Log b to the base a is 2 and 3. So a square is equal to b, or a cube is equal to b. We have to consider these. We have to consider these examples. And we have to take till 2023. So how many distinct cases will be there? right? 54 cases. We have to take these two cases into the consideration. Okay. Next. Okay. Now let alpha and beta, see, like we found that we observed there was one more problem like this in the previous session. Let alpha and beta be positive integers such that 16 by 37 alpha by beta 7 by 16, right? Find the smallest possible values of beta. So first of all, what you have to understand here is, right? What you have to understand here is 16 into 16, see, like 16 into 16 is 256. Now what is 37 times 7? 9, 259, right? 259. 37 times 7 is 259. Okay. Okay. So, see, like what I have to do, 16 beta minus 37 alpha is less than 0. I have to see like this, 16 beta minus 37 alpha is less than 0, and 16 alpha, just a second, no, 16 beta, yes, this is correct, 16 alpha minus 7 beta is less than 0. Okay, and alpha and beta are obviously positive integers, right? Alpha, beta are obviously positive integers. So with this, I can say that beta, and we have to find minimum possible, beta is less than 37 alpha by 16. And here I am getting beta greater than 16 alpha by 7, right? So let's assume that I take alpha to be 112, right? Then beta comes out to be greater than 256 in this case, and alpha beta comes out to be less than 259 in this case, right? So there will be a possible beta here, which is 257 for alpha equal to 112, right? For alpha equal to 112. But then there is a problem. There is a problem here. The problem is less than 0. The problem is, the answer is, in this case, see, like the answer is, now if I take beta to be 258 and alpha is 112, I can actually divide them to get how much? This becomes 129 and this becomes 56, right? 56 upon 129. This proportion will satisfy this, but this beta can be further reduced, right? This is 43 into 3. This is 8 into 7, right? Right? So beta, see, like beta is between 16 alpha by 7 to 37 alpha by 16. But how do we solve it? How do we solve it? How do we solve it like this? Then see, like we have to do hit and trial only. We don't have any other option. What will we do? 16 alpha minus 7 beta equals minus 1. We'll put this, right? Right? This is in this equation. And then 16 beta minus 37 alpha, we'll try to minimize. We'll try to minimize this. Now, this is again Bézout lemma. This is again Bézout lemma. This is odd. 16 alpha, just a second. I need this to be 1 minus 1, right? So, what am I getting here? 7, 14, 21, 28, 35, 42, 49. Yes. So if I take 16 times 3 minus 7 times 7, I will get minus 1. So 3 and 7 are one solutions. Okay, now look closely. The next solutions is when I add 7 here and I add 16 here. 23, right? So 10 and 23 are solutions. And also have a watch on this. This should be minimized in one of the solutions, right? So see, like, this is alpha, this is beta. If I'm putting alpha equals 3 and beta equals 7, this is 112 minus this is 1. So this is a perfect solution, right? This is a perfect solution. Now, if I see here, 23 times 16, what is 23 times 16? 16 threes are 8, 16 twos are 32, 368. Now the difference is minus 2 here, right? I want it to be negative, right? My 16 beta minus 37 alpha should be negative. So this is acceptable. So if I somehow get minus 1 here, that will be my answer. If I somehow get minus 1 here, that will be my answer. Adding 7 more, 17 and 16 here, 39, right? So now 16 into beta is 39 times 16. So strange, man. 16 nines are 44, 16 threes are 48, 624, 37 sevens are 17 sevens are 629. So now this is becoming negative. I think this is the minimum case. 10 by 23 is the minimum case. You cannot have lesser difference than this. 10 by 23, I guess, right? 10 by 23 is the minimum case, because then your differences are increasing. Your differences are increasing if you see, right? So minus 2 is the minimum case. So 10 by 23 is the answer. 46, right? 23, like I said. Okay. Now, find the number of triples ABC of positive integers such that AB is prime. Okay. AB is prime. So A has to be 1, obviously. BC is product of 2 primes. ABC is what it is. Just a second. I think there is some interpretation problem here. A, B, C are digits, is it? ABC is a 3-digit number, right? ABC is product of A and B and C. This is a product, right? Now A into B is a prime, so obviously A or B has to be 1. Okay, A and B has to be 1. BC is product of 2 primes, so it means B and C will be prime, right? So A is definitely 1. B and C are prime number 1, B and prime number 2, right? So it will be 2 into 3, 2 into 5, 2 into 7, 2 into 11, 2 into 13, right? This is 1, 1, 2, 3, 4, 5. And BC can be exchanged. BC can be exchanged, I believe, because it's like ordered triplet. A is definitely 1, BC can be exchanged, right? BC can be exchanged. Right? So A is 1, B, P1, P2, correct. So 10 cases accordingly here. Then 3 into 5, 3 into 7, 4 cases here, because it can be exchanged. So 14 triples here. And now when A is prime, B is 1. So then C becomes product of 2 primes, right? C becomes product of 2 primes. Okay. Okay. So then if A is 2, C can be 6, 10, because the product has to be less than 2, 14. 3 cases A. If A is 3, oh, their product is not divisible by any. So no prime number can be repeated. No prime number can be repeated. So if A is 2, C will be either 15, which is one case only. If A is 3, then C will be 10 and 14. Oh no, only 10. One case. Right? 2 into C is 30. 2 into 15, 30. Because 2 into 3 into 5. 2 into 3 into 5. In this case, there are 2 cases. Right? And then when A is 5, C is 6. One more case. So total 17 cases are coming. 17 cases are coming, I think. Yes, 17 is the correct answer. 17 is the correct answer. 17 is the correct answer. Okay. Now what it is? A positive integer n has the property that m square is expressible. Now this is very simple question, right? Okay. In integer, find the maximum possible value of mod m minus n. Right? So we have to make it into a perfect square. So can I write it like this? 4m square, 16n square, in fact 16. 16m square, 64n square minus 40n plus 256. Why I am doing this? Let me tell you. This is 8n whole square minus 2 into 16, right? This is 80. I have multiplied it by 16. 2 into 8n into 5 plus 25 plus 231. So this becomes 8n minus 5 whole square plus 231. Our whole aim is to represent it as difference of two squares. 231. Okay. Okay. Now this is 21 into 11. So 16m plus 8n minus 5 becomes 21. 16m minus 8n plus 5 becomes 11. If you add them, m becomes 1, n becomes how much? Oh, this was 4m, sorry. 4m square, right? 4m plus 8n minus 5 becomes 21. 4m minus 8n plus 5 becomes 11. If I subtract them, I am getting, if I add them, I am getting 8m equal to 32. So m equals 4. Then 8n minus 5 becomes 5, which gives me n, which is a fraction, which is not possible, obviously. So this becomes, if I take it as 33 into 7, let's take 33 into 7. Because the difference, what is their difference should be? Their difference should be of the type 8n plus 2, 8n plus 10, which is 8n plus 2. This difference is 26, which is 8n plus 2. Yes. So 4m plus 8n minus 5 equals 33. 4m minus 8n plus 5 equals 7. If you add them, 8m becomes 40, m becomes 5, 13, 20, 13, 18. Again, this is not acceptable. So we have to do hit and trial basically, right? We have to do hit and trial. Basically here, this is what it is, right? 7 into 11 into 3, this which is okay. So M. So see, like eventually M will be 10 and N will be -4, right? So this will be 14. Basically, you have to do hit and trial, different permutation and combinations, right? So 14 is the correct answer. Yes. Now let's do it. For n belongs to natural number, let Pn denote the product of digits in n and Sn denote the sum of digits in n. Consider the set A, n belongs to natural number, square free, and Sn is a proper divisor of Pn. Find the maximum possible number of digits of numbers in A, right? Now what it is written, for n belongs to n, let Pn denote the product of digits in n, Sn denote the sum of digits of n. Consider the set A, n belongs to natural number, such that product is non-zero, which means no digit of n is 0, is square free, and it is square free. Okay, square free means it has no square divisor, so all digits are different. Basically, Sn is proper divisor of, sum of digit is proper divisor of Pn, right? Find the maximum possible number of digits in numbers in A. Hush. Maximum, see, like if it has, let's say, more than 5, 6, 7, 8, 9. This is the maximum possible number of digits which it can have, but still its product will have a square. So basically, we have to construct it. If I'm taking 1 here and I'm taking 2, let's assume, I cannot take 4, I cannot take 6, I cannot take 8, right? If I'm taking 3, I cannot take 9 as one of the digit because it is square free. It is square free, right? 1, 2, 3, 4. I can definitely take 7. I can definitely take 5. So 1, 2, 3, 5, 7. Yes. So basically all prime numbers I can take. Okay. Now what is the sum of digit of this number? It will be 1 plus 2 plus 3, 6. 6 plus 12 is 18. Right? But the problem is the product here. See, like the sum is becoming 18, which is okay. But the product is not divisible by 3. So this Sn will not divide this product. So we cannot have a 3 here. In fact, if I reduce 3 and take n 9 here, let's assume. What is the sum of digit now? What is the sum of digit now? 9 oh, it has to be square free. So it can be 3 only. Okay. So I think I will have to take only and only 4 digits. Right? 1, 2, 3, 6, 13. And I cannot take 7, 11, 13. So some permutation of this can be maximum. I think 4 digits, right? I think 4 digits. I can take only 4 digits. One can be oh, there can be infinite ones, right? There can be infinite ones, right? And 2, 3, 5, 7. So now let's do one thing. Find maximum possible number of digits and maximum possible number of digits. Okay. See, like the product is 18. If I take any this thing, so what is the product? 7 5s are 35. 35 6 are 210. Right? This is product. And if I keep on increasing 1 1 1 1 1s, right? Right? Now the product of digit is fixed, right? What can be the sum of digits? So now 105 can be the maximum sum of digit, right? So what is it? What is the sum here? 7 plus 5 is 12. 7 plus 5 is 12. 12 plus 6 is 18, right? I have 18 here, right? Now I can take, these are the 4 digits. See, what is it? 5 plus 12 is 17, sorry. So I can use 88 ones so that my sum becomes 105. Sum of digit becomes 105. And 105 will then divide 210. So 88 ones plus 4 these digits. So it can have 92, maximum of 92 digits. Maximum of 92 digits it can have. It can have maximum of 92 digits. Right? Because it is a written proper divisor. So it cannot be 210. Sum of divisors, sum of digits cannot be 210. Okay. So 92 is the correct answer. Okay. So in the land of binary, the unit of currency is called ben, and currency notes are available in denomination 1, 2, 2 square, 2 cube, bens. The rules of the government of binary stipulate that one cannot use more than 2 notes of any one denomination in any transaction. For example, one can give a change of 2 bens in 2 ways. 2 1 ben notes or 1 2 ben note. For 5 ben, one can give 1 ben note and 1 4 ben note, or 1 ben note to using 5. Now this is, and 2 using 5 1 ben notes or 3 1 ben notes and 1 2 ben notes, or a 5 ben transaction is prohibited. Okay. So basically using 5 1 ben notes is impossible. 3 1 ben notes is impossible. 1 2 and 1 2 is prohibited because you cannot use more than 1, more than 2, right? Find number of ways in which one can give change of 100 bens without following the rules of government, right? So 100, obviously 64 plus 32 plus how much? 64 plus 32, 96 plus 4. Okay. So one can give 2 to the power 6, 2 to the power 5, 2 to the power 2, right? Now if somebody has to use 2 to the power 5, 2 to the power 5, 2 to the power 4, 2 to the power 4, this is also okay because you cannot use more than 2. So I have just used 2, 2 to the power 2, 2 to the power 5, 2 to the power 5, 2 to the power 4, or no, sorry, 2 to the power 6, 2 to the power 4, 2 to the power 4, 2 to the power 1, 2 to the power 1. This is also 100 only, right? And then 2 to the power 6, 2 to the power 5, 2 to the power 1, 1, 1, right? 2 to the power 5. So yeah, it can have many cases, right? Like this. It can have many cases. I can clearly see, right? And we just have to manually count it. So in total there will be 19 cases, right? Basically you have to split powers into, right? 2 to the power 6 into 2, 2 to the power 5 into 2, 2 to the power 4 into 2, right? Like this. That is what you have to do. Okay. Okay. 19. Perfect. Now, a positive integer n greater than 1 is called beautiful if n can be written in one and only one a way as n this equal to this. For some positive integers a1, a2 this, where a is greater than 1. For example, 6 is beautiful because 6 is equal to 3 into 2 into 1, and this is unique. But s is not beautiful since, okay, Find the largest beautiful number less than 100, right? Now this is pure hit and trial, right? So if you see, you can use 1 many times, right? So we'll start with 99. 99 can be written as, so what is 99? 9 into 11 into, see, like it can be written as 9 into 11 into 1 into 1. This is so many times so that the sum becomes 70 here. And but it can be written like this also, right? So there are two ways. So 99 cannot be represented like this. So basically, your number should be product of two prime numbers only. Two prime numbers only. 98 has 2 square, 7 square. 97 is single prime number, which is a problem, right? 97 is a single prime number, which is a problem, right? 96, obviously, no. 95 is the biggest number because 95 is product of two prime numbers. 95, yes. So 95 is product of two prime numbers. Okay. Now the last question. We are solving till 2023. Let dm denote the number of positive divisors of positive integer m if r is the number of integer for which this is sigma, this is odd, then find the number of digits of r, right? Okay, let's see. Now this sum is d1 plus d2 plus dn, right? Right? Now let's calculate s1. S1 is d1, which is 1. So r equal to 1 is okay. S2 is d1 plus d2. It has two divisors, 3. So r equal to 2 is okay. S3 is d1 plus d2 plus d3. Again, so r equal to 3 is okay. But when you see S4, 4 is a perfect square which has 3 divisors. So S4 is S3 plus 3, which is 8. And this is where the problem begins. This is where the problem begins. Now, if I add 5, 6, all these will be even. Why I am saying? Because see, like all perfect squares have odd number of divisors. So the parity will change. The parity will change when you have a perfect square, which means S9 will now be odd. So let's see. S1 is odd, S2 is odd, S3 is odd, S4 is odd, S4 is even, sorry. Then S9 is odd till S15, right? S16 is again even, right? So you have 3 here, then you have 7 here, then you have to write, you actually have to leave. So basically, see, there will be 3 odds, 5 evens, 7 odds, 9 evens, 11 odd, 13 evens, right? This is n less than equal to 2023. So basically, you have to find sum of this AP, right? You have to find sum of this AP, right? So the R becomes 990, 990 such numbers, and 990 means the sum of digit is 80. Okay, right? It becomes 80. Okay, now see, like there are 2024 problems. 2024 paper was very easy, right? So all these problems are homework for you, and you have to write the answers of all the problems. You can find the solutions of IOQM 2024 in our playlist, right? We have solved all the problems of 2024 this year only. This was very easy, IOQM.